Hi, I'm Anna Hoffman, and welcome to the first ever episode of Learn Live. We're super excited to be joining you here today, live from wherever you are streaming today. My name is Anna Hoffman. I'm a data applied scientist on the Azure SQL team, and today I'm joined by Bob Ward. Bob, why don't you introduce yourself?
Thanks, Anna. I am Bob Ward. I'm a principal architect in Azure Data Team, famously now known as the person that presents with Anna Hoffman. That's kind of what I'm known as. So I'm here today with my partner in crime, Anna, to talk some Azure SQL. Pretty excited about it. Thanks, Anna, for having me.
Yeah, I mean, it's my pleasure, and we're so excited. This is going to be such a fun series. It's been a while since we've done this series, so I'd love to take a step back. Today, of course, is Introduction to Azure SQL, but there's actually much more than this to come. Bob, can you tell our viewers a little bit about what we're doing here, how it happened, and how it's kind of evolved?
Yeah, sure. I mean, Anna, January of 2020, when was that? That seems like an age ago. You know, we were joining forces together. I'd spent time launching SQL 19. You spent a lot of time working with Azure SQL. I started on this journey. Anna, here's a quick tip. Don't ask your boss, what can I do next? Not a good idea. Because your boss will tell you, here's what you can do next. And our boss, Assad Khan, said, Bob, I think you should spend some time in the clouds. Even though I had spent some time in Azure, take your experience with SQL Server and start assessing Azure SQL compared to SQL Server. Because a lot of people know who you are. They know you know SQL Server. They trust your judgment. They trust your knowledge. So that's what it was about. I was like, hey, I'll go assess SQL Server. And you kind of said, hey, I'm kind of working on this Azure SQL project. It'd be kind of fun if we joined forces. So that's kind of what led us to this whole concept of Azure SQL Fundamentals.
Yeah, definitely. And, when we look at the workshop that we've built, you'll hear us call it different things: the Azure SQL Workshop, Azure SQL Fundamentals, Azure SQL Bootcamp. But really, I think a big part of it was being on top of the Microsoft Learn infrastructure. And, Bob, do you want to share what's so special about Microsoft Learn? And that's that bottom left link here on the page, Azure SQL Fundamentals.
Hey, number one thing out of the gate, if you think about SQL Server, we always were able to do things for training-wise to say, hey, download Developer Edition on your laptop and just do our training, right? But as we started building Azure SQL, we thought to ourselves, how are they going to do Azure SQL without paying for Azure SQL to do our training? We'd like to offer a free thing for you, and having this sandbox environment with the Learn team together is huge. Imagine now, Anna, going to these different modules that we've talked about and trying out what we're going to show you over the next 6 weeks, and do it with not getting charged to your Azure subscription. So having that sandbox is so big. And then Microsoft Learn just has this amazing reputation for training at Microsoft. So being able to partner with them together to be on their platform and have that sandbox, I think it's just been critical and it's been immensely a part of the success we've had of all this training.
Yeah, definitely agree. And you kind of alluded to something that I'm not sure we've told everyone yet, and this is running for 6 weeks. So the next 6 weeks, we're going to be going module through module. So what you see here, and we're going to take you through all of Azure SQL Fundamentals. And we kind of think at the end of this, you might be able to pass DP300, which is our relational databases in Azure certification. So pretty exciting. And, when we look at these modules, Bob, can you tell us how we came up with this order or these modules, or why these items are what we consider the most important?
Sure. I mean, when we were doing this assessment, I was doing this assessment, you were working on Azure SQL together, we were thinking to ourselves, how do we organize this? And ironically, we had both together started working on a what to use when type session at events, which led to this idea of we got to start off in the first module and talk about what is Azure SQL. Microsoft had pivoted to this branding of this term Azure SQL. So we need to kind of set the landscape and build the foundation for what are we talking about? What's the history of this? What is it all about? Why would you choose this, right? And then for me, being a SQL Server person, I thought to myself, okay, well, what is one of the first things you do? You have to install SQL Server. And so we together thought, well, let's talk about the deployment experience. How do you deploy Azure SQL? How do you configure it? And compare those experiences with a SQL Server perspective. And then I remember throwing this term into you. We were just talking online. We used OneNote. Remember all the OneNotes we built to go design all this? I said, Anna, we got to have meat and potatoes in there. And you're like, meat and potatoes? What the heck? What is this Texan term you come up with? And it all deals with these topics in the middle, the heart of this: security, performance, and availability are three critical parts of the SQL Server database engine. So why not take the concepts in SQL Server that apply to that and tell you in Azure SQL, how does that work? And so here we are. We have our 5 modules, and we started down the process of going through all of this. And then I remember at one specific meeting, you saying, well, there's got to be a way to put this all together, right? And I'm like, yeah, what do you have in mind? And so you were the one that came up with the idea of module 6, putting it all together. So you should tell everybody, when we get to the end of 6 weeks, what are you going to have?
Yeah, it's really exciting. At the end of the 6 weeks, you're going to be able to, like it says, put it all together. We've got some really challenging, exciting case studies that are going to bring it all together. And we're going to use like a social media campaign type of style to use hashtags and try to get you all to submit your solutions to the challenges that we pose at the end of all this. So I think it's going to be really fun. I want to bring us back to today where we're going to be focusing on the first module, which is Introduction to Azure SQL. So if you go to that aka.ms link, you're going to be able to find the actual module we're going through today. So we encourage you after this session or next week or whatever to go through this actual module so you can get a little bit into the details but understand we're going to be covering some of the same content. And finally, this is live and interactive. So want to encourage you to participate, ask questions on whatever streaming platform you're coming in through. We will be taking a look at what's coming up and what's being brought up to us. On YouTube, we're getting a lot of comments already. Some people are saying, hey, this is exciting. Some people are saying, thanks for doing this. So we've got a lot of engagement already. So I'm just super excited for all of you to join us today. And let's go ahead and talk about Azure SQL. How does that sound, Bob?
Sounds like a great idea to me.
Awesome. So today we're going to be talking about Azure SQL. We're going to give you some background and history. Then we're going to talk about each of the deployment options. And we're even going to dive into the service tiers, compute tiers, and all that other good stuff you have to talk about. So you have to think about. So like Bob mentioned, this is really your what to use when type of session before we dive deeper into the meat and potatoes of Azure SQL. So I'd like to start off with this slide here. On the left, you have Ray Ozzie, who was the chief software architect at Microsoft at the time. He came to the Professional Developers Conference in 2008. So this was like Microsoft Build back then. And he got on stage and announced Windows Azure for the first time. And he did so with this slide that you're seeing here. Now, this is a really interesting slide to me because what is front and center? Microsoft SQL Services. So Microsoft SQL Services is how we kind of first made our step into the cloud. And the great thing about this and why I think it's so cool is from the beginning of Windows Azure, when you think about it, SQL Services or SQL Server has literally been at the center of our cloud. So it's evolved a lot since then, but it really started out at the center of what we were trying to do. And, Bob, over the years, I'm sure you've seen a lot of different things when it comes to Azure SQL and the evolution.
Yeah, thanks, Anna. First of all, I want to give a huge kudos to my colleagues, Anna. If you look at the bottom of these slides right here, these little dots are called breadcrumbs. So you see here, we're in the overview section. You kind of see where we're headed, right? As we go along these slides, we'll talk about Azure VM, MI, database, and comparison and summary. So what I love about this series is as we're presenting these in slide decks and slide format, every module has that look and feel. So you kind of know where we are in this discussion and where we're headed in the rest of the module. So Anna, you're right. I am a little bit of history buff. And I actually, admittedly, have been at Microsoft much longer than this timeline shows you. But I do remember being at Microsoft when all this started. And you think back to 2006, we embarked on these interesting projects at the same time. Red Dog being the Windows Azure team and CloudDB being the SQL team, saying, how do we do services for things like compute and databases? And as you just mentioned, in 2008, at this Professional Developers Conference, we announced Windows Azure and SQL Data Services. Well, sometimes it's about branding. And so in 2010, we decided to come together when we actually launched the service. This was preview in 2008 to call it SQL Azure. In fact, many people today in the engineering team, if you talk to them, still use that term SQL Azure. Windows Azure being a term back then because Windows being the top brand at Microsoft. But notice, as you look a little this timeline, like even by the time 2012 came along, what we were doing is servicing a database. And you're going to see the fruits of that in today's presentation of what is Azure SQL Database. So SQL Azure became Azure SQL Database. Now in 2013, there's a very important thing we did. And this, interesting, the timeline is because it kind of aligns when Satya Nadella came along and was in charge of our server and tools business. And that is, prior to this time, we did not have a virtual machine offering that was stateful. You couldn't run SQL Server in the Azure virtual machine environment. So the launch of this was very important for the progress of Azure SQL, because now SQL became this primary workload because you had a disk drive all of a sudden to store SQL Server data. And then you see in 2014, we decided to rebrand Windows Azure to Microsoft Azure. Now, why would we do that? Because all of a sudden now, Azure became this platform, not just for running like Windows and SQL, but we're running all sorts of different types of compute and applications. Hundreds of types of apps were now showing up in the Azure platform. So why not call it Microsoft Azure? Because it wasn't just about Windows anymore, including things like Linux VMs, right? In 2015, we had a very, very important evolution to the platform of Azure SQL Database. We call that version 12. And that involved a new paradigm and an architecture that allowed us to get a lot more predictable performance and isolation to make sure customers that want to deploy Azure SQL Database could do that in a very, very performant way. And then kind of look as we march further here. In 16, we introduced something called Elastic Pools, which we'll talk about. We introduced something called a managed instance, Project Cloud Lifter. So instead of just a database, you're going to get now a PaaS service that's a SQL instance. And we're going to talk about what is the difference today between an Azure SQL database and managed instance. And then 2019 and 20 are all about us kind of just moving the game forward with things like Hyperscale or serverless compute, or even things like instance pools. And finally, as we launched all of this last year, this branding that Azure SQL encompasses this family of infrastructure as a service and platform as a service. So Anna, it's a really long history. It's important to kind of see that evolution of what we've learned along the way. But perhaps the best way to really give everybody a feeling of what are we talking about is for you to talk about what is Azure SQL.
Yeah, definitely. And I think this is actually a good segue into the Azure ecosystem. We did get one question, and this person says, how is being an Azure SQL DBA different from being a SQL Server DBA? And I think this might be a good lead into the Azure ecosystem.
Yeah, thank you for saying that, because you're right. Before we talk about Azure SQL, what the heck is Azure? What's that experience like? So if you're a SQL Server DBA and you've never used Azure before at all, you kind of have to have an account in this service, right? You need to have an account, a subscription to do things like deploy databases or instances. And often, what are you going to use? You're going to use the Azure portal, which comes in the forms of browsers or even applications on phone devices to go in and navigate things in a graphical way. You're going to see examples throughout all of our modules about the use of the Azure portal to do various things. Now, the Azure Marketplace is a series of products and services that you can subscribe to and purchase for Azure. Well, guess what? One of the marketplace items is Azure SQL. And we'll actually talk, I think, Anna, today at the end of this, kind of this unified experience we've built on how you can go find out Azure SQL services through the Azure portal, through the marketplace. Now, if you're kind of a programming person like me, you'd like to know APIs and command line interfaces. So Azure comes with a consistent set of command line interfaces and APIs that are consistent across many different platforms and available to you. Things like Azure CLI, the Az CLI, which is available on Linux, Windows, and MacBooks, or PowerShell, or even just using APIs from a programming point of view. And so a lot of things are always based on APIs and CLIs, and you're going to find out that Azure SQL integrates and snaps into that ecosystem where we have specialized APIs and CLIs specific to Azure SQL. You're going to see this term called resource groups a lot in our presentations. And so behind the scenes, the Azure Resource Manager, or ARM, provides an infrastructure for services like Azure SQL to deploy and manage different various pieces. And so having that resource manager is critical. And usually what you see is something called a resource group, and then resources within that group as an interface to what ARM is all about. Now, Azure Monitor is a platform for monitoring, and Azure SQL snaps into that. You will see demonstrations and examples throughout our modules about how we take Azure SQL and integrate with the overall Azure Monitor system to look at things like metrics and logs going on with your deployment. One of the decisions you're going to be making is where to deploy Azure SQL. In your data center today, you have known areas where you go put a SQL instance in a virtual machine. Azure is all over the world. There's so many regions and data centers, I've lost count. So you're going to make some decisions. Where am I going to deploy my Azure SQL resources in given data centers and regions on the world, some of those decisions could be based on compliance regulations that you must adhere to in your country. And we'll talk some about that. And then finally, you would like to use this platform for a reason, and that is you would like compliance, you'd like trust, and most of all, you'd like a service level agreement. Wouldn't it be nice to go deploy an Azure SQL database and have guarantees of uptime based on agreement and a contract between what you have between us, between yourself and Microsoft? So, if you've never used Azure SQL before and you're a DBA, you need to understand these different parts of the ecosystem, because they're going to come important to understand how you are going to deploy, manage, and configure a SQL outside of the SQL environment itself. And we call these things, the Azure ecosystem.
Yeah, definitely. This is definitely like things that become, common language as you start to work with Azure. Now, when we think about Azure SQL, and we really want to get into this now, I know you guys have been watching for a while. You want to know, what is Azure SQL? What are the options? And in what scenarios do I use one versus the other? So there are three main deployments in Azure SQL when we think about it, from deploying things that run and are hosted and live in Azure. Now, the first one is SQL Server on an Azure virtual machine. And as we go from left to right through the slide, what you're going to see is, yes, you give up some control and you give some more responsibility to Azure, but what you get in return is also pretty cool. So let's start with SQL Server and Azure Virtual Machine. So in this case, it's just SQL Server running on a virtual machine. So you pick the OS, you pick the version, you pick everything that this is running on, and Microsoft takes care of the infrastructure and the hardware. So that's SQL Server and Azure Virtual Machine. A lot of times we see people using this when they need access to the OS, but we'll dive deeper into that after this. Now, the next option is what moves us into our platform as a service, or PaaS type of offering. So SQL Server on Azure Virtual Machine is an IaaS, or infrastructure as a service, whereas PaaS, or platform as a service, is slightly different. And let's talk about why. So the first option is Azure SQL Managed Instance. And you can think of this as, hey, let's abstract away the OS from you, and let's give you a managed SQL Server that is versionless. That's what you can think about with Azure SQL Managed Instance, because this is going to give you all the instance scoped capabilities that you're used to having in SQL Server. Now, if you say, I don't need these instance scope capabilities, and I want to try some of the newer things that have come to Azure SQL Database, like Hyperscale and Serverless, that's when we go one level further and say, okay, let's abstract away the server and say, I just want a managed database with the latest innovations and the greatest tech and the most opportunities for cost savings. And that's where Azure SQL Database comes into play. And today, that's the only deployment option where you can get Hyperscale and Serverless. So if we take a step back and kind of look at the spectrum, there are different ways that might land you into each of these different deployment options. And Bob, do you think it'd be useful if we kind of went through some scenarios and talked about some customers and dove a little bit deeper into this, or do you think this is good?
Well, we presented this before. It's a great overview to kind of think of left to right on my furthest control, my most control, my less control, my more capabilities. But I think what was really interesting is take this from perspective like a challenge solution. Like, what are the challenges that one of these is trying to solve? What's the solution? And what are the features and differentiators? That's probably the right way to look at it.
Awesome. Yeah. So let's do just that. And we're going to dive first into SQL Server on Azure virtual machines. So if we think about a customer challenge or a potential customer challenge or scenario, I want to migrate to the cloud as fast as possible, but maintain my OS and SQL Server functionality. So maybe you're really just trying to do this lift and shift. You don't want to upgrade. You don't want to move to versionless yet. One great example of this is if you're running on SQL Server 2008, which reached end of support a few years ago now, I think. But if you move to a virtual machine, you can get extended security updates. So this can be one reason you might decide to move to SQL Server in an Azure virtual machine.
But then let's kind of drill more to some actual functionality here. Like, what does it really come down to? So if you need complete SQL Server and operating system access, that could be a third-party app or something of that nature, this is going to be your best bet, right? You need expansive, different versions of SQL and operating systems for whatever reason. We've actually seen customers that have third-party applications that require a specific SQL version or operating system version. Or maybe you need to go to Linux specifically, or use containers. So using VMs, SQL and VMs are going to be your best option. There could be specific functionality, really, specific to your application, like you need file stream, or you need a simple recovery model database, which you're going to find out later in our modules. We don't offer that for PaaS services, but there's reasons behind that. But for whatever reason, you need that. And then you might use some of our BI services, maybe use analysis services or reporting services. And so we actually have specific VMs built for that type of functionality. But if you did move SQL Server to Azure VM, like, why would you do this versus just running VM on your own? Well, first of all, we talked about the fact it's infrastructure as a service. So we're managing all the hardware and the host and so forth. But consider, like the example Anna just talked about, free extended security updates for non-supported versions of SQL Server. Or how would you like to have some automated backup, some security update functionality? Like it'd be great if we had some of that to combine with this complete access. In other words, can Azure kind of help me along the way? Whether it's Azure Backup or accelerating my performance with like blob caching for storing Azure storage. Or wouldn't I like to go look at a study that actually said there's a return on investment here for allowing Azure to host the infrastructure, but you control most of what happens with SQL Server and the operating system?
Yeah, definitely. And one customer story that we really like to talk about when we think about SQL Server in a virtual machine is Allscripts. And the reason I like this customer is because they were able to take about 600 on-premises virtual machines and fail over using a technology called Azure Site Recovery in a matter of just a few weeks. So this included failing over their SQL Server VMs to SQL Server on Azure Virtual Machine. And this was able to be done very quickly. So you talk about moving quickly to Azure, this can be a great way to do it. And one of the interesting things is after they moved to SQL Server and Azure Virtual Machine, they started to evaluate some of the capabilities related to managed instance, and they started converting or migrating some of their instances to managed instance to take full advantage of that platform as a service capabilities. Now, we don't go into a ton of detail on SQL Server and Azure Virtual Machine for the rest of this series. So, Bob, I know our viewers would love it if you could give a little bit of a deep dive onto SQL Server and Azure Virtual Machines.
Yeah, now we had a tough choice when building this workshop out, right? If you think about SQL Server itself and those engine capabilities, those are going to be common inside the virtual machine of SQL Server itself. But I couldn't help myself. I was like, we have to give the audience some taste of what it's like to do SQL Server and VM. So let's spend some time doing that. So first of all, what about just deploying this thing? Like, what are your choices? Well, we talked about that idea of a marketplace. So this is really interesting. We will provide pre-installed versions of SQL Server and Windows and Linux for various versions out there that you can just choose from the marketplace, make a couple of choices, hit a button, and about 10 minutes or so later, a fully installed version of SQL and the OS will be available for you to use. That's kind of nice to have, right? And then you have this ability to say, I'd like to pay as I go, a subscription type model. We'll talk about it in a second. Or you actually bring your own license to the table from an existing SQL Server license. So that's one way of doing it. The other way of doing it is to say, I'd like to install an operating system like a Windows version. I do this all the time from the marketplace. And then I will actually bring the SQL bits myself. I have the bits. I can copy up the setup files and just install SQL within the deployed virtual machine with the operating system. This is an interesting mode that a lot of people don't realize. Let's say you got SQL 2012 running an environment with Windows Server 2016. I just picked that combination. Azure Migrate allows you to take the VHD, the actual VM image from VMware or Hyper-V, and literally lift and shift the VM image, the snapshot, into Azure, just kick up the virtual machine and configure from there. So that's an interesting option if you'd like to deploy SQL that way. Now, this is something a lot of people I don't think know enough of. It's important. So you'd like to take some advantages in Azure. Like you'd like to be able to use licensing that you already have, like Azure Hybrid Benefit as a possibility. Or you'd like to do these automated backups and security updates, or even see your virtual machines with SQL in the portal along with other Azure SQL assets. So there's something called the SQL IS Agent Extension. Okay, so if you use the marketplace, we just put this in there for you and you can start using it. If you install your own SQL Server, you go through a process of actually installing and registering with this. Look at the advantages of that, especially from when it comes from this licensing point of view or managing your VMs with SQL. It's not a big brother thing. It's actually just trying to help you manage the VMs you have SQL already out there. So a lot of people don't realize that. That's something certainly to take a look at to use. Now, when it comes to SQL, a lot of it's about storage and sizes. So when your environment, you're used to picking virtual machines with certain configurations of memory, CPUs, number of cores, disks. We have all those. We have virtual machine sizing that we have. We have guidance for you about picking the right VM sizes in Azure that match your SQL workload. And then you have choices to make. We're going to help guide you about putting your database and log on premium managed disks, on separate disks, taking advantage of things like read caching. We're going to help you put TempDB on the local SSD drive for maximum performance. And then we have something called Ultra for super low latency needs for performance. We have Ultra disks, things like your transaction log for, say, like in-memory OLTP might use something like Ultra. So a lot of choices there for sizing and your storage needs. You're going to have to kind of typically network this together. So we offer virtual networks in Azure. You're going to learn more about virtual networking with Azure PaaS, but the same concept can apply though for your VM, where you can integrate on-premises assets and your networks with virtual networks in Azure. And then Azure Defender, which is a new service that's kind of been out there a little bit for PaaS, we now offer this to integrate in and apply this to your SQL Server Azure virtual machine environments. We'll talk more about Azure Defender and the security module. Those concepts like vulnerability assessments and advanced threat protection can now be used for VMs. Now, high availability still matters when you're in the cloud, and we have a lot of options for you. But one thing people don't realize, when you're in our infrastructure, you now have built-in HA at the VM, at the node level. For failovers that occur, we take care of all those things for you because the VM is in Azure. But you might want to use some of our technologies like failover cluster instance or availability groups, and we have that functionality. In fact, we have specifically built functionality so those can actually work really well in Azure. And we even have some interesting scenarios we announced last year where hybrid availability secondary replicas can be done, like a DR only can be done for free with your licensing. So check out those kind of type options as well. Even things like file snapshot backups or integration with Azure Backup itself for like a complete VM SQL combination. So if you look down this list, you can see there's a lot of choices, but a lot of functionality to make your SQL and OS investment integrate well with that Azure ecosystem.
Yeah, and I think a lot of people are pretty excited about all these different options, because what we're doing is we're really giving you a lot of control and a lot of options to kind of pick how you want your backups to be done, how you want your high availability to be managed, and that sort of thing. And when we kind of look at comparing IaaS, which is what we were just talking about, infrastructure as a service, or SQL Server and Azure Virtual Machine, with your more platform as a service, PaaS type of offerings that you get with Azure SQL Database and Azure SQL Managed Instance, that choice of control and some of the configuration capabilities are a big benefit of virtual machines. And one way I like to think about it, especially when you look at things like business continuity, availability, your backups, and geo-replication, with IaaS, all of these things are going to be possible for you to configure. Bob mentioned several of these on the previous slide. However, with PaaS, or Platform as a Service, or Azure SQL Database Managed Instance, either of those options, this is more of a built-in capability. For example, and we'll talk much more about it in coming modules, but some of our architectures just actually, you deploy a specific database and we deploy an always-on availability group behind the scenes for you. So yes, in IaaS, it's possible and configurable, but a lot of times in PaaS, it's just kind of built in. And the same goes for things like geo-replication.
But there's even more. Think about scale. So when you pick those VM sizes for IaaS, you can change those, but in PaaS, we have an advantage. We could do things like auto scaling with serverless, right? Things behind the scenes where you just make some declarative choices about ranges of cores, and we'll just scale for you. What about versionless? Anna, you touched on that concept earlier about versionless. It's an important concept. Even though we can offer automated updates, which are security updates for VMs, the SQL Server engine in PaaS is versionless. Behind the scenes, we are doing everything for you to update that version of SQL Server. This has huge advantages because not only are you taking advantage of security updates that we just do for you, but if we find an important fix we need to make to the engine, we can roll this out proactively to prevent you ever seeing a problem. Or we can light up new functionality that are versionless through a private or a public preview program without installing a new major version of SQL Server. And then all sorts of built-in monitoring and intelligence capabilities can now be delivered because in PaaS, we have the ability to build and install and deploy software services that interact with your PaaS installation and help really, provide some intelligent performance and monitoring capabilities. You're going to see examples of that throughout this 6-week series.
Definitely. And so now that we've kind of compared IaaS and PaaS, let's go into some of the platform as a service offerings, starting with Azure SQL Managed Instance. Now, remember, this is kind of abstracting away that OS and giving you a managed SQL server. So some customer challenges we see is a customer wants to remove some of the management overhead. So they don't want to deal with backups or availability or some of those things. They want to take advantage of a lot of the built-in capabilities that we were just mentioning about. However, they do leverage, or some of their systems leverage, SQL Server instance scoped capabilities. So what do I mean by that? I mean things like CLR, machine learning services, service broker, database mail, DTC. I think those are some of the big ones. But those instance scope features that you think about when you think about scoping to a whole instance, or features that are only available at an instance level, this is where we find customers really landing in Azure SQL Managed Instance, because it does have support for all of those, most of the features in SQL Server today.
Yeah, and that's a great point out. And if you think about the actual key features, first of all, it comes down to the fact that this is an instance. We'll talk about something called an instance pool shortly, but I want you to think in terms when you connect with, say, Management Studio, of you looking at an instance of SQL Server that just looks like your SQL Server. That's when we say the surface area is really, really important. And actually the history behind this project is called Cloud Lifter. I remember in those days when we did that. The reason we did that is that customers were struggling a little bit to lift to the cloud an Azure SQL Database deployment because of the features and things you just mentioned. But it is a fully managed service. Things like platform service capabilities that you've mentioned already are going to be part of this thing. But another thing that we did Cloud Lifter for was native virtual network support. So at the time, we didn't have some of those capabilities for Azure Database. And so you want to be able to take your managed instance and integrate it into your virtual network, especially for an on-premises environment. And managed instance just comes with that type of capabilities. And then you also want to be able to do things like Azure Active Directory with on-premise identities. That's going to be part of this solution as well. But there's got to be, again, what are the differentiators to make this interesting for you besides having that instance? Notice this one. This is interesting. When you want to do a migration using things like database migration service, we can do almost zero downtime migration using log shipping type technology. I know we just announced even the ability to have APIs for you to control that. But yeah, we can behind the scenes use log shipping to do a almost zero downtime migration from, say, a SQL Server on premises or even an IaaS type environment. And then you're going to see later in the availability section where we're going to introduce something called failover groups, which are a big part of doing managed instance across regions. And then just like we talked about in VM, independent studies have looked at what is going to be that return on investment for you, where we're going to do more of the managing of some of the things behind the scenes. You do less managing of it, right? You don't have to worry as much about it. Are you going to get that return on investment? And Forrester's done a pretty good job of that. And then I remember putting a slide together and I thought to myself, where really is this? It's the best of SQL Server with the benefits of a managed service. That's kind of the summary, I think, of the way you should think about it.
Yeah, I think it's a great summary, and I've started saying it as well. So I'll give you kudos, but I'm also going to say that.
Right. You can steal it all you want.
Yeah, and a customer we really like to talk about when we talk about managed instance is Komatsu, because they were able to migrate a pretty sizable database with almost no code changes in just a matter of days, 1.5 terabytes. And now these aren't just marketing buff; these are real numbers. They had 49% cost reduction and 25 to 30% performance gain. So that's pretty significant. That's not just like 5 to 10%, like 49% cost reduction. Pretty significant. We're seeing a lot of adoption of Azure SQL Managed Instance. Like Bob said, best of SQL Server, the benefits of a managed service. Now, the last deployment offering we have to talk about today is Azure SQL Database. And there are lots of customer challenges that kind of lands a customer in Azure SQL Database. So let's talk about a few of them. So a lot of times we have customers that want to build modern applications. So they want to take advantage of things like cloud elasticity and also this idea of serverless. And that's something you're only going to get in Azure SQL Database today with Hyperscale and Serverless, which we're going to talk about. actually later in this session today, as well as upcoming sessions. Now, we also have customers who want to do things like manage multiple databases. So perhaps they're a software as a service provider and they have many databases and they want to do things like resource share and cost optimize. And that's also something that Azure SQL Database has a pretty good solution that's been around for years to do. But there are some other capabilities and features as well, and let's dive into them.
Yeah, and again, think about this. Your goal is to have a database. That's what you want, right? Even though behind the scenes we may dedicate an instance of SQL Server for you, and you may have some feeling of that by looking at, say, a DMV or something, the concept is you want a database, and that's the abstraction point you'd like to work with. And so the idea of a database is important, or an elastic pool, which is, of course, a series of databases, and then just alluded to. But because of the fact that you are going to work just at a database level, behind the scenes, we can offer some interesting technologies that we can't anywhere else. Things like you've already alluded to, hyperscale and serverless compute. Those are very important aspects to the promise of Azure SQL Database, and you're going to hear us talk about that in today's session and other sessions as well in these series. It is a fully managed service. In fact, it's the fullest of managed services, again, because you're doing a database. And you'll see in the security module, we're going to help try to solve some of your concerns about exposing things on endpoints on the internet by something called private link support, and we're going to offer that in an Azure SQL Database. In addition, we're going to go to the highest level of availability here in this case by being able to offer something called availability zones. And so if you look at differentiators, that kind of technology allows us to offer the highest availability of any of our Azure SQL choices here through our SLA, and quite frankly, the highest in the industry that's been published for a service level agreement of that kind of type number. That's pretty significant. And we'll talk more in availability about the entire SLA system and what does that really quite mean to you. But this was interesting. Many of you out there using SQL Server understand the terms like RPO, recovery point objective, and recovery time objective. We're the only database out there offering a service level agreement for those kind of type numbers, not just for SLA. And so just like some other studies, some people have asked me before, like, this database is interesting, but I don't really know, are you really performant? Can you really meet the needs of my application? So GigaOM did a study and looked at the performance using benchmarking to compare us to in other industry databases. And so that's something you sort of can take a look up if you're kind of wondering, like, is it possible to perform with Azure SQL Database, and what kind of costs am I going to have compared to the competition?
Yeah, thanks, Bob. And when we think about customers here, because we always like to mention a real world customer scenario, I like to talk about AccuWeather. Now, there are a lot of customers we could have talked about, but I like AccuWeather because they came to Azure SQL Database and said, I don't want to worry about managing a SQL Server, managing versions. I just want a database and I want to build modern applications. So they were able to very quickly get up and running and start building these new applications, leveraging things like Azure Machine Learning Services, Azure Data Factory, and then scale as their service either needed more or needed less compute or other services. So it's been really powerful for them to use something like Azure SQL Database. And now what we're going to do, Bob, and I know you love this section, we're going to do some knowledge check questions.
I mean, Anna, there are people right now that are just tuning in going, I thought I was just going to sit back and kind of learn from Anna and Bob. You're going to test them?
Oh, yeah. I mean, if you think,
okay.
Yeah, we're gonna do lots of quizzes. We got quizzes, we got assignments. We'll do all sorts of stuff. We'll try to stump Bob.
Yeah, that's what you really meant. I really want to make Bob look bad in front of a lot of people. Yeah, okay.
Yeah, so I will say, if you want to use the official poll, then please head over to Learn TV. That's where the poll is going to be hosted. Otherwise, if you're not on Learn TV, feel free to put in your answer in the chat, whatever it is, wherever you're streaming from. We can also see those as well. But if you want to be part of the overall ticker, then you have to go into Learn TV. So that being said, let's take a look at this question. So the question is, you want to migrate to the cloud, but you leverage a third-party application which requires access to the OS. Which is going to be the easiest Azure SQL deployment option to move to?
Okay. I'm going to think about this while you're getting your answers in. Anna, how I roll. It's process of elimination. That's the best way to take multiple choice tests.
Definitely. We do have some answers coming in
Okay.
Learn, as well as on YouTube and Twitch. So keep it coming in. We also have someone on Twitch. They said, Bob, you can never be bad. I don't know what that was in reference to.
I'm not sure, but I'll take it. Thanks, Nick. The first one.
Yeah.
I think it's like my
said
Texas Ranger shirt today. I'm rocking my baseball team in honor of the baseball season coming up. So
you are, yeah. You're just ready for the next sport because the past
ready
few
for the next sport.
out.
I love the way you said that. Yes. Okay. What do we got, Anna?
Well, we have someone who commented on Twitch, and I like this comment. They said, "It depends."
My favorite answer. Yeah. That's what I should use.
But yeah, let's take a look. It looks like the most common answer is between A and B. A has got about 80% of our votes on Learn, and for YouTube and Twitch, it looks like A is the most common one as well. You know, before we answer this question, you know, it might be helpful. I'm not sure if we exactly talked about elastic pools. Bob, do you want to give a brief overview of where elastic pools falls into all this?
Well, Darth, we actually are going to talk a little bit more about pools in the next slide. So Anna, I'm wondering, you snuck it in when the next slide is what I get to talk about pools. But honestly, what it's about a collection of databases. It's about a pool of databases that allows you to pay for performance across these and manage these as a pool of them. And it all came out of the need for software as a service developers that said, look, I got like 1,000 of these things. And what am I going to do? Pay for the maximum performance of all 1,000? I'd like to share the cost and share the management across these, which is why we call it elastic pool. That's really kind of what the concept is.
Awesome. Thanks, Bob, and thanks, Darth Vader.
Thanks, Darth. Yeah.
Question. Yeah. Okay, let's take a look at the answer. What do you think the answer is, Bob?
Well, again, we talked about, and you know me, I like to use process elimination. So I'm going to tell you what it not is to get to the answer of what it is. So you want to migrate to the cloud. That's a good one. These all involve the cloud. That's easy. But you leverage a third-party app which requires access to the operating system. Now, you're a little tricky because you say easiest to move to here, right? But it does say access to the operating system. And if you remember, we talked about the fact that infrastructure as a service gives you operating system access. Platform as service does not give you operating system access because we manage even the VM itself, not just the OS. In fact, you don't even know what OS SQL's running on in a PaaS environment. So the problem is here, C and D are gone because databases, you know, those are PaaS environments. And even though Azure SQL Managed Instance may feel like that to you, like an instance, you don't have access to the operating system. And that's a key tip, Anna, because later, I'm gonna give a tip for the audience. You may get questions where we ask you about using the file system for managed instance. You don't have access to the file system, okay? Because you don't have access to the operating system. So B can't be, therefore the answer's got to be A.
Yeah, that's exactly right. And I'm going to go ahead and put up the next question.
Okay.
But we can go ahead and talk about it. So this next question, it's another scenario. So you should be able to see this on Learn TV again, or you can put your answer in the chat. But the scenario is you want to migrate to the cloud and remove some of the management associated with SQL Server, but your application leverages CLR and service broker capabilities from SQL Server. Which Azure SQL deployment option will be the easiest to move to? So this one's kind of a tricky one. Bob, do you have any tips for folks as they think about this one?
Well, it's not just about easiest. That'll be my tip. It's more than just about easiest, but I can see why somebody is going to look at that and may choose an answer that is not the exact right answer. I would say there's a best answer here. How about that?
The best answer. Yeah. So go ahead and put your answers in. Let's see. I'm not seeing any just yet.
Okay. I like how you said migrate to the cloud, though. That applies. You threw that in there. That was good. It's good that you did that. Yeah.
Yeah. I mean, migration is a big piece of all of this. I know we don't dive a ton into it in this series, but yeah, it looks like some answers are coming in. I see quite a few of one answer.
Okay.
Seeing right now about 90% of folks saying managed instance and about 10% saying SQL DB.
Okay.
And while we're waiting for your answers, this is an interesting question that just came in. Malusi says, is it possible to use MS SQL Server and link it to Azure, and how so?
Yeah, all sorts of ways to do that. Absolutely. For example, you could even do a link server. That's one certain way, right? And we even just mentioned the fact that for Azure Virtual Machine, you could have a Azure VM be a secondary replica, an async secondary replica as like a DR to your on-premises SQL Server. That's an interesting scenario because we announced a licensing change that if that Azure VM up there is a secondary replica is just for DR purposes, it's free. How crazy is that? Free core licensing to do that with, right? So that is certainly one way to do it.
Awesome. Thanks, Bob. Hopefully that helps with your question, Malusi. Okay, so it looks like votes are kind of starting to slow down. Looks like we got 92% of people saying managed instance, 8% saying SQL DB, and a few people in the comments saying they were between B and C but couldn't decide.
Yeah, come on now. You got to make a choice and a decision, right? So let's walk through it. We mentioned that surface level, instance level features, which is what CLR and Broker are. Think about those. SQL CLR and Broker are instance level functionalities. That is something that is not in Azure SQL Database, which is why we did Cloud Lifter, right? So already we got to eliminate, C and D from our answers. So now it comes to A and B. And, it is true that SQL CLR and Service Broker could run in a SQL Server, in SQL Server and Azure Virtual Machine. But notice Anna's first part of her question. I want to remove some of the management associated with SQL Server. And we talked about how Platform as a Service gives you that managed capabilities. So I would eliminate A and C. The best answer would be B.
Yep, that is correct.
Okay.
It seems like most people were on board with that. So great job to everyone participating. Right.
So now that you've tested everybody, Anna, maybe we should talk about pools, right? I think this is interesting because I remember you had this idea. It was a really good idea because what did we do? We did, VM, MI, and DB, but then a lot of people are still torn. Like, what is between MI and DB again? In fact, I remember when we were first doing this, people were still asking us that. So maybe it's kind of important for me to go through this a little bit. Managed instance is that single instance with a surface area and native network support and fully managed. But what we found is we wanted a way to speed things up from a deployment point of view and actually provide a way to condense the number of instances that could show up in a virtual machine. Because with a single instance, it's kind of dedicated. So an instance pool came along, which is in preview right now. And so it can be a more cost-effective way to do an instance. In fact, it's the only way to get down to 2 vCores because the minimum number of vCores for an instance is 4. So if you just want 2 vCores for a managed instance, it's in public preview now, you're going to use this concept called an instance pool. And what you do is you go out there and build your instance pool first, and then you deploy instances within it. So the initial instance pool can take a little bit of time, just like a single instance can, but then the instances within the pool are pretty fast, go through and deploy those things. And then for Azure SQL Database, again, it's a single database. This is where you get your maximum storage with things like Hyperscale, or get that great capability with something called Serverless, which we're going to talk about, and private link support. But then you also have that pool concept for databases. Again, this is a little different where, remember, you're kind of abstracted from the instance here, right? So you don't know where these exist. But a pool concept is, again, I'd like a lot of these. I'd like to share costs and management of these across a large number of these. So I'm going to build an elastic pool. And when you go in and do that deployment, and I know in Anna, in the module deployment, you're going to see some of those options. You get to choose, hey, I'm doing a database. I'd like it to be part of a pool that I've already established. So that's kind of really when you think about these two. You've got managed instance on the side. Again, it's a fully managed service, but it is a full SQL instance. It's going to feel like that to you. And you got an Azure database, which you could have multiple databases for something called a logical server, or a large number of databases is something called a pool.
Yeah, and I think this comparison is super helpful. Figuring out which deployment option is going to be best for you. And if you are migrating, we do have tools that help you with that. For example, we just launched a new experience in Azure Migrate, which allows you to actually assess your on-prem instances, and it will recommend not only the deployment option, but also the different service level objective and the service tier and the compute tier. And that's what we're going to talk about next. So we've talked about the deployment option. So are you going to pick SQL Server and Azure Virtual Machine, Azure SQL Managed Instance, or Azure SQL Database? And then within those, are you going to choose this pools type of option or not? So that's what we've talked about. Now, once you've picked that, there's still a few other choices that you have to make. And really, these choices are designed to give you flexibility, but it's important to understand what the differences between them are. So let's start by looking at the next decision that you have to make, which is around purchasing models.
Yeah, and I want to emphasize to the audience, we're just getting you introduced to this, right? So you're going to like, in the next module, we're going to talk about this again. In fact, we're going to repeat ourselves and talk about what these are, because we're going to go through a sequence of your choices, right? But we wanted to introduce you these concepts because these are decisions you'll be making as you go through this process. In fact, if you're pre-planning about deciding MI or DB, this is going to be helpful to you. So for a database, an Azure database, you do have something called what we call a purchasing model to make a decision. For the longest time, we had this concept called a database transaction unit, and that was your only choice. And it's really kind of think of it as a prepackaged way of looking at resources. It's the most simplified way for you to choose your compute, like CPUs, memory, IO, etc. You just pick a DTU number, and we have these levels called like basic, standard, and premium. You pick levels within that, and then we give you some sort of predictable performance number that your app would adhere to. Now, we had a lot of feedback that people would come along and say, I want some more flexibility. I want flexibility for licensing and flexibility for choices to separate this choice of virtual cores and storage. So therefore, we came along with this vCore model. Now, we say Microsoft's recommendation because what we found is people wanted to apply that Azure hybrid benefit. They want to take their SQL licenses and apply it to the cloud. And this is the choice you need to make to get that. Plus, people wanted things like reserve capacity, or they'd like to pick the number of cores they'd like and storage, the max storage separately. And that's where this vCore model, comes into play. If you want to make this choice, you kind of have to decide for yourself. But here's the good news: you can go back and forth. So if you go to the vCore model and say, "Look, DTU is better for me," or you go to DTU and I'd like the vCore model, it is something you can use in the portal through APIs to change that decision.
Definitely. And so that's the purchasing model. And again, like Bob mentioned, this is only available for Azure SQL Database. For Azure SQL Managed Instance, you don't have this choice. You just get the vCore model. So that's the purchasing models. Let's now shift and talk about the different service tiers that are in both SQL Database and Managed Instance, but we're focusing again on the vCore model. Now, the first service tier that you have, and is pretty self-explanatory by the name, is a general purpose service tier. Now, we're going to talk about this later in the availability module, which is going to be week 5 of our series. But just to give you a little glimpse, sneak peek under the hood of what happens in general purpose is underneath, we're deploying a failover cluster instance or something very similar to that if you're familiar with SQL Server and availability. Now, this is, like the name suggests, good for most business workloads. So this is your general purpose database. It works really well. It's cost efficient, and there are some other options that can help with cost savings. Now, the other main option that we have in both SQL Database and SQL Managed Instance is business critical. And again, like the name suggests, this is really meant for your mission critical type of workloads that need that low latency, fast recovery, and even some read scale right off the bat. And again, just to give you a little peek under the hood, what's happening in the business critical service tier is when you deploy, we're actually going to deploy an always on availability group underneath the hood for you. And that's how you're going to get this really fast recovery and readable secondary. Now, if we dive a little bit deeper into what that entails, for general purpose, you can think about this as having remote storage. So again, we'll dive much deeper into this in the availability module. And I've used some, Yelp style ways to compare the two. So you're going to get more IOPS or IO per second with the business critical service tier, but that's also going to come at a cost because again, we're maintaining this always on availability group underneath the scenes. If you need in-memory OLTP or using in-memory type of workloads, you're going to want to use business critical as well because it's not supported in general purpose today. And again, like I mentioned about the always on availability group, that kind of explains the replicas you're seeing down at the bottom for business critical. You have a primary and you have 3 secondaries, but one of those secondaries can be used for read workloads, and that's what that R stands for. Now on the other side, you have less IOPS, less cost, no in-memory OLTP, but you have an option, another option between provisioned compute and serverless compute. And I think, Bob, you're gonna dive deeper into that in just a moment. Is that right?
Absolutely.
Awesome. So these are the main service tiers. I'll hold off and let you guys have the suspense build on serverless. These are the main service tiers available for SQL Database and SQL Managed Instance, but there is one more service tier for SQL DB.
Yeah, first of all, I love the way you roll Yelp style comparisons. Yeah, only Anna would say Yelp style. We've been alluding to Hyperscale. Hyperscale is something only available in Azure SQL Database, but has some very unique characteristics. Now, notice here what we say, most business workloads, but here's the key, highly scalable storage and read scale requirements. And so if you compare it to the other things we've shown here as far as storage goes and compute and replicas, consider this. Hyperscale has a unique architecture, which we'll show you in the availability module, that uses a combination of local and remote storage, okay? And because of the way we actually do that, the IOPS that you're going to get out of this are going to be slightly between what you see with the general purpose and business critical type environment. And the costs for this you're going to see are going to be a little bit in between what you might pay for from general purpose and business critical. But notice these last 2 points. These are very important. Your largest database size capabilities come from Hyperscale. We publish 100 terabytes, but we really think of it as unlimited storage. And then notice the diagram compared to what Anna showed you on the left and right. You get a primary compute. You're just like you're going to work with anything else. You're always going to have a primary replica you're going to be connecting to. But notice here you get up to four read replicas that you can scale to, as opposed to the fact that general purpose has no read replicas and a business critical only has 1 read replica. And so you're going to love the fact when we talk more about Hyperscale during availability, about this architecture and about the fact that for large scalable read scale operations, you're going to get the most availability here with Hyperscale. And because of the fact we're using local or remote storage, you're going to see some amazing functionality where we're going to talk about how point-in-time restore becomes blazingly fast because of the way we actually store the database files in Azure storage, but surface the data to you through a tiered set of caching layers.
And so we'll let the suspense subside. I mentioned earlier in Azure SQL Database, you have one other choice in the general purpose service tier, and that's between provisioned compute and serverless compute. So let's take a look at an example. Let's say I have a line of business application, which most people use only during business hours. So maybe between 8 to 5 or 9 to 5 in my time zone. Now, after work or after office work hours, people go home and they don't use the database anymore. Now, with the provision compute model, you're going to be paying for the compute you have, whether or not you're using it or not. And this has its benefits because it's guaranteed, it's available, it's there for you, you've already budgeted for it. But what serverless can do is in these periods, for example, the nighttime when no one's using your line of business application, or the weekends where, developers aren't working on an app or something like that, you can actually enable something called an auto pause delay. So what you can see here is in this example, around 22 or 23 o'clock, what happens is the database becomes inactive. People aren't using it, no one's opening connections to the database. And after that auto pause delay time, which again is something that you can set here, it's set to about 2 hours, the database actually becomes paused. So what does that mean? That means that we actually have separated the compute from the storage. And during this time, we're essentially going to shut down SQL Server. And so you're only going to have to pay for the storage at that point. So this is obviously drastically going to reduce your costs if you have this kind of intermittent type of workflow. And in addition to that, what serverless allows you to do is set a minimum and a maximum number of vCores. So in this example, you can see we set the min as 1 vCore and the max as 4 vCore. And what it's going to do is it's going to auto scale you on a per second basis to the max of CPU or memory of what you actually need. So this auto scaling capability is pretty powerful, and they implemented a really interesting new cache reclamation system to kind of bring you back down after this period of high intensity CPU. And this is great for, line of business applications. Like I mentioned, this scenario where people aren't really using it after hours on the weekend, but it can also be great for things like if you have a new application, you're not sure how much CPU it's going to need at a given time, or if you're dealing with dev tests. We've seen a lot of adoption in the serverless space for many, many different use cases. Bob, I'm sure you've also seen that as well with customers.
Absolutely.
So now, Bob, I thought it might be interesting, if you have something you could show us. We haven't seen any demos yet.
Yeah, what's a session without demos? I'd love to show you a demo, Anna.
Cool, let's take a look.
Yeah, so what I have here is a recording, and I know sometimes people don't like recordings of demos, but I recorded this for a very good reason, because we're going to show you several aspects of serverless compute as compared to general purpose provision. And some of this needs to be time-lapse. So it'd be better to show you kind of in a video. So let me just kind of kick this off and let's talk through it. So I've got an Azure SQL database, and you're going to see here, I'm going to zoom in. I've got a general purpose 2 vCore general purpose. We'll talk about Gen 5. We're going to mention those things later during configuration. So I'm going to run a performance test with my favorite tool called OStress. Okay, Anna, you've seen me do OStress before, right? Going to run a typical query against a sample database, going to kick off like 8 users, 25 iterations, and I'm time-lapsing the performance of running this workload on my 2 vCores. So I'm going to kick this thing off with running OStress, and it's going to come back and run in a certain time frame that, for me, takes a little too long. So I time-lapse this a little bit. It's going to get finished. It's going to take about 14 seconds. I want this to run faster. I think I've got a CPU bottleneck, right? So what I'll do is I'll go back here. In fact, this is really cool. The Azure portal, you can see here the utilization. It's almost 100% consumed for this general purpose 2 vCore environment. So I'm like, hey, I need more CPUs. No problem. Go into the portal, use a little slider and say, you know what? Give me 8 CPUs. A couple minutes later, the scaling operation finishes, pretty low downtime. I run it. It's going to come back. Boom, 5 minutes. That's pretty cool. But you're probably asking yourself, like, what does that have to do with serverless? So instead of having to do that operation, I'm going to take another database that's the exact same copy of that database, and I'm going to deploy it as a serverless database, okay, instead of it being this 2 vCore. Now, what you're going to see in the portal is something different. Remember, Anna mentioned about ranges. Can you see right here? In the portal now, since I picked serverless, I can say, oh, I'd like a max of 8 cores, but a min of 2 vCores. Also notice this auto pause that Anna mentioned. I'm going to turn that off for now. So I'm going to go back, going to run the same workload against serverless. Notice it took even faster than general purpose. Now, that's not always guaranteed, but I'd expect to have similar performance from my 8 vCore deployment. Notice the portal looks different now with serverless. I not just get utilization here on the left, I get billing for CPU, because Anna mentioned billing slightly different. On the graph here, on the left-hand side of this peak, is kind of like me getting billed for min vCore usage, okay? So when I was not using it, I got billed for min. When I was not running the app, on the left and right side, that's min, but I'm getting billed in the middle there at the spike for the actual usage. Now, here's what I'm gonna do. I'm gonna turn on that auto pause feature Anna talked about. The minimum is 1 hour. And of course, this is where time lapse comes into play. I'm gonna turn on auto pause, and I'm gonna run this thing, but then I'm going to wait an hour and not use this. Now go look at the metrics for billing, okay? Shows here the last 4 hours. I see a similar graph as I saw before. You see how this works? So I see my non-usage in orange shows up as min core usage. You can see here the blue is min core billing, and on the right side, and then the maximum usage is there in the middle. The orange is not using any at all. The key is when I'm not using this, but I've got min core not auto pause, I still get billed some. But here the key is to the right. Auto pause is kicked in. I'm not using it, and I'm not billed for anything. That is one of those interesting scenarios. So I get ranges of CPUs, Anna, but I also get the ability to pause my database and not get billed for any compute usage, just billed for storage.
Yeah, it's a pretty powerful demo. I really think serverless is just really cool. Personally, especially for all my demo databases, I'm always using serverless because it's all set up and ready to go. But when I'm not using it, it's paused and it keeps it really, really cost efficient for me to use. Now, I put up another poll for you guys to go ahead and take a look at. What I'll do is I'll just kind of explain the question, and then we have a few questions in the chat, so we can take some of them. And then we have one more question after this as well. So thanks for all your participation. So this question has another scenario, and it says, you're moving an application and a database to Azure, but your database is currently 62 terabytes with plans to grow. You don't leverage any instance scope features today. Which Azure SQL deployment option will be the easiest to move to? So go ahead and use either the Learn TV poll or the chat to put in your answer to that question. And while we're waiting for answers there, we did have one question, Bob. I think this is a great question about serverless.
Okay.
Nick says, would you be able to set specific times? For example, I always work between 9 and 17 hours and then stop.
Yeah, I mean, you have the ability to set auto pausing whenever you need to use it, right? You can enable auto pausing. So you have the ability to go in, since this is all based on CLIs and APIs, you could go in and set your auto pausing to be a certain time frame that I need it for, and then you're not going to get charged that time. That's exactly like what you said earlier in that chart. So if you say auto pausing, I want to do auto pause, and you say auto pause for an hour, if you don't use the database between 9, as you say here, 9 and 1700, then you wouldn't get charged. So you're not setting a schedule up. You're just saying the fact that when the database is idle during those times, pause me. So during that time frame, if you didn't use it for a couple hours, you wouldn't get charged. But all of a sudden, if you start using it again, we'll ramp up and then we'll charge you only that time. But then let's say you paused again for an hour. So you did it again, then you would become in the auto pause mode. So you don't set a schedule up. You just set for how long do I want to wait until I'm idle until I go to that pause state.
Yeah, exactly. And one other thing that you might want to consider when you think about what your auto pause delay is going to be is when this pauses. Remember, SQL Server essentially shuts down. So when it starts up again, you are starting with a cold cache. So if you're just hitting this intermittently but don't need all of that stuff to be there for most of the day, then maybe you want to set a little bit longer of an auto pause type of delay.
And I do want to call out the one thing, anything you configure with Azure is programmable. So if you wanted to change the configuration of auto pause or your ranges and so forth during certain times, you could do that, but it doesn't mean you set a schedule for pausing, if that makes sense.
Yeah, definitely. And looks like we've got a lot of answers in for this question. Okay. Again, this was about a 62 terabyte database. And it seems like we had a few people say SQL Server and Azure Virtual Machine, but the vast majority of people are saying Azure SQL Database, single database. But however, 20% of you are saying Elastic Pool. So maybe that's something we need to talk about as well. So Bob, do you want to take us through this one?
Let's talk about Elastic Pool first. Elastic Pool is a set of databases. So you said here you wanted to actually have a database at 62 terabytes. So Elastic Pool is not taking 62 terabytes and sharing it across a bunch of databases, okay? So that's eliminated here. That's not the answer. But it's good to know that Elastic Pool is not sharing a bunch data across databases, but for 62 terabytes. It's a set of a bunch of databases, right? So that wouldn't be the case. Now, we didn't really specifically say Azure SQL Managed Instance doesn't support 62 terabytes, but I called out that your maximum storage is not for Managed Instance. So we're going to eliminate that one. And SQL Server and Azure VM won't support that size today. So the only option would be single database, and it would be that hyperscale option that we mentioned.
Yeah, definitely. So it seems like most of you all got that, but maybe a few got confused on the Elastic Pools bit. Now I have one more question, and this one should be an easy one because we've talked a lot about serverless today. This scenario is you have an Azure SQL database with the serverless compute tier deployed with an auto pause delay of 2 hours. After 2 hours of no activity, what happens to your database and the incurred charges?
I always didn't like professors that said this should be easy. I really didn't like those. So
it puts the pressure on.
Yeah,
right?
Exactly.
Yeah, so go ahead and put in your answers for this. Let me take a look because we have been getting a good number of questions in here. Okay, maybe this one, I'm not sure if this is a question, but Miles says, you don't pay for what you use, you pay for what you provision. So I'm guessing they're comparing provision compute versus serverless compute.
Yeah, I think Miles has a good point. I mean, let's just summarize it real quick. So if you do provision compute, you are paying for the number of CPUs you choose, whether you use them or not. You pick 8, you pay for 8. And the storage is independent of that, right? So you provisioned 8, you pay for that. With serverless, you're going to give us a range. You're going to say, hey, I want a min of 2 potentially and a max of 8. If you're not turning on auto pause, that's key. You don't turn on auto pause and you don't use any CPU, you pay for min, okay? Or you pay for what you use, like you use 4 or 6 or even the max of 8, okay? If you turn on auto pause and you got 2 to 8, and we pause you because you didn't use it for an hour, even if you have minute 2, you don't pay for 2, you pay for none, right? That's kind of the key to it. But be careful too. It's very, very important. Go look at the documentation about using things, right, in the database. Once you connect and start using it, we're going to start ramping you up, and you're going to start pay for that min CPU. So that's kind of how I would look at it. Thanks, Miles.
Yeah, no, I think that's a great call out. And again, thanks, Miles, for calling that out. We have a few other questions coming in. Not all of them exactly relevant to this stream, but
okay.
Let's take a look at the answers. So it looks like we've gotten a good number of responses in, and they are mostly on A. So Azure will pause your database to stop compute costs and only charge you for storage. So Bob, can you talk a little bit about how you would think about this question and answer?
Yeah, I think the key, again, is elimination. Pausing is not about changing a service tier. So it's important about that concept service tier. And don't be, it's okay if you're like, hey man, I don't know what a service tier is. We're going to talk about that term so many times, right? Remember the service tiers Anna talked about? General purpose, business critical, hyperscale. So you don't reduce a service tier, you actually change how compute costs will happen for your database. In fact, as it turns out, today, serverless is only available for the general purpose service tier. So you got service tiers, and then under general purpose, you can have provisioned or serverless, okay? That's not available in business critical or hyperscale. So in that serverless compute tier, which is part of general purpose, you wouldn't change the tier, you would only actually stop compute cost and only charge for storage during the time you're paused. That's kind of the key.
Yeah, definitely. So the answer is A, which it seems like most of you were able to get, which is awesome. You've really been killing these knowledge checks, so that's good. We'll have to stay tuned for next week and hopefully stump more of you, because that's my goal.
You will, because you stumped me. So yeah, for sure.
So the kind of the one of the last things you have to think about, I mean, if you can even think about making another choice, is hardware. And we don't have to spend a ton of time on this because when it comes to hardware, typically there's one main option for you. So in this case, that's Gen 5 or Generation 5, and you can see some information about it on the left. And you can kind of guess that, you can kind of assume that as time goes on and hardware advances, these options are also going to change. For example, there are some future generations that became available recently, some that are memory optimized versus compute optimized, and there's also a newer version of hardware. Bob, I'd love if you could share a little bit about it related to the DC series, and this is for confidential computing.
Yeah, one just comment here, it's not our intention to make this complicated for you, to make these hardware choices, right? But we want to give you the option. So most people are going to pick Gen 5, but if you want to get the maximum number of cores for Azure SQL Database, you're going to pick M series, for example. But DC series is interesting. It's a new VM choice from the Azure team, which includes an Intel chip specifically designed for enclave security. So we recently announced the preview for Azure SQL Database with secure enclaves. And behind the scenes, to make that work, we're going to use Intel SGX as the enclave, the protected memory environment in the actual compute itself. And so the DC series is exactly that. It's built specifically to support our always encrypted secure enclave technology.
Oh,
looks like
I'm on mute. I did it. It
had to
happen once, right?
Exactly.
But I think it's really interesting is what I was saying. And it's something we'll dive into a lot in our security module, which
Exactly.
will be the third week. So 2 weeks from now. Um, Now, the last thing we have to think about, or kind of you might be interested in, is these interfaces for Azure SQL. And I'll show you in a moment how we've kind of done this Azure SQL unified experience. Because again, like Bob mentioned, we are trying to make this easier for you, but there are some other tools and technologies that you're already familiar with using, or you might be interested in using that you want to consider.
Yeah, Anna, along the way when I started this assessment experience, I thought to myself, what am I going to use as a tool to kind of look at these things? And I thought, what does the majority of the world use? And it's Management Studio. So you need to have assurances that if you're a Management Studio user, not only is it compatible to work with the Azure SQL choices we've talked about today, but it knows how to snap to that. So if you go into Management Studio and you pick what's called a logical server, which we'll show you during deployment for your Azure SQL databases, we will kind of change the menu options or the Object Explorer options that snap to only Azure SQL Database. Or if you use Managed Instance, it'll look like a complete SQL Server instance. In fact, you could actually take Azure SQL Data. I think I've done this before. You got Azure SQL Database, Azure VM, and Managed Instance, connect to all of them in a single pane of glass with Management Studio and kind of see those differences. But Azure Data Studio, Anna, that's one of your favorite tools to use. That's a new and upcoming tool that we've built. And just the notebook experience alone is worth using this tool. You're going to see us do demonstrations throughout this series a lot with something called a notebook with Azure Data Studio. But there's more. For example, we announced private preview of a new migration experience to do inline migrations to Azure SQL from SQL Server, and it's going to be done through Azure Data Studio. So Azure Data Studio, one of the cool things about it people love, it works across operating systems. So you're a MacBook lover today, you want a native experience, use Azure Data Studio. Linux, Windows, and Mac all works with that tool. But I mentioned before earlier the Azure ecosystem that people like to use APIs and command line interfaces, and that's me. So out of the gate, notice here it says the word T-SQL. One of the things I emphasized to Anna during our beginning journey, and I think Anna has a phrase, it's just SQL, was the T-SQL language is so known by so many people around the world that as they make this journey, they're afraid, do those T-SQL skills go away? Hey, here's the good news. They don't just go away, they get better. We take the T-SQL language and we enhance it to work with Azure SQL. So all those T-SQL skills you have all apply to everything you're seeing here in the cloud. But maybe you're a PowerShell user. That's going to work. Or new PowerShell commandlets we've built specifically for managing experience across these assets. And then if you've never seen AskCLI, I love AskCLI. I use it all the time in the Cloud Shell. Works on Windows, Linux, and Macs. And it's a great interface as well to do command line interfaces to anything you can do with Azure SQL. But you really want to get gnarly, I call it gnarly, go to the REST API. I know my colleague Dimitri is like, Bob, have you tried AskCLI with REST to solve this problem? I'm like, no, I'm not a REST programmer, I'm sorry. But if you want to go to the lowest levels, you can even do REST APIs because all of our interfaces for Azure SQL PaaS actually support REST. And then what's tried and true? SQL Command and BCP, they all work great. All those tools work fine. In fact, again, I use Azure Cloud Shell all the time to use those tools. But yeah, those tried and true tools work just fine, applying those to any Azure SQL assets we have today. So look at our list here, a unified experience in the portal, but tried and true tools and new tools, to help use your existing skills today, but also us to grow you new skills in the experience with Azure SQL.
Yeah. And, one thing I'll add is throughout this series, if you stick with us, which we really hope you will, throughout this series, through the exercises, you're going to get to play with almost all of these different interfaces and tools and kind of see what makes sense to you. You're going to see, like Bob mentioned, the Azure Cloud Shell, which is built into your browser, into the Azure portal, and it allows you to do things like access Azure CLI, PowerShell, SQL CMD, all from within the portal using command line. So there's a lot of really cool tools that we're going to take a look at. But kind of to round out this session, we thought it'd be interesting to take a look at this Azure SQL unified experience. So at the very beginning, Bob mentioned how in 2020, we announced Azure SQL. And we didn't just announce it as a thing. We tried to follow through in some of the tools that we have so that you can see this Azure SQL experience as well. So I'm going to hop over and show you an example of this. So this is my Azure portal view, which you can see here. And what you can see is a few things you're probably familiar with seeing. Create a resource, but what you also see is this Azure SQL button. Now, this button is great because what it allows you to do is actually take a look at all of your databases, all of your Azure SQL resources in a given subscription, or you can set multiple, you can set certain resource groups, you can add other filters. But what's really cool about this is it's going to group them all together regardless of what Azure SQL deployment option they are. So you can see I have my SQL databases. I can see if they're hyperscale, general purpose, business critical, serverless. I can see my managed instances, my Azure SQL Database logical servers, which we'll learn a lot more about in the next session. I can even see my SQL virtual machine. So this one's running SQL Server Enterprise 2019 on Windows Server 2019. So there's lots of information here. Even Elastic Pools are here. So I kind of get this single pane of glass to see everything that exists. Now, similarly, if I go to create a new resource, what's going to happen is I'm going to have more options, but this should look familiar. This is very similar to the way we design the slides, where you have your 3 main deployment options, and under each one, you can dive into what those options are. So for SQL Database, you can dive in and see single database or Elastic Pool or database server. For managed instance, you can see options there. And this is perhaps the coolest part, is for the SQL Server in an Azure virtual machine, you can actually get every single image in one place. Now, before this, if any of you had been trying to deploy a SQL Server in Azure virtual machine, it was really hard to find the specific image you wanted. And if I go all the way down, what you're going to see is I can find a bring your own license SQL Server 2008 R2 SP3 on Windows Server. And I can deploy that and make it easier for me to migrate and leverage right off the bat. And you can see we also have images for other OSs. So not just Windows, but SUSE Slash, Ubuntu, Red Hat, or RHEL. All those different versions are here for you to easily deploy a pre-installed image like Bob talked about closer to the beginning. So this is really awesome. And one other thing you can see is we talked about the different service tiers. So we'll go more into deployment in the next episode, but just wanted to show you, just like Bob did earlier, these different options you have under general purpose or business critical. And then we also talked a little bit how Hyperscale is available only in Azure SQL Database today. So these are kind of your options. This is kind of the unified experience that we're going for. And yeah, so if we kind of take a step back and think about all the things that we've done, Bob, what do you think? Have we covered just so much? Do you think people are following? What's next? What's going on?
I think some people are watching and they really love the overview we provided, but they're also wondering, like, are you guys going to get into some gnarly, deep stuff? I can assure you.
Gnarly.
In the next modules, Anna, as we built this, we're like, Bob, I think we're going too deep. So we are going to get deep as we move into the meat and potatoes of SQL Server. But think about what we talked about. I mean, I'm biased. I think Azure SQL is the world's database. I mean, think of the options you have to put things in a virtual machine, in a managed instance, and an Azure SQL database. And what we're going to show you in the next few weeks, how easy it is to deploy this, how to configure it, how to secure it, make it fast, make it available. The built-in capabilities we're going to show you, I think, makes it that. But we have these options for you. You want a VM? We'll put it in a VM. We'll give you some extra on top of it to run in Azure, right? Remember, you're in a VM in Azure, so you just get built-in availability of the VM because you're in Azure. But you want a managed instance to get that built-in availability, we're going to give it to you. You want a database to go to Hyperscale, you have that as well. You want to just lift and shift? Again, you can take Azure Migrate and take a VHD image from VMware or Hyper-V and just put it into the cloud. You want an instant to get that power of paths? Remember, the best of SQL Server, the managed service, that's managed instances. And then if you have a modern developer right now and you have a modern app and you just want to deploy a database and you want this thing to auto scale or pause when you need it or scale up to 100 terabytes when you need it, Azure Database is definitely the platform for you. So I think about all these choices we have, Anna, now today. I really, the intention we both had was to make sure people walked away from today's session and know what's possible with Azure SQL, and then join us in this journey over the next 5 weeks to find out, what do I do next and how do I use it?
Yeah, and we do have a whole journey ahead of us. I think, Bob, you mentioned it quite well, saying that this is really just the beginning. We're going to get really deep. So if this was an overview, something you were already familiar with, you're definitely going to want to join, because we're going to go into some stuff you probably didn't even know existed in Azure SQL today. Now,
lots of demos, Anna, lots of demos coming up in the next ones, right?
Lots of demos. We have so many demos. So we're really excited to share them with you all. And if you want to check out some resources in the meantime, of course, that first resource is going to be for this learning path. So if you want to start getting hands-on, reviewing the modules, then you can check it out at that first link. If you want the slides that we're using, a lot of people ask for our slides. We actually host those on GitHub, so you're able to take them. You can take that at that second link, SQL Workshops. What else? Shameless plugs for other series that Bob and I do. One is Azure SQL for Beginners. So if there's something small you want to revisit, this was a 61 video series that Bob and I recorded that takes you bit by bit through the Azure SQL Fundamentals content. And then another shameless plug for Data Exposed. If you like these live stream sort of things, we're actually streaming on Wednesday. Bob, you're coming on the show on Wednesday.
Well, thanks for the notice.
Yeah, so on Wednesdays at 9 a.m. Pacific, please join us on Data Exposed Live, and we also release recorded episodes on Thursday. You can find those on our YouTube channel. We have some books too, because doing live videos and stuff isn't enough for us. We have to go write some books. Bob wrote a book last year called Azure SQL Revealed, which follows pretty closely with this journey, but it dives deeper into some of the extra stories and hidden gems that Bob has found in his research and his just career. And then we also have another book written by myself and several other Azure SQL program managers about practical Azure SQL Database for modern developers. So this book is more geared towards folks who might be new to Azure SQL Database or are developer heavy. So definitely check out both those books. They're really great resources. I read them both to help myself, even though I was involved in some of them. Yeah, again, if you want to access this module from Learn Today, you can head to this AKA link, Learn Intro Azure SQL. Again, it's part of this whole Azure SQL Fundamentals learning path. And Bob, that's not all, is it?
Yeah, I just want to add one other thing that honestly, it wasn't even intentional for us. I can't tell how many people that have gone through Azure SQL Fundamentals or are going to go through the series that you're going to go through the next 6 weeks and literally just pass the DP300 exam. I mean, I'm talking like a lot of people have contacted me and said like, hey, just pass the exam. I just did your stuff. I'm like, yeah, that's actually pretty amazing. So if that's your thing and you want it and you need to pass that exam and it's part of your journey, please, this content can help you do that.
Awesome. Thanks, Bob. And, just stick around with us. You see the dates there, but really we're here at the same place, same time every Monday for the next 5 Mondays. So go ahead and mark your calendars. Be sure to join us. I'm just taking a quick look at the question. We have about 2 minutes left. Let's see. Maybe this is a good one to end on, Bob. I'm going to throw that.
Yeah, good.
See what you think. This person says, which approach would you take in a scenario where you're running a Kubernetes cluster hosting multiple microservices where some of them depend on SQL Database? Would you host the SQL Server in a container or use Azure SQL Database? So this is kind of a tricky what to use when.
Well, you take something like Azure Kubernetes Service, that provides a lot of platform as a service-like capabilities for Kubernetes. And a SQL Server container runs great in that environment. But you're not going to get built-in availability groups, okay? You're not going to get serverless scaling. So if you need a lot of these PaaS capabilities that we provide, Azure SQL Database is going to be a better offering for you, like a versionless SQL Server, where a SQL Server container doesn't do that. But hey, Kubernetes has built-in basic availability, like a failover cluster instance, and a SQL Server container runs really well in there. It's really great for DevOps scenarios. So a lot of people that choose Kubernetes versus using a PaaS service, but again, remember, PaaS gives you that ultimate built-in platform capabilities. So that is going to be, what does that person say? It depends.
Yeah.
But think of the container more of like your infrastructure service type capabilities, because again, it is just SQL Server running a container, which is going to be kind of like running in a virtual machine like IaaS.
Awesome. Thanks so much, Bob. Thank you everyone so much for joining us today. Be sure to join us next week, same place, same time. Like, comment, subscribe, all that stuff. And we hope to see you next week on Learn Live.
Bye, everybody.
Hi, I'm Anna Hoffman, and welcome to Learn Live. We are super excited to be here today to continue our discussion about Azure SQL. I'm Anna Hoffman, and I'm joined today by Bob Ward. Bob, thanks for joining us again today.
Anna, thank you for having me again. Everybody that's tuning in, we're so excited you're here today, and I cannot wait. We're continuing our journey to talk about Azure SQL, and I'm really excited that today's session is all about deploying configure, so it should be fun.
Yeah, it's definitely going to be a great session full of demos and demos that you can get hands-on with yourself. So if you head over to Microsoft Learn either now or later or whenever you're watching this, you're going to find a module dedicated to this topic, which includes all the hands-on exercises you're going to see in demo form today. So it should be really great. You don't have to follow along through the exercises live with us. If you want to, you can. Otherwise, you can try them later. There's also some more resources and more context around certain topics, but we're really excited to be here today. Thanks for joining us. If you have any comments or questions throughout the session, this is live and interactive, so feel free to say hi in the chat. We have subject matter experts from our team standing by to help answer any questions you might have, so be sure to tune in. We're not in the first module of this Azure SQL Fundamentals. We're actually in the second module. Bob, can you tell us a little bit about what we covered last week, what we're covering today, and kind of what else there is to cover?
Yeah, thanks, Anna. Last week was all about just introducing our audience community to Azure SQL, especially compared to like what SQL Server is. A lot of people know SQL Server. So what does Azure SQL, what does it mean to that? Remember, we talked about Azure VMs, we talk about managed instances, and Azure SQL databases as a complete suite of services for SQL in the cloud. And so just get everybody familiar with what it is, what your choices are, why would you use it, how are you going to plan for it? But I think today the right thing to do is to talk about how to set it up. You're used to installing SQL Server, you're configuring SQL Server, you configure databases. So that's a great topic for us to cover today. And then where we're headed in the future is that meat and potatoes of SQL, security, performance, availability, and then a great session to wrap the entire series up on just putting it all together. So you can see where that journey is. We just got you started. What is Azure SQL? To introduce you to the idea. Wasn't a lot of demos last week, but today let's got to show it off some. And you have to know how to get to deploy this thing to use it in the first place. So are you ready, Anna, for some hyper-focusedness? I can't say that right, but yeah, I think that's where we're headed, right?
I'm not sure I'm ever ready for the hyper-focusedness, but it's definitely always a lot to learn. So I'm looking forward to learning. I think our viewers are looking forward to learning. So let's get right into it. So like Bob mentioned, we're going to start by talking about deploy and configure. So we're going to talk about pre-deployment planning. So what do you do before you deploy? We're going to talk about actually deploying, configuring, verifying, getting connected, loading data. All these things are topics that are going to be covered today over the course of the next 75 minutes. So stay tuned, and here we go. So the first thing you want to think about when we think about pre-deployment planning, so before you just go in and deploy, you need to have some sort of plan. And the biggest decision you have to make up front is, okay, well, is this a new deployment, or is this an existing application or database that we're actually going to migrate? So we don't spend a ton of time in this series talking about migration, but we wanted to take a little bit of time now just to talk about some of the new things in migration and some of the ways we are going to help you from a migration standpoint. So what I really like, and I'll share this resource with you all, we just recently actually revamped the whole site, is we really break down migration into 3 phases. What do you do before you migrate? So pre-migration. What do you do after you migrate? And how do you migrate? And what do you do after you migrate? So before migration, migration, after migration. It's a very simple process, which I like. Now, during the pre-migration phase, what you're going to do is you're going to discover and assess all your existing instances and applications and database, and try to figure out, what is going to move, where is it going to move, which deployment option. We talked about them last week, SQL Server and Azure VM, Azure SQL Managed Instance, Azure SQL Database. You're going to use some of those decision points you learned about last week to kind of decide, where is this thing going? What size is it going to? Is Hyperscale or Serverless something we want to take advantage of? And then if you're not coming from SQL Server to Azure, you might be coming from another type of database, then you actually have to convert your schema. And we do have tools for this, such as SSMA, and we can provide some resources for that in this link I have coming up on the screen soon. Now, once you figure out, what you're going to migrate, you actually have to do this migration. So if you're doing an online migration, you have to do all of these steps here. If you're doing an offline migration, you really just migrate the schema, the data, and the objects. During that time, you're offline, and then you switch over your connection strings and you're back to up and running. Now, some customers prefer to take maybe a more phased online approach. So they'll migrate, but they'll also maintain some sort of data sync. We have some services and some different options for you to do that. And then when you're ready and you're comfortable to do what we're calling the cutover, so move from your SQL Server on-prem to your, for example, Azure SQL Database, then you can perform that cutover, and now you're migrated to moving to the cloud. So you can have a little less downtime. And finally, once you migrate, there's a lot of things that you can do. And a lot of these things are actually going to apply in some of this deploy and configure section. But we talk a lot about remediating your applications, making sure everything works, optimizing not only for performance, but also for price, and just making sure everything works and doing some good testing. And those two resources in the bottom right side of this page are going to be the most useful for you. The first is the Azure Migrate program, where you can basically apply and get free resources, whether it's training, a white glove experience, all sorts of things to help make this migration smoother for you. And then the second one is this new website that we actually just launched that I wanted to mention, called aka.ms/data migration. Now, we used to have another page, but this new page is really interesting because it really cleanly organizes all the options of where you could be coming from and where you're going to, and then gives you a custom guide. And again, this has all been revamped just in the past few weeks, so you can count on all that content being up to date. Now, there were a few things that were new, especially related to Ignite. And Bob, I'd love if you could share some of the new things that we came out with related to Azure Migrate.
Yeah, there's two things that are really important that we launched and just announced at Ignite. One is using the Azure Migrate Center as kind of that really great hub, especially for this discovery and assessment phase, Anna, that you talked about. So one of the things we demonstrated, I know I was part of this discussion and demonstration at Ignite, was a new concept of an appliance, because a lot of people out there have a lot of SQL Server instances, a lot of servers, and they're like, I'm not even sure what all I have that I need to consider to migrate. So this Discover and Assessment appliance, the preview right now is for VMware systems. You run this thing in a lightweight, secure agent in your environment, does all this type of assessment and discovery of your assets. And here's a really cool thing. It's not just about telling you what you have in your environment, but it gives you recommendations. So for example, we can give you recommendations for some of the things we're going to talk about today. What service tier should you pick? Is managed instance the best option for you, or is it database or VM? And then even cost estimates, which we've had a lot of feedback from customers. What's this going to cost me when I make this move into Azure? So that's one thing, Anna. The new Azure Migrate experience to really help with that discovery and assessment experience. And I'm really excited about the preview we talked about, which you're going to see a lot more in the next coming months, is an inline migration experience from Azure Data Studio. You got a single SQL instance, you'd like to assess that just with some of the things we talked about here, and just inline migrate that right to the cloud. Imagine doing that from a single tool that you're familiar with, connected to your existing SQL server. So both those things, we're going to continue and iterate those over the next several months. And I'm kind of excited. I'm also part of the process to produce some content and work with the team on that. So I'm really excited to see how that journey goes forward to help you do all of these phases that, Anna, you've talked about today.
Definitely. Thanks, Bob. Really appreciate you chiming in. And I know you're a part of a big demo at Ignite, so it's always interesting to hear your perspective. So we're kind of talking about this pre-deployment planning. So we're talking about the overall process of migration, but now I want to switch to dive in a little bit deeper into whether or not it is a new or existing migration, the things you need to plan out before you go and deploy this. Now, the first thing you might plan out is how you're going to deploy. So Bob talked in the last session about some of the different interfaces you have to interact with Azure SQL, and the same goes for deployment. So for example, you could use the Azure portal. Now, if you're more into scripting, you can use the Azure CLI, you can use Azure PowerShell. To a certain extent, you can even use existing tools like SSMS and Azure Data Studio. So you need to decide, like, how are you going to deploy this thing? Maybe you're going to use ARM templates, maybe you're a big ARM person. And then once you decide how you're going to deploy, again, you should already have an idea of what you're going to deploy before you open up the Azure CLI or the Azure Cloud Shell and start deploying. So again, just to review briefly, some of the options we talked about were single databases and elastic pools. And we talked about managed instances and instance pools. And I do want to also call out that for this deployment process, we're going to specifically be diving into the platform as a service offering. So we're not going to be talking about SQL Server and Azure VM here. So you're going to pick your deployment option, and then you're going to pick your region. Bob talked about in the last session how we have many different regions all around the world for you to choose from. So you need to make sure you're picking the one that's going to be closest to where you are, and also ideally in the same region as your application, because you want to reduce that latency as much as you can. Then we talked about this last week as well. You need to pick the purchasing model. So again, for Azure SQL Managed Instance, this is an easy choice because your only option is the vCore model. But for Azure SQL Database, you're going to have the option of choosing between the DTU model and the vCore model. And once you pick that, you're going to pick a service tier. Now, these are the service tiers available for the vCore model, which was the service tier
choices you see in front of us. So if you think about today when you're deploying and configuring SQL Server, you're doing that in your own bare metal or VM environment, and you're making some of these choices yourself as you deploy. You figure out how many cores you need, you pick a certain hardware platform you might be using for your server, or you may pick other choices that affect capacity or predictable performance. So service level objective, as it turns out, and you're going to see it exposed this way, is going to be this combination of these choices. So for example, Azure Database with a vCore model, general purpose, Gen 5, 8 vCores. Something like that together could be called a service level objective. And Anna, one of the things important that you understand about that term is it can affect resource limits that you don't explicitly choose. So for example, today with SQL Server, when you do it on a virtual machine, you pick a certain amount of memory you're going to give that virtual machine. Well, in platforms as a service, the choices you make in your slow affect how much memory you get. You need more memory? Sometimes what you need to go to a different service tier or add more vCores to your deployment to get more memory. Things like maximum transaction log size or transaction log rate, also the same type of concept, depending on your deployment option, database or managed instance, depending on the service tier, how many vCores, it can affect what you're going to get. Things like IOPS. Remember, in platform as a service, we own the infrastructure, including all the drives and the disk storage. So you're not even provisioning disks. So data IOPS can become a factor now based on these choices. Turns out there are some scenarios where the number of files, we'll talk about some of that, I think, more in the performance section, but the number of files you pick could actually have an impact on IOPS. But you normally are determining IOPS based on the storage you've selected in your environment. For us, you need to be using this particular slow to get a certain number of IOPS. But even things like the size of temp DB, max concurrent workers, and even the backup retention choices you may get, all of those together, you're not explicitly picking a lot of these choices that you get for these maximums. It's the slow you pick that dictate these limits. And here's the good news. You might look at this list and go, well, how am I going to go figure all this out? Which one is which? There's a couple of interesting things. Number one, the documentation has some really excellent tables where you go choose the different options you want, the service tier, the deployment option, the hardware generation, and we'll tell you what those maximums look like. And then also, we're going to show you today and in future modules, dynamic management views that also give you that same type of information depending on the choices you've made. So it's important to understand the choices Anna showed you already, but also implicitly, what does it mean when you make those choices? You know, what kind of resources and predictable performance do I get from platform as a service?
Yeah, it's a great call out, Bob. And, you know, we have a lot of people, at least I do, and I'm sure you do as well, just reaching out and trying to understand this. And then you show them that table and the documentation. And they're like, oh, it makes so much sense. This is how much IOPS I need. This is how much, you know, I need of this other thing. And I can very easily figure out which slow is going to be the best for me. So it's really useful. You know, Bob, I don't know if maybe we have some people that didn't join us last week, but we love to do knowledge checks, right?
You mean you love to do knowledge checks? Let's be clear about this, Professor Hoffman. Yeah, you're the one that loves to stump people, including me.
Yes, I mean, I try my best. I wouldn't say I could ever stump you, Bob, but I do try my best. And so we're going to continue the knowledge checks here. If you want to participate in giving your answer, just feel free to add it in the chat, or if you're streaming through us with Learn TV, that's going to be the best because you can actually fill out the poll and we can get a look at all the different answers that you have. But this first question is, which of the following options have limits depending on your deployment option and service tier? So this is a little bit tricky. You had to have been paying attention to what Bob was saying to try to figure out which of the following kind of depend on the deployment option and service tier. So I'm going to give you guys a few seconds to bring in your questions. Bob, what do you think? Do you think people are going to be able to tackle this one?
I think so. I mean, we did just talk about it. I mean, we had a bunch of bullet points, right? And so it may have been blurry to you to think about this. But again, I want to just emphasize that you make choices on managed instance database, you pick general purpose, business critical, you pick a generation hardware, and you pick things like vCores. There are some things you don't choose about what is possible for you. And so this question is all about what are the limits or things that are going to potentially happen to you based on your choices. And then the reason I wanted this to be a big part of this is I want people to start getting in that mindset as they're planning. I want them to be able to make the right choices so they're not surprised. So that they come along and deploy Azure SQL Database or managed instance and go, oh, wait a minute, my maximum transaction log size is not big enough for my application. And I want them to understand to be able to go research that to give them a great experience.
Definitely. Thanks, Bob. It looks like we are getting some answers coming in. Looks like so far there's a very strong leader. I'm not sure if you can see the answer before you post the answer, but go ahead and get your answers in. It looks like 85% of people are saying all of the above. So you do have about 15% of people that are saying something else. But a good number of people think it's all of the above. Bob, why don't you take us through it?
Well, if you tuned in last week, it's okay if you didn't. But I told Anna that I like to take multiple choice tests by process of elimination. It's a quick way to get through an exam and to give you more confidence in your answers. So if I look at this right here, I know that size of temp DB is something I just talked about, right? I mean, that is a limit that will be a factor of your deployment option and service tier. So is max log size. Okay, so since size of 10D and max log size are both correct, it can't be one of the two because they're both correct, and it can't be C because they're both correct, so it's got to be D. As it turns out, backup retention, even though you choose a backup retention, your choices on backup retention of what you get access to are based on your options and service tier. So the answer's got to be D.
Awesome, thanks, Bob. This one was a little bit tricky for some people, but I think most people got it, so that's good. If you got the question wrong or you didn't get to answer the question before we went over the solution, don't worry. I think we have like 4 or 5 more knowledge checks throughout, so there'll definitely be more questions, more opportunities for you to take a shot at answering.
More tests. So good job, Anna. More tests. Great.
More tests. So we talked about pre-deployment planning, and the next thing to talk about makes sense, is to talk about actually deploying. So what I put up here on the screen is all the different blades that you would see if you went into the Azure portal and try to deploy an Azure SQL managed instance or an Azure SQL database. And you can see that some things are designated DB because they're only related to deploying database only, and some things are designated MI. But that doesn't mean that they're not available. It just means they're not necessarily configurable during deployment. Some of these things you have to configure after deployment. And instead of going through these individually, I thought it would be a little more interesting to take a look at a demo. But before we get into it, there is one new thing here, like very new, and that is maintenance windows. Bob, can you tell folks a little bit about maintenance windows?
Yeah, thanks, Anna. I think one thing is great about this, though, it just shows, Anna, how both of us have tried to make sure, we've been doing this for a while, right? We're trying to adapt of what's changing and what's new in the cloud to make sure when we present things like this, you get the latest and greatest information. So we've worked very hard for that. Maintenance window is a good example of that. So you've deployed platform as a service with us, and you're like, great, this is awesome. I've got this all set up. You talked about SLAs and high availability. We're going to talk about that in future modules, but we mentioned it in the last discussion. But then you might be saying like, hey, this is a versionless SQL Server. You talked about that last time. When do you guys update things in the background, and how do I know about them? And is it going to affect my application? So as it turns out, Anna, what people don't know is prior to this point, we do the best we can to make sure that we, by default, only do updates in the evening. So like during normal working hours, like 8 a.m. to 5 p.m., depending on what region you deployed, local, that time zone, we try not to do any kind of maintenance activities on updating SQL or the Fabric or Windows or whatever, right? And that's what's called a maintenance window. So we've been doing this the entire time. We just didn't really document that. And so when you see this option, your system default is going to be that. But the feedback from customers was, I'd like a different window. How about you only do it on the weekends? That'd be kind of cool during a different time frame. So Anna, you're going to show this in the demo you're doing, but we just announced this concept. It's a more predictable time frame of when we're going to maintain your deployment of Azure SQL or managed instance, so you can account for that. Another thing that's really cool, you're going to discover as you dive into this, you're going to have the ability to get alerts or notifications when these events are occurring. That's going to help you have a more predictable experience to decide, when am I affected? The service level agreement is not affected by this, and it does not take into account things like unexpected failures that might occur because of hardware reasons or something in the infrastructure. But for maintenance activities, again, why it's called maintenance window, we're going to give you choices now on what is that window of time that we're going to take things offline for a short period of time to make sure we keep things up to date in platform as a service.
Awesome. Thanks, Bob. So I think without further ado, let's take a look. Let's take a look at some demos. Let's get hands-on. So here I am in the Azure portal. You see a lot of things here, but what I want to show you is a few things. So first, if I type Azure SQL up here, you're going to see a lot of different things. So I just wanted to help you navigate this blade. Now on this first blade under services, you're going to be able to filter all your services. So if I select Azure SQL, you might remember from the end of the last session, I actually showed you this. It shows you all of your Azure SQL deployments, so existing deployments. That's what you're going to get here. Now over here, what you can see is the marketplace. So this is where you can go if you want to deploy something new. So in this case, we want to deploy a new Azure SQL database. So that's where we would want to start. But you can also see some other options here, like documentation that might be related. If I had resource groups that had Azure SQL in the name, they would show up here. And you can also see some other resources, in this case, a solution, which I have deployed related to Azure SQL. So this is a really great way to just search everything in Azure, whether it's documentation, your existing deployments, or new deployments. So we're going to go ahead and select Azure SQL. And we're going to get this familiar blade. I showed you guys this last week. But what we're going to do is we're going to deploy a single database here. And you see, we are getting a little what to use when here down at the bottom. And so what we're going to do is just a single database this time now. So I'm going to go ahead and click create. And now I'm going to have to locate my resource group. So here's one of my resource groups. So you're going to select your subscription, your resource group, and then you have to give your database a name. I'm going to call it AdventureWorks, and it'll make sense shortly why I do that. And now we haven't talked a ton about this. I know Bob will go into this in more detail after this, but with Azure SQL Database, you have this idea of an Azure SQL Database logical server. So this isn't a full SQL server like you would expect in SQL Server on-prem, for example, or SQL Server in Azure Virtual Machine. But really, this is more of a logical server that's going to allow you to group databases and policies together. And it's also going to give you something to connect to, right? Because you have to connect to some sort of server. So I'm going to click Create New. I'm going to give this a name. Let's call it 1, 2, 3, 4. See if that's available. Oh, 5, 6. Really creative there. Give it a server admin login. So this is going to be very similar to like your sysadmin login. I think we talked about this in the last session, but you have to deploy with a SQL auth login. I think that's actually something we'll talk about next week. Then you want to give it a password, and we'll see how I do typing live. It's like, okay, you pick the region. So we talked about the different regions you might select. You hit OK. Okay, we're going to select a different region. Use East US 2. And then once all that's validated, you can choose, do you want to use a SQL Elastic Pool? In this case, we're going to say no. And you also have the option to come in here and configure the service tier and all the details related to that. So for example, if we take a look at general purpose, I now have the option of choosing between provision or serverless compute. I also have the option to change the hardware configuration. I'm just going to leave it as the default. We're going to use provision for now. And I get to pick the vCores and the data max size. So these are all things that Bob mentioned. Your selections here are going to have an impact on several different things. So I'm just going to leave all the defaults for now, and I'm going to go into the next blade, which is networking. We're going to talk a lot more about networking in the security module, but for now, when you deploy, you do have to make some decisions. So you kind of have to know a little bit. The default is no access, and if you're just getting started with this thing or just trying to get access to it, I do not recommend using the no access. I recommend using the public endpoint. This is just going to be the easiest way for you to get connected and for other apps to connect to it. Now, that being said, if you're looking for the most secure way, and again, we're going to talk about this much more in the security module, then you can actually configure with a private endpoint. So I'm going to select public endpoint, and I'm going to say, okay, any Azure service can connect to this, and also add my current IP address. So this is a virtual machine that I'm in, and I'm basically saying, yeah, go ahead and add this as a firewall rule so that I can connect from this machine. It's just the easiest way to get connected. Now, in additional settings, I have some options around data source. So I can choose none. I can use an existing backup from anywhere else in my subscription, or I can also use a sample. Now, if I use the data source of none, let's say I'm starting a new application, I want to set all this thing up, I have the option to configure this collation only on the server level and only during deployment. So this is the only time you really have to make any changes here for Azure SQL Database. It is a little bit different for Azure SQL Managed Instance. Then you can also configure Azure Defender for SQL. So this is something, again, we'll talk about a lot more detail in the security module. For now, I'm just going to start the free trial of it. And then finally, Bob talked about maintenance windows. And we can see by default, that's going to happen between 5 p.m. and 8 a.m. local time to me. But I also have some options here to change it to Monday to Thursday at night or Friday to Sunday at night. So maybe depending on when my application is heavily used, I might pick one versus the other or stick with the system default. Now, next, I'm able to add some tags. So for example, you might keep track of your resources by using something like environment and then calling this your dev environment. Then you can review and create and go ahead and kick off that resource. So this is just a simple way of deploying a database. I've actually already deployed this database for some of our other examples later on, and next we'll talk about some of the details as well as later how to verify and configure this thing.
Yeah, one of the things I want to emphasize before we talk about this next slide is I always use the portal experience well to kind of show off what I'm doing in Azure. But we mentioned this a little bit last week. You have the same abilities to make all those choices Anna did through a CLI. You can do this through as CLI, you can do it through PowerShell, and then take a hard look at something called Azure templates to automate, especially like a mass deployment if they need to do something like that, right? Okay, Anna, so we were building this course out and, we were talking about deploy, configure, and I'm like, Anna, we didn't really tell anybody like how we do this. And you're like, what do you mean? And I said, well, I think it'd be kind of interesting to know a little bit more, even though things can change over time. Like, how do we deploy an instance or a database or hyperscale, like some of the stuff behind the covers? We alluded a little bit into it when we talked about the history and so forth, but we do have something called the service fabric in Azure that helps us as developers deploy our services within Azure. All services in Azure use the service fabric to deploy. And in fact, you yourself can go to build your own service fabric app as a service using Azure if you choose. So it all starts with managed instance. Like, what are some of the things behind the scenes that affect how you see these deployment? So first of all, in managed instance, we have something called a dedicated ring or virtual cluster. And this gives us that VNet isolation that we talked about last time to describe what managed instance is. The only downside is to that is because of that, the deployment or scale operations can take a little longer than doing an Azure SQL database where it's not a dedicated ring. Because you're just doing a database, we don't have to necessarily do that. Today, the way we deploy managed instance is that an instance of SQL Server, it's actually a SQL Server instance, is deployed in its own VM. And depending on how we organize things in the cluster and how the choices you make, there could be multiple VMs per node within this cluster. What is a reason is why we built pools. We talked about instance pools last week, is we can then start combining multiple instances now in a VM to make deployment a lot faster and give you a lot more density and open up things like lower core type options. So this is what a managed instance looks like, but it still does use the service fabric, both in general purpose and in business critical, as an underlying infrastructure to run the cluster and run SQL Server. Now, what about Azure SQL Database? So Anna, I'm glad you brought up that logical server concept, because I have to admit it confuses so many people that are SQL Server people, because you deploy a SQL Server that has what? A physical master database, a model database like system databases, and then your user databases. So an Azure database, like you just said, you're giving me a database. What is this logical server? Think of this as a collection of metadata that we are doing. It may not be an actual SQL server. We're using a set of resources as a connection point for you. Anna, you mentioned last time the concept like a gateway, right? And we're going to talk more about that. So think in terms of this logical server giving you access to like this gateway, plus storing information about the databases that are associated with the server itself. And it turns out there's a logical master database that kind of looks like a master that's part of this concept. Now, I mentioned this a little bit already in the history of this but to emphasize to you, it's not a for sure thing, but we use a dedicated SQL instance behind the scenes for each of these databases. There's a few exceptions to that, but for the most part, each Azure database gets its own SQL instance. But here's the confusing part. You don't see the SQL instance, the physical master. We manage all that for you. You, though, at the logical server level, will see this logical master. It can get somewhat confusing when you start going into things and using SQL Server, but it can explain why, for example, Anna, the use command doesn't work. So you're going to connect to Management Studio or Azure Data Studio, and you're going to go, oh, use AdventureWorks. I'm just going to say, sorry, we don't know how to do a use. That's because, again, these databases may not be on the same SQL instances. So how do you use across multiple computers? The SQL engine doesn't know how to do that. That explains why use doesn't actually work. It's okay. You have the ability to connect to anything and explicitly say, you know, what database I want to connect to. Now, because we're doing a dedicated SQL instance, though, it's very powerful because it gives you more surface instance level type diagnostics. You're going to see that throughout our presentations and all the different modules we're doing. What about this Hyperscale thing that is really popular? I love the name, right? It's incredibly impressive technology. And you're going to see a lot more information behind the scenes when we talk about availability, about what we built. But because we built a unique architecture using SQL Server, you cannot change today the tier once you go that way. So if you go to Hyperscale with Azure SQL Database as a service tier, remember you get general purpose, business critical, Hyperscale. You cannot go back to general purpose and business critical. When you go to general purpose and business critical, you can switch between them. We can actually set up that kind of type scenario. But once you move to Hyperscale, you cannot move back, at least today. And we'll see in the high availability section, we're going to use a very impressive set of caches, which is a distributed tiered architecture to provide speed and scale. And then something really interesting, we're going to use remote storage for the databases, still use the caches for speed, but we're going to allow some very interesting scenarios like snapshot backup. So point-in-time restore becomes really crazy fast. Now, Anna, you may not be aware of this, but behind the scenes, we're doing some resource governance in both managed instances and Azure Database to give this slow and predictable performance. So we introduced this feature several releases of SQL Server ago called Resource Governor. And we're going to take advantage of that in Azure SQL behind the scenes in the engine, but we're going to add some functionality to Resource Governor that you don't see in SQL Server to do things like enforcing transaction log rates. But we're going to use other things like Windows job objects. I'm going to show you an example in a second how Windows job objects can affect your SQL deployment. We're going to use things like file server, Azure storage limits, things of that nature to help provide all those different slow limits I talked about, depending on what you choose, to ensure we give predictable performance and we give you what we say we do based on the tables we actually talked about. So there's your hyper-focusedness slide of the day to give, and Anna, we could change some of this. We reserve the right behind the scenes as this platform or service to change some of these things, but this is effectively how we make things work today behind the scenes.
Yeah, I mean, I think it's definitely useful to kind of get a glance under the hood, and it helps you understand how certain things work. Like, for example, I think a great example is how you can't use that use statement because now you understand that running underneath, you might have a full SQL instance that isn't the same as your other database. So I think it's really useful, especially for people who really understand how SQL Server works, to understand how we've kind of implemented this thing under the hood.
Well, we were going through this exercise of building. I love the fact that we get these little stories how we were building these things. And I remember this meeting. We specifically had this meeting about our content. And I said, Anna, we got to tell the people how do they verify the deployment. And you go, what are you talking about? I mean, it just works, right? I'm like, yeah, man, I'm sorry. I've been doing SQL Server for so long. Like when I deploy SQL Server, I go through a verification process to do a sanity check of did this work? So maybe we should talk about my viewpoint of verifying deployment, compare that to Azure SQL. So let's just kind of go a progression of how this might look. First of all, it might start with in managed instance, looking at what Anna just showed you, like she did Azure Database. So you can go look at the status of your deployment in the portal or with CLI. So this is a deployment. Remember we talked about in the Azure Ecosystem in the first module about Resource Manager. So we're using Resource Manager to do deployment. Deployment is a concept in Azure for all Azure resources. And this deployment has details behind it and something called an activity log. Today you might, Anna, be looking at like the event log in Windows or even logging with journals in Linux. So we are going to put in information about the deployment in this thing called an activity log for you to see the details. For example, is an easy way for you to use the portal to look at activity log to see how long did it take to deploy that instance or Azure Database, or if there's a failure, you can get more information behind the scenes of what to do. Now in managed instance, you get access to the error log, the SQL error log, the tried and true text file of SQL Server for a billion years, right? And you can go into the error log and look at a managed instance to see what it actually looks like. You can't do that with Azure SQL Database because we don't give you access to the instance, but with managed instance, you can do it. And so what might you do if you're an existing SQL Server user today? You might pop up Management Studio and just do a connection, and you might run some queries. But to do that connection, you need some basic stuff, right? You need to know the network, the name, and connect. And we'll talk about that. What about SQL Database? What does it look like compared to that thing? Hey, it's the same thing. You just don't get access to the error log. But all the same things that you do with managed instance, all same apply. So you want to run these deployment queries. You want to connect with Management Studio. You need to get network access. Anna briefly mentioned that in the first module. We'll talk a lot about those options of the next module, but notice what she did in her portal deployment. Remember, she said to get going kind of up and fast, she gave allow Azure access and she used her client IP address. So for example, Anna, if you were doing in the portal from your own desktop computer and you gave client IP address access, you now could use SSMS on your client computer to go run deployment queries. You would get the name of the logical server, or in the case of managed instance, the name of the instance. That's available once you run the deployment to see what that name looks like. It's kind of like a 4-part name, right, that you would see. You would get that. You have your login because you already said, like in the case of Azure SQL Database, here's my server admin SQL login. And by the way, Anna, in module 3 in security, we're going to talk about options there, like what are your options for those admin options. But you're going to use that server admin SQL login. You're going to go in with Management Studio. You're going to put in the password. You got this name, and you're going to connect. So once you connect, what do? Well, here's what I do when I look at a SQL server. And I'm going to show you the similarities between that and an Azure SQL database. First, I look at version. I'm like, hey man, is the SQL edition I installed and the right version deployed on what I'm doing? In fact, I looked at version all the time with customers to say, tell me exactly the version of SQL you're running. Well, we're going to show you an example in a second. That's a little different when it comes to Azure SQL because we're versionless. So the version actually doesn't really have much of a factor in what you're doing, except for the fact it's showing you you're in Azure. I'm going to look at what do my databases look like? Do I see my system databases? Do I see the objects I'm used to seeing, like system objects? Or if I had a sample database like Anna showed you, do I expect to see the user objects there? And then I might go through a series of system DMVs. I might look to see, are the number of schedulers match up the number of cores I deployed? What about OS things like OS sysinfo? What about the memory I have access to? I might look at something like OS process memory. That's not going to be available in Azure SQL Database, as it turns out, because again, you don't see that instance, but that is available in managed instance. And then I look at things like DM exec request. Are all the background processes running? Is my own query running? Do I get a sanity check of looking at what's running in SQL Server? Now, I might run server property for addition, and we'll show you an example of why that matters between database and instance. But notice the ones in green. The ones in green are new DMVs that are specific to Azure SQL. And I think the best way to look at this is maybe you see an example. Would you like to see one?
Yeah, I would love to.
Okay, let's do that. So I'm going to go and share my screen now, and let's hope technology works. Okay, Anna, let me give a few seconds here for the magic to appear. Let me know when you see it.
Yep, I can see it.
Now, I just said in that screen to use Management Studio, yet that's not what I'm showing you. I'm showing you Azure Data Studio for a very good reason. Number one, I want to point out a couple of things. I actually have the GitHub repo that goes with this same fundamentals course loaded on my laptop. And whoa, that's not what I want to show you. So I'm using Zoom It, and clearly I'm not doing a good job with Zoom It. So I want to show you first, though, this. This is the GitHub repo, and then notice these what are called notebooks. So we're using a T-SQL notebook that we've built to show you off these examples. There's a combination of markdown text and code to show you. But here's the cool thing. I've got the output already run. So in case that there's an issue, I don't have to actually execute each of these commands. So what I love about this, and Anna, you built this, here's a notebook to show you what verification looks like for managed instance. Here's one for SQL Server, and here's one for Azure Database. So you can kind of compare what does this look like between these three different options. So like the last one could be SQL Server like an Azure VM. But let's go through and see what the output looks like. So first of all, I mentioned about add version, and we told you last week about versionless. So look at this thing here for Azure SQL. You see SQL Azure, we just can't help ourselves, Anna. We still got to call it SQL Azure. That's like a holdover from the old days. And then notice this, it says version 12. What are you talking about? I thought we're like way to SQL 19 now and past, right? That's like the same version we've had it there for a while. So here's the bottom line. You can't use version number anymore to look at Azure SQL because it's versionless. And you're asking yourself like, well, how am I supposed to know what version I'm on? It doesn't really matter. The only thing that you're going to see, and we'll talk about this later, is database compat level for your database. So version numbers really don't matter. The fact that you just see that you're running SQL Azure is the really only important thing that comes from add version for me. And again, you can look at these other examples to compare and contrast. What does that look like? Now, server property can matter because if you want to, as a programmer, know what am I actually running. So look at this. You can see here that I'm running Azure SQL Database, which is number 5. Or if I wanted to, I could look at, if I got an 8, I could tell if I'm running managed instance. So this gets really interesting because you're asking yourself, okay, is Azure Database or managed instance that I'm running, is it standard, enterprise, express, or desktop? Like which one is it? Okay, we don't have editions in Azure SQL. We have service tiers like we talked about, and in some cases, that can dictate functionality that may show up. For example, in-memory OLTP only appears in business critical. But for the most part, here's the cool thing, most of this functionality you get from a feature level point, this just comes in your deployments for Azure SQL. One thing that's different today between, like, say, standard and enterprise is limits. And so we already talked about the fact that your deployment choices can affect limits, things like memory. So that's how you look at which edition you're running for Azure SQL. Let's get into some of the output of the DMVs. Now, this is going to surprise a lot of people. For Azure SQL Database, I see a master and I see my database. what happened to model, MSDB, TempDB, all those things? Remember, we abstract you from the instance. So the master you're seeing here is actually the logical master that goes for the logical server. So anytime you run sys databases in your Azure SQL database, you're only going to see your database and the logical master. And if you were to run this in managed instance, you would see the normal system databases because we do give you the entire instance of SQL. Now, sysobjects is going to look pretty much like you're used to seeing in SQL Server. That's kind of reassuring. I see all the system objects I'm used to seeing. So that's good as a sanity check that I see that. Now let's go look at schedulers. Now, this is really an important concept for me personally. I deploy SQL Server on, say, a virtual machine with 8 vCores. I go right into OS schedulers and I'm like, do I get 2 schedulers? Because we normally deploy 2 visible schedulers per the number of cores that you get. And in this particular case, I'm running a general purpose 2 vCore option. Therefore, I expect to see 2 schedulers to kind of match, what I deployed. So I'm pretty good there. Let's kind of keep going and seeing, okay, this is where things get a little different. Notice here that we're going to show you 2 DMVs that only show up in Azure SQL Database and Managed Instance. I think I even mentioned in the previous screen that instance resource governance would also show up in just MI, but as it turns out, user DB resource governance can also appear in Managed Instance. And if you get kind of confused on what we're seeing here, when you go look at these notebooks, because you have access to them, and it's going to show you some of the resources at the end of the day that you have access to, we have all sorts of great documentation and our markdown text for what I'm showing you here, though. But what you're going to love about the notebooks is that you can go look at this and compare to your own deployment to see, as kind of a sanity check, what am I having access to? So here we go. I'm going to look at user resource governance here, and that's pretty interesting because I'm going to look at my database. I'm going to scroll along here, and I'm going to see, look at that, Anna, slow name. Here's why we taught you slow. Azure SQL Database, general purpose, Gen 5 hardware, 2 vCore. That's a mouthful, right? But now you can see why slow is this combination of these concepts we're doing. And you're going to see that in other examples where we're going to look at an Azure SQL Database or managed instance deployment. Now, I said I only had 2 vCore, and sure enough, I can say I'm limited to 2 CPUs. Notice this. Also, I can see my max DOP possibilities. So it turns out for a 2 vCore general purpose deployment, we only let you have max DOP 1. If you need parallelism at a higher level, you got to pick a higher vCore limit, and you'll see how we can configure that DOP. Now, memory is an interesting one because we mentioned about this job object concept, and I show you that here. So how much memory do I really get? As it turns out, for an instance of SQL Server, we want to make sure we apply proper resource limits. So we use this Windows job object concept, which is not a scheduler thing. It's a way to do process limits on Windows processes. So you can see here from Windows job objects, the process memory limit MB, this corresponds to the table we talked about for a general purpose 2 vCore deployment. And that's 10 gig. If you needed more memory of that, and again, that's the same memory you get like in SQL Server for your buffer pool and all your memory needs. If you need more than that, you would bump up your vCore level and you would see those values get higher. Now, the last thing I want to show you is DM exec requests. And people ask like, Bob, why would you run that? Well, I want to make sure that this is really SQL Server. Do you really have a lazy and log writer? Do you really have the background task I'm normally using? And that's why I kind of prove to people, yeah, it really is SQL Server. It's the instance engine running all that stuff you're used to seeing that apply to your environment. So it's just also to show you that DM exec request, which is kind of this instance level thing you want to see, that works for your database. So if you want to go see your own user requests as they're executing, and Anna, we'll show you great examples of that when we go to performance. We'll show you how you're going to use the same DMVs you're used to using today for SQL Server. And in addition, some of these new DMVs you're seeing for Azure to look at things like performance, to look at security, to look at availability. But this is just a sanity check. So SQL Server users that come in to deploy Azure SQL, it gets them in a comfort zone to say, yeah, it kind of feels like a SQL Server.
Yeah, definitely. I think this is really useful. And like you mentioned, I think it's useful for people to compare, how it varies among what they're getting. And also, love to come back to this, how for the most part, it's really just SQL here. We're just changing a little bit of the scope depending on what you deploy.
Absolutely.
Cool. So let me share my screen again, and we're going to do a knowledge check. So This is a good one. So Bob showed you all some verifying deployment queries that he runs. And for this question, they're saying there are some new queries specific to Azure SQL Database and Azure SQL Managed Instance. Now, which of the following queries are only available for Azure SQL? So remember, when I say Azure SQL here, I mean Azure SQL Database and or Azure SQL Managed Instance. So which of these are only going to be available for Azure SQL? So you should see that coming up on your screen to answer from Learn TV. If you're streaming from somewhere else like YouTube or Twitch or Twitter, feel free to put your answers in the chat or head over to Learn TV and we'll make sure we get your answer counted. Bob, you know, when you first went and you deployed and you were looking, you were doing this analysis of comparing all these things, was there anything that like really stood out to you as far as what you can see or what you can't see?
Yeah, I mean, you know, I'm a SQL Server person for 28 years. And so I heard about Azure SQL Database and I'm like, oh, well, I probably don't get to see things like DMVs, like OS schedulers. Like, I'm not going to let me see that because it's just a database, right? So when I ran these queries, like I told you about this verification thing. You're like, hey, man, what are you going to do? Why are you doing this? I'm like, I want to make sure it's SQL Server. Like, is there some trick behind the scene? So I ran DMO sort of schedulers, and I'm like, oh, this is what I used to use in SQL Server. So I get to see what I'm used to. DM exec request, this could be the #1 DMV used in the world with SQL Server. Every SQL Server professional knows how to run that thing, right? And so I ran it. I'm like, man, I want to see the processes, the background processes. I mean, what if I have a problem with my deployment and something's going wrong? I want to be use DM exec request to troubleshoot my problem. You know, I was in support for a million years. And if you would have called me in support and said, I'm having a problem with my SQL Server, I'm like, go run that. So I can see the output of that, right? Many people have written stored procedures that, you know, use this and use other DMVs. So what stood out for me was I was so impressed with things that I had access to, even though I still get that abstraction of the database and still predictable performance. And then the second thing that stood out is that, you know, the tables are great, but I'm a programmer. Like, give me access to a query that shows me these details. And I think the thing that's really cool is we're still continuing the tradition of dynamic management views being a way to look at things in tables. And we're just doing it by doing things that look like SQL and things that are new and specific to Azure.
Yeah, no, I think that makes sense. And it's interesting. It's always interesting to hear your perspective because, you know, you've been around and seen this from basically the beginning of SQL.
Yeah.
So looks like we have some answers coming in. We got a few people saying C and D, and a few people, actually most people are saying B. So Bob, do you want to take us through your thought process on how you would go through, you know, your elimination?
Sure, yeah. Well, first of all, I did specifically say that OS process memory is not available in Azure SQL Database, and you called it out here. This is both for database and managed instance. So D has to be eliminated correctly, right? And it has to be eliminated. Mm-hmm. So you said here, which following queries are only available for these two? And I just told you that exec request is something I use in SQL Server all the time. So that can't be the answer either. So it's left with A or B. And then I even mentioned to you that OS schedulers, which I use in SQL Server all the time, is available there. So the only thing that could be possible is this new one, DM user DB resource governance. That was written specifically for cloud deployments of SQL. So B would have to be the answer. Oh, awesome. I was right. Thank goodness.
You sound surprised.
Well, I'm like, okay, does this elimination thing actually going to work on live television, right?
Yeah, you were right, and it looks like about 85% of our viewers were right too. So kudos to you, and kudos to the live viewers tuning in.
Awesome. Yeah, so the next part of our journey after deployment and looking at verification and looking at all the different architectures was configuration. And Anna, you told me in a conversation, like, well, you know, how many options are there? And I'm like, oh, if you only knew. SQL Server, we're famous for allowing you to configure SQL. Now, some things you do during deployment, and you did some of that in the portal, right? And in SQL Server, when you run setup, if you remember, Anna, I remember I had all those screenshots of how SQL setup works and all the different choices you can get. But you also have configuration choices for SQL Server and for databases. So if you think about a managed instance, the #1 thing people do to configure SQL is spconfigure. This stored procedure has been around almost as long as the product's been around. It's a server-wide configuration option. They're knobs to touch things on how SQL behaves and performs. And so, as it turns out for managed instance, you have access to many of the things you do for SQL Server, just like a SQL Server today. The one big limitation here is you cannot restart managed instance on your own. You can fail it over. We'll talk about that during availability, but you don't have like a net start, net stop SQL Server. So any option in configuration that requires a restart is not available to you. There are some trace flags that are available. We document very specific ones you're allowed to touch, but we don't just open up the entire trace flag story here like you do for SQL Server. So if you think you're going to start, going on the internet and finding your favorite trace flag to bring down SQL, sorry, you're kind of a little bit out of luck. And in fact, that's a good thing. We don't really want you to have to use trace flags a lot for SQL Server. There are a few specific things you can do, but we want to limit the need for you to have to do that. Now, temp DB size is interesting. You're not going to get access to actually control that in managed instance like you do in a SQL Server, but you do indirectly. And in fact, we talked about the fact that the different choices you're going to make, right, for your different options are going to affect that size, number of files, that kind of type thing. So indirectly, you're going to be doing things, but you don't directly change the size. You're used to doing that for your SQL Server today. It's a good thing. It's a good thing for you to have less worry about how that works. But we do document what the sizes, the max sizes you get for TempDB based on your choices. And this is a surprising thing to a lot of people, but you can actually configure model and master. It is a system data, a SQL instance. You can go put objects in model, and new databases will pick that up if you need to. Now, the addition of SQL Server, I kind of alluded to that already. You don't pick an addition for managed instance. You pick your service tier. And again, most functionality and features that you do are going to be consistent across general purpose and business critical for managed instance. There's a few small differences there, and we document what that looks like. And then, Anna, you're going to really get into this in Module 3. You're going to make some network configuration choices. You're used to doing in SQL Server like allow TCP and name pipes and some of those kind of things. You don't mess with that stuff anymore. You just only pick your configuration on how to connect into your instance. And then in space management, you're used to doing that with your SQL Server. We'll talk more about that in the next section about how does space management kind of work in an MI. So that's your configuration of managed instance and some of the options that you get. So let's talk about databases now. So for Azure Database and for managed instance, you do have Alter Database. Here's a really cool thing, Anna. In the documentation, I know you've seen this before. You go look at Alter Database in our documentation. We have this really cool layout where you just pick your deployment option, SQL Server, managed instance, or database, and you click it, and we flip and show you the Alter Database reference that applies only to what that looks like. It's very handy to know what's possible and not possible. And so you get to do some file maintenance in managed instance in terms of sizes, number of files, things of that nature. You don't pick storage, though. We'll talk about that in the performance section for a very good reason. But you can pick how many files you get and the sizes of those within your max storage. You do have set options, just like you do in SQL Server, and database compat. That'll be a very important thing that you've seen in SQL Server today. Sometimes that's how you're controlling functionality. You do have access to that in managed instance and database. And Alter Database scope configuration, which is very important, that is also available to you in both options. Now for SQL DB, there's a few differences there on how we do a few things. You do have network configuration and space management for Azure Database, which we'll talk about. But notice this list to the right over here. These are the options we're turning on for default use for Azure SQL Database. And in many cases, you cannot change that, like full recovery. You have to have a full recovery database. In order for us to meet service level agreements, you have to be in full recovery. What about accelerated database recovery? We'll talk about that during the availability section, but that is on by default, and you cannot turn that off. That's because we need that to help you meet that service level agreement. So the last thing in configuration, Anna, that I think it'd be important to tell our audience here is that what are some restrictions of things maybe that you might be used to doing, especially when it comes to things like server configuration manager, that you cannot do with managed instance or database? Now, look at this list for a second here. It's not because we wanted to limit you from doing this. It doesn't make sense in platform as a service. Letting you just restart servers at random, we can't meet a service level agreement if you do that. Worrying about things like instant file initialization or locked pages in memory, even though we might use it, let's abstract you from having to worry about that stuff anymore. Or even when it comes down to things like error reporting and feedback or alter server configurations, we're doing the infrastructure. You're not going to go pick NUMA nodes anymore or even affinity for processors. So a lot of these things that you do right here you don't need to do. Now, even mixed mode security is forced. That's even changed. We're going to talk about in the security module next week that we have this new option now where even you don't have to have mixed mode security that's forced for you. So again, I did this as a very exhaustive study of comparing SQL Server to Azure SQL, and a lot of these things are usually done outside the engine, alter server configuration being one example that's not. But these are things that we don't feel like you have to worry about anymore, like startup parameters, because again, it's platform as a service.
Yeah, and Bob, this is all super, super great information. I know people are starting to see the hyper-focusedness coming out, which is good. We have some people asking questions about the replay of this. I'm guessing their brain is starting to melt, and they're like, I need to be able to watch this again. We did get a question from John Michael, who was one of the people who asked. He said, you know, where can I watch the replays for this? While we are streaming live, all of these are going to be recorded. Well, they are being recorded, and you can find them on, I believe, channel 9 at aka.ms/learnlive. So there's the link at the bottom of the screen. So don't worry if you missed something or you want to go back and say, wait, what was it that Bob said about IFI? Then you can go back and watch it in the recording, and you can also check it out in the learning path, which we'll share, again, all these resources again at the end. But just wanted to throw that in there, give people's brains a second of relief before we talk about space management.
Brain melting? What? Yeah, I mean, isn't that part of our job? No, actually, it's just thoroughness. Let's be honest, Anna. This is just being thorough. And again, we're trying to get you comfortable with this. You're a SQL Server person, and you think this Azure SQL thing is just this mysterious deal. It's not. It's SQL Server. So trying to get you comfortable about what you can and can't do and why you can't do it. Now, space management, this is an interesting one. I have maybe iterated this slide, Anna, like 5 times because it's a little bit hard to describe this. If you think about today with your SQL Server with space management, you provide all the storage. You set up the disk drives, you place files and databases in certain disk drives and storage facilities. So you know the maximum capacities of your storage and what you can do when and without those. Since we're platform as a service, we kind of need to explain a little bit how this works. So for Azure SQL Managed Instance, your slow determines the maximum possible size you get to play with for everything, for the system databases, for the user databases. So what's going to happen is, though, we're going to charge you for the storage you're going to use at a maximum level. I know that sounds crazy. So you get this maximum possible size, then you choose the max storage for the instance up to that size. Your maximum possible size, for example, in general purpose, is 8 terabytes. You may say, I don't want to pay for 8 terabytes because I'm not using 8 terabytes. So I will put my max storage at 4 terabytes. And then that is the storage you're going to get for the entire instance. Now, database is going to be created as model with default sizes, and I document those there. And you can alter these sizes and files within all this max storage if you'd like. But again, not the physical location. That's something that we manage behind the scenes for you. And during the performance section, we'll talk about the fact that it really doesn't matter that you get to do that. But from a storage perspective, it does, because again, we control the max storage that's possible for you. Now, a couple of things that are interesting I thought might point out here and that I've observed. Number one, message 1105 is one of the oldest messages in the history of SQL Server, because that means you're out of space for your database. But notice this new one, 1133. So since this is the max size of all the storage, it is possible to hit that error before you run out of your database. Because again, it's for the storage for the entire instance. So it's a new error that applications and administration need to be aware of, that if you see this and you're not used to it, it's because you've hit that max size of what you've configured. So you said 4 terabytes. If you hit that limit, you're going to get this error. Now, again, with general purpose, you get up to 8, so you can increase your size that you want up to that limit itself. Now, for general purpose service tier, where databases are stored in Azure storage, as it turns out, the number of files and the size, since we're using Azure storage, it can affect the actual premium storage level that we're using. So we have a really nice blog post that talks about how you might be able to tweak your performance versus using a slow by changing the way you actually apportion data and log files. So that's Azure SQL Managed Instance. Okay, what about this Azure SQL Database where you don't even get access to the instance? The same concept exists. The slow determines the maximum possible size, okay? And then you choose a data max size within that possible size. Now, as it turns out, when you're looking at things like sys.database files, in managed instance, it's going to look just like you're used to. You see the files, you can add some and so forth. For Azure SQL Database, you're not choosing files. So you may see one or more files that may not reflect that exact size. I've seen people go look at the sys database files max size column, and they deployed an Azure SQL Database, but the max size isn't that yet. That's because we may grow that up to that max size if necessary. Now, the transaction log's a different thing. We account for this separately. You pay for data max size, you get, as part of that payment, 30% of that as your maximum transaction log size for your database. Now, we believe it's enough because logs are truncated regularly. We'll talk about that during availability, and we use accelerated database recovery so you're not beholden to open transactions, accelerating and growing that transaction log. So Hyperscale is interesting. One of the things I love about it is not only just it's unlimited storage, but you don't pick a max size. You just pay for the storage you use. In fact, we decide what that looks like. So when Anna showed you those portal options for picking different things like cores and sizes, for Hyperscale, you don't even get a storage choice there because we just start building a database and growing to the needs that you need for your unlimited storage. So there is kind of an exhaustive look of how space looks like, but it's important to administrators to understand, how do I play in here in the PaaS space depending on, or compared to how I'm used to doing things in SQL Server.
Yeah, it's definitely super interesting to learn about this, and it's also very important for folks to learn about this. And I think, Bob, you mentioned this. We kind of have redone that previous slide a few times because we want to make sure it's clear. And it seems like no matter how many times we explain it, sometimes it's confusing. And so I think a good way to kind of try to learn is to take an example and try to apply it yourself. So in this scenario, we're going to say if your data max size in Azure SQL Database is set to 10 gigabytes, then what additional space is the maximum transaction log size? So some keywords in there. What additional space? So this is on top of the 10 gigabytes that you already have. So want to call that out there. We should have put the poll up. We'll see. Go ahead and get your answers in. We'd love to see what you guys think and hopefully re-explain if we've confused anyone.
This is important. I think the poll is important because I don't want anybody today tuning in to go deploy Azure SQL Database or even managed instance and have a bad experience from a space perspective. I want them to understand exactly how it works, what's possible. And because, again, anytime you have a bad experience like that, you're just wasting your time. You have energy, you have a bad experience, and you don't feel comfortable with the environment. We want you to have the knowledge so you feel comfortable deploying SQL in the cloud.
Yeah, definitely. It looks like our answers are starting to kind of pour in, so we can go ahead and take a look at this. But I will say it looks like right now, at least, option B is winning by a large majority. There's a few people that have said A, but for the most part, B is in the lead. Okay,
cool. Do you want us to go through it, or you want to give a few more?
Let's go ahead and go through it.
Okay, well, it's process of elimination again. Now, one thing is interesting for anybody who's hyper-focusedness, they're like, hey, what about Hyperscale? Well, notice we just said you don't specify a max size with Hyperscale, right? So therefore, Hyperscale can't be part of this answer. It must be a general purpose or business critical database, Anna, because you don't specify a max size with Hyperscale. So in case anybody wants to trap us, they can't do that. Okay, so you pick your data max size. And notice we said data max size. That's actually a term that you do with Azure SQL Database. You pick 10 gig, and what's the additional space for the transaction log? So it can't be 10 gig. You don't get the same amount of log that you get with database. So we can eliminate that one. It's not 50%. I had a very specific thing that I said, and it can't be 1 because that would be 10%. So it's got to be B because that's 30% approximately of the database size of data max size. So.
Yeah, and I will say it looks like 87% of people got that. So I think most people got it. To those of you that said 1, just a quick recap, the size was 30% accounted separately of the data max size. So that's how we got from the 10 gigs to the 3 gigs. Awesome. Okay, so now we've talked about configuring for space management. One thing we wanted to touch on is configuring for connectivity. Now, Bob mentioned earlier, once you do this thing, what you're going to do is you're going to get the network, you're going to get the name, and then you're going to connect. Now, there's two main ways that you can actually go about this connection. And so let's take a look at one example first. Now, for this, I'm going to talk about proxy, and then I'll talk about another option, and then I'll talk about the default. So in this case, we're looking at an Azure SQL Database logical server. However, this also applies to Azure SQL Managed Instance. We're just showing it in Azure SQL Database right now. Now, if we say we want to use the proxy method of connection, what's going to happen is we're going to go to the gateway. So you can see there's a set of gateways here. We're going to go through the gateway, confirm that we have access. We're going to then get rerouted to the database we want to connect to. So that's the proxy method. Now, one of the potential downsides of this method is that every time you want to connect to the database, you have to go to the gateway first. So you almost have to make an extra hop in the sense before you can get to a database. Now, the other option that we have available is called redirect. Now, in redirect, it's kind of a two-step process. So at first, we go to the gateways and we get the connection information for the database. And then we redirect you straight to the database. So that means the first time you go to the gateway, but every time after that, you're not having to go to the gateway every time. So what this means is it means less hops or less network latency because you're not going to that gateway every single time. So the general recommendation is if you can use redirect, but if you can't, then you can use proxy. And if we think about what the default is and explain why, in Azure SQL, what we do by default is we use redirect for within Azure, so services within Azure. And the reason we can do this by default is this requires a certain number of ports, certain ports to be open, those 11000, 11999, those ports have to be open in order for redirect to work. So we can't make that assumption for your on-premises or outside of Azure environment, but we can make that assumption because we know that it's true for services within Azure. So by default, you're going to get redirect for in Azure, and outside of Azure, you're going to get proxy because we're not going to make that assumption. If you want to use redirect for both, then you'll have to configure this port to be allowed in your on-premises network or from whatever network you're going to be connecting from. Then you can set them both to be redirect. But by default, it's going to be redirect for in Azure and proxy for outside of Azure. And in the exercises, I'll go ahead and put up this next question, but in the exercises that you do, you'll actually go through this exercise to see what that performance difference really looks like. And in some of my tests, it's almost 50%, sometimes more, is decreased in the network latency just because you're making half as many hops. So this can be really useful. Again, your mileage will vary depending on where you are, where your two devices are, where the database is. But it's something to keep in mind. It's a good test to kind of see the differences, that there actually are impactful differences, and also to understand those defaults. And this question is really just asking about the defaults. Hopefully this is an easy one. And next week we're going to talk a lot more about networking, right, Bob?
Yeah, I just want to make sure the audience, we wanted an proxy and redirect, okay? Because it can have impact on performance, especially what Anna just talked about, right? But I want you to be rest assured, next week when we talk about security, Anna's going to go through a really great exercise of explaining the different networking options you have for these deployments, but do it in such a way you don't feel like you're a network guru. This is one of the biggest things we struggle with, is like, how do we explain networking to people that generally don't deal with networking? And we don't. So we're like, okay, we're not networking people. How would we do it ourselves? How would we want to learn it? So next week, you're going to hear a really good description of all those different options you have to connect in and outside of Azure. But proxy and redirect are important. It's important to know that because a lot of people may pick a default policy and they'll look at performance and not understand why there might be a performance issue.
Awesome. Thanks, Bob. I think just for the sake of time, we've given people some time to answer. We've got mostly D's and then a few A's and C's. Bob, you want to take a stab at this one?
Yeah, let's just go right at it and say that A and B cannot be the answer because you just said there's a difference depending on where you are. So we've got to limit A and B. And then it just comes down to C and D. And again, proxy, just remember, you go to the gateway, then you go to your server every time. So because those ports have to be known, proxy can't be proxy does not make sense to be within Azure, because within Azure we just know the ports, right? So D is the only choice really that kind of makes sense for the difference there.
Awesome. Thanks, Bob. That is right. Now, the last main topic we want to talk about is loading data. And I think overall, the big theme that we want to stress is that it's just SQL. So a lot of the things that you did in SQL Server are very similar to what you can do in Azure SQL. However, there are some new options and there are a few limitations that you might want to be aware of. So bulk copy or BCP is something that's very popular for moving data. This is available and supported just like it is in SQL Server. We also have this thing called smart bulk copy. It's been documented by some of our PM teams. We have a few blogs as well we can point you to really help in moving data efficiently. We also have this idea of bulk insert, which is something I think you've all probably used before. The main difference here is that usually you go from a file, and in this case, you're actually going to link it to something like an Azure Blob storage, and you'll see an example of that in a moment. But all the things you know about making bulk inserts perform well are going to apply here. Now, when we think about SSIS, something you might be using a lot today in your on-prem world, you can also use the Azure equivalent of this. We have Azure SSIS available. We also have Azure Data Factory, which is a really awesome tool. If you all haven't played with it yet, it's very useful for doing things that you would previously do on-prem, perhaps with SSIS using Azure Data Factory. We also have Spark connectors, and we'll link to a few blogs in the actual module where we've shown it can be actually very efficient to load data into Azure SQL Database using these Spark connectors. You also have the ability to make a copy of your existing databases. For Azure SQL Database, I did want to call out that you cannot natively restore like you did in SQL Server, but you can import a backpack into Azure SQL Database. And in Managed Instance, you can natively restore a database. However, you're going to do it from a URL instead of from a file, similarly to how you might bulk insert, because you don't have access to the file systems where the managed instance is residing. So that's just a few things that I thought of. Bob, I know you have lots of tips on how to load data efficiently into Azure SQL.
Yeah, one of the things that we've just seen with customers is specifically also when you get large amounts of data, get your files into Azure storage natively. There's all sorts of great ways to do that very, very efficiently, and then go do your loading within there. So load your files up into Azure storage and then go use something like a Spark, could be running in a VM or something like that, or do a bulk insert where the server is actually accessing the data. So get your files there and then use the native services in the cloud to go then pull that data in. And again, we mentioned a little bit briefly here that recovery model for SQL Server has to be full recovery. This is why minimum logging is not supported with Azure SQL Database or Managed Instance except in TempDB. But of course, if you get in TempDB, you still have to move that from TempDB into your actual databases. And then one thing that might get you, I mentioned about transaction log rates as a resource limit. You're going to see more of that in the performance module that we're going to do in a couple of weeks. But bulk operations could be affected by this log rate governance. So you might find yourself needing to change your slow a little bit to give you higher transaction log rates, even for a small period of time to do bulk operations, then move it back if necessary. And then people forget about just some tried and true best practices about using batch sizing for bulk copies, and especially the fact that if you're using column store indexes, it is really a great mechanism to high-speed load large amount of data directly into the cluster column store index itself.
Awesome. Thanks, Bob. And I thought, it might be nice as we kind of round out this module to take a look at some demos. So the first demo is around loading data into Azure SQL using that idea of a bulk insert. Now, I wanted to use this because I wanted to show you all how cool this interface is that you have through Microsoft Learn. So this is the module that we're in, and I just skipped ahead to Unit 8 of 9. You can see I already have a sandbox activated. These are good for 4 hours, so I have some time remaining. Let me just make sure this terminal is still active. Looks like it's not. So I'm going to refresh this terminal. But one of the really great things about this sandbox is you actually have the ability to take code, copy it from here, and paste it right into the Cloud Shell. And I'm just going to refresh this real fast so it refreshes. Now, what we're going to do here, if you choose to do it through the browser, is you can use SQL CMD, and we'll use the Azure Cloud Shell. And the Azure Cloud Shell is a way that you can access the Azure CLI and Azure PowerShell from wherever you are. It's already pre-installed and up to date. So that can
Hey,
be
Anna, while you're
something-
doing that, I have a question for you while you're waiting for that.
Yeah,
so
sure.
how much is this going to cost me if I go do this in my Azure subscription? How much do I have to pay for this?
Oh yeah, if you want to go do the
Sandbox.
exercises.
Yeah, how
It's
much does it cost me?
Free.
It's free.
Yeah, so that's a great point.
This is all free. Okay.
Yeah,
cool.
it's free and really easy to get started and use. So definitely go get hands-on after this. So what I want to show you is now that I'm connected using SQL CMD, this exercise is going to take you through some of those steps to actually load data. So I'm going to move kind of fast because I'm going to assume a lot of you are familiar with this sort of thing, but know that you can go deeper later if you want. But what we're going to first do is we're going to create a schema. So this is pretty standard. You create a schema, and then we're going to create a master key. So I'm going to go ahead and create this master key, and I can use that master key to create a database scoped credential. And what this is going to do is basically allow me to use a shared access signature, which is basically a way to use a token to get access to a blob storage account. And in this blob storage account is the data that we want to load in here. So I'm just going to go ahead and run that over here. And now once we have a database scope credential, we can create an external data source. So I'm just going to call it data set. And again, we're going kind of fast here, but I just want to show you how easy it is to use this Azure Cloud Shell, this sandbox, and how we've built some pretty cool labs. And finally, once I've done that, I can go ahead and kick off the bulk insert. And now while that's running, I just wanted to call out a few things that you might recognize from your experience working with SQL Server and managing performance. So a few things that apply. You can set no count to on. And basically what this does is it reduces the network traffic by stopping like the message that shows the number of rows that are affected. You can also do some things. Let's see, what are some things we're doing? We're using tab lock to minimize the number of log records for the insert operation, and we're also using batching. So batching and inserting in batches is going to help us in reducing the network traffic. Of course, there are other performance tips that apply here. We're going to talk a lot more about performance 2 weeks from now, but just wanted to give you a brief example of this. Now this is still running, but once it runs, we'll just give it one more second to run. Once it runs, we'll hopefully see that we added, about 3 million rows. So I'll just give that 2 more seconds. Now, while that's completing, I actually had one more demo, Bob. I thought maybe it'd be cool to do a back-to-back demo before we wrap up the session. What do you think? Are people up for it?
We said we were going to do demos, so let's see it.
Let's see it. Okay, so I'm going to go back into that VM. Looks like this is still running, unfortunately. But what I have here is I have a managed instance. Now remember, in Azure SQL Managed Instance, you can restore natively. So what I can do is just select restore. And for device, the main difference is that instead of connecting to, let me just see if I need to verify this. Oh, looks like we're going to get in. Instead of connecting to the local file system, I actually need to connect to a storage account that I have in Azure. And so in this case, I can go into the Contoso blob container and create a credential. Now notice all the things I just did here is what we did in SQL CMD pretty much just a moment ago. So now we're going to create access, this shared access signature, similar token. And then once we're in the container, we can navigate, for example, to this backup file, select the backup file. It's going to do a basic some scan and some restore plans, and then it's going to go ahead and allow us to do this restore natively. So this will take just a few seconds. Let me just pop over here. It looks like our load did complete. So just to finish out the demo, so you're not left wondering about it, we can see that we were able to insert almost about 3 million rows just from a data file. And you can actually set this up to read multiple from a single file. And this will take just a few moments to complete. Just for time, we're going to go back. But you can see it's pretty easy to do a lot of things you did in SQL Server before now in Azure SQL.
So I'm really impressed, Anna. 2 demos. You did demos in parallel. That's very impressive.
Yeah. Parallel or crazy, who's
but real quick, that last demo you did you just restore a database from SQL Server right into managed instance? Is that what you're doing?
Yeah.
Awesome.
Exactly.
That's great. That's a great story.
Yeah, very cool. Okay, so we're gonna go a little quick through these last few questions. This first question should be easy. You just saw it, we talked about it. Which Azure SQL deployment options support natively for storing a database? So your options are SQL in Azure VM, Azure SQL Managed Instance, Azure SQL Database, and a combination, which is D, which is SQL Server on VM, and Azure SQL Managed Instance. Let's see, looks like we already have a few votes coming in. Bob, just for time, why don't you go ahead and start taking us through this one?
Well, sure, it can't be C. We just said, you can't restore, you told us you can't restore natively to Azure SQL Database, so you can eliminate that. And the fact that you can do it for MI and for VM must mean D has to be the answer.
Yep, so that's an easy one. Looks like all the answers we have come in to this point were D, so it looks like people have got that one pretty down packed. Okay, we're gonna do another one. So we've gotten near the end, we're doing question after question, demo after demo, getting kind of crazy. But this next question,
baby.
Yeah,
way to roll.
Hyper focus. So this next one is should also be hopefully one that you all can get pretty easily, but this one is, what is not an example of how you can more efficiently load data into Azure SQL Database and Azure SQL Managed Instance? So think about this question. This question, again, this is one of the not questions you'll learn throughout the series. I like to use those questions.
Typical professor.
Yeah.
Throw your students off. Yep, seen that before.
Again, Bob, we got some people coming in with some answers. Looks like a few people have said all of the above, and a few people have said simple recovery mode.
Well, all of the above will help, but you said not. So it can't be D. And we said column store indexes and batches will help, but you said not. So simple recovery is the only possible option. And we did emphasize that. Minimal logging is not supported. Can't use simple recovery with Azure SQL. And by the way, there's a very good reason. In order to meet our service level agreements that you're going to want, we can't allow simple recovery databases. If you need that, you need to go to a SQL Server and Azure VM.
Yeah, definitely. Awesome.
Anna, they made it through all your questions. That's
they made
impressive.
All the questions, all the demos.
Think about what we just talked about. We did do a lot. We really stepped up the game last week. Everybody liked the intro, but I hate to tell you guys. I mean, if you like this is great, because guess what? The next 3 after this are going to be even more hyper focused than this. But real quick here, hey, we talked about how to plan your options, your service tier, your core choices. We talked about how that can impact your resource limits. We talked about migration. We talked about new experiences we've even just launched. We talked about Ignite. Anna showed you a really great demonstration of how to easily deploy with the portal. But hey, CLI and templates and PowerShell are all there to have that same experience. We even showed you what options you pick along the way. We gave you methods to connect and verify your deployment. We went over exhaustingly all different types of configuration options you have as compared to SQL Server, including options to connect to your deployment, and then a great demonstration of what are the different data loading options you have, because that's something you're going to do right out of the gate. We picked loading data as the last part of this module because we knew you would deploy, configure, and need to get data in your deployment. So it was a great session, Anna. Thanks for participating with me today as well. I really enjoyed it today.
Yeah, it's been a fun, information-packed session. As always, we have lots of resources for you. The top one there is this Microsoft Learn Learning Path, which you just saw, where you can do all these exercises for free. We also have 2 books. Bob wrote a book last year on Azure SQL, and myself and a few other PMs wrote a book on developing with Azure SQL Database. So lots of resources out there. Lots of videos out there. If you want to go dive deep into this specific module, you can check it out at this AKA up on the screen here. So again, this is what we went through today. This is all the demos we did today. You can get hands-on with them here. And, mark your calendar. Every Monday, same time, same place you were here today. We've done 2 weeks, but we still have 4 more, right, Bob?
Yeah, think about what we did. We showed you what it's about. We showed how to deploy and configure. Why not go learn in the next few weeks? Pick your choice here. Why not know how to secure it, how to get best performance out of it, and how to make it highly available, and then wrap it all up with a great session about putting it all together. I'm looking forward, Anna, to the next 4 weeks together with you.
Yeah, I am as well. And I hope, all our viewers are sure to tune in, like, subscribe, come join us next week. We're really excited about it. And thanks for joining us on Learn Live.
Thanks, everybody. We'll see you next week.
Hi, I'm Anna Hoffman, and welcome to this special episode of Learn Live. Today, I'm joined by Bob Ward. Bob, thanks for joining us again today. Can you tell us a little bit about yourself?
Thanks, Hannah. Thanks, everybody, for joining. I'm Bob Ward, a principal architect for the Azure Data SQL team. And so, great, Anna, great to be back with you again, talking a little Azure SQL. I think today is about security. So excited to be here.
Yeah, excited to have you. We're going to have a great day today. I just can feel it. We're continuing our learning path of Azure SQL Fundamentals. This is a learning path on Microsoft Learn with 6 modules that Bob and I have built and maintained, which means updating them very frequently to keep up with the pace of the cloud. Now, Bob, since people are coming in at the security module that we're in, can you tell everyone like a little bit more about where we are, like where we've been, what we're doing now, and what's next?
Yeah, sure. I mean, if you think and look at this list right here, we started a couple of weeks ago with a journey of explaining really what is Azure SQL. What is this branding called Azure SQL? Being this combination of Azure Virtual Machine, SQL and Azure Virtual Machine, managed instance and Azure SQL Database. And we just talked about the history of Azure SQL, the significance of those different offerings, what to choose when. We kind of went through that whole process, introducing the topic like you would with any good training content. And then last week was all about deploying and configuring Azure SQL. For those of you who do SQL Server today, you're used to installing SQL Server, configuring SQL Server, configuring databases. So we wanted to give you all those kind of type options. But today begins the first module on what we call the meat and potatoes of Azure SQL, which is all about security. And where we're headed next is to continue that journey the next few weeks, talk about performance, availability, and then round it off with, and I know a module you really love, and that's kind of putting it all together in that final week series.
Yeah, definitely. And if you're tuning in for the first time this week, don't worry. I think you'll still learn a lot from this. And all of our previous episodes, so weeks 1 and 2, have been recorded and are available on Channel 9 as well as YouTube. So don't feel like you've missed out. And if you're new to the series, you should go ahead and bookmark your calendar for the same date, same day, same time for the next 3 weeks, because we'll be doing it again. Now, all of this, like I mentioned at the beginning, is related to something on Microsoft Learn. Now, the greatest part about Microsoft Learn is that you can get hands-on with all the demos you're going to see for free because they have a free sandbox environment for you. And I had something kind of fun. I don't know if you'd seen this, of course. Now my VM has locked me out, but let me show you something. Bob, did you know that at the top of our learning path, they're actually advertising our session here?
We've made it to the big time. We're advertised on television. That's awesome.
Yeah.
I didn't know that.
It feels pretty cool. So, you can go in and you can click the save the date button and actually get a calendar invite. So you block off your calendar and make sure you join us for the rest of the sessions. Now, all the sessions we're doing here today are live and interactive. So what that means is that you can head over to Learn TV. That's aka.ms/Learn TV. So from wherever you're streaming from, if you want to interact with us and take part in our knowledge checks, which are really fun, Bob really enjoys them, you'll want to go over to Learn TV because that's how we have it kind of a little bit better organized to kind of facilitate answering your questions and showing the answers from the knowledge checks. And also, we have some wonderful SMEs standing by. So SMEs are subject matter experts from our team, so from the Azure SQL product group, standing by to answer any questions you have about security or really anything related to Azure SQL. They are there to answer those questions. So please keep them coming. All right. So I think we've talked enough about the platform and what's going on. Hopefully you all are ready for the first meat and potatoes, as Bob would say, of Azure SQL. We're going to be talking about security. So what that means for your network, for access, for protecting your data, for logging, keeping track of all this information, and then even some more details into that. And we have quite a few really cool demos today that I think you're going to enjoy. Now, this is the first module that we're really getting into the capabilities and the tasks. So before we get into that, I just wanted to share a few things about the structure of this. Bob mentioned in one of our earlier weeks that we try to breadcrumb everything. So at the bottom of the screen, you can keep track of where we are in the module and what we're covering, just so you kind of get a status of like, okay, where am I? How much more is there? What else are they going to talk about? You can keep yourself updated. But then additionally, for all of the meat and potatoes modules, we've separated things into capabilities and tasks, because this is really important as a data professional. You want to understand, okay, what are the capabilities of Azure SQL Database and Azure SQL Managed Instance? And then what does that mean for me? What does that mean for you? What does that mean for like the things that you have to do as the manager or data professional working with Azure SQL Database and Managed Instance? And, there's a lot of things up on here, Bob, as you think about the things you see here and Azure SQL security, what really stands out to you?
Well, it's kind of broken down into 4 areas, and not necessarily in a certain order, but if you think about what you do with SQL Server today, one of the things you have to consider is how do you implement and deploy and configure SQL Server to ensure it's configured correctly for security points from a network perspective. Like, is it part of a virtual network and how is that protected? Do you have firewalls? You're going to find out what we're going to talk today about Azure SQL with things like private link, some of those kind of type concepts. And I think you're going to like this section. Anna does a really good job here because we really struggle to talk about how much we talk about networking with Azure SQL, given the fact that we've discovered a lot of data professionals, that's not their expertise. So I think you're going to see a great balance of giving enough information to understand about network security, and then working, of course, with your perhaps networking team to go further. So network security kind of starts there, and that's where we're going to start that journey today. Now, you got to get authenticated to SQL Server, and the same thing applies to Azure SQL today, and you need access to the actual SQL instance and the resources. And so what you're going to love about this section is because of the fact that Azure SQL is deployed in Azure, we're going to talk about authentication when it comes to being outside of SQL and in the Azure ecosystem. Remember, we talked about that concept in the first module, Azure Ecosystem. And then we'll talk about how to get authentication access to SQL itself within SQL itself, whether it's SQL Database or Managed Instance. You want to protect your data, whether it's connections, data at rest, data inside the SQL instance itself. And so we're going to talk all about different types of data protection techniques, including an interesting discussion about dynamic data masking, which we found a lot of our customers aren't aware of is available in SQL and in Azure SQL. And then finally, you need to manage certain aspects of security, especially when it comes to auditing. But you may want to understand, like, are there more things in Azure SQL that I get the power of because of the fact that I'm in Azure? So we're going to talk about things like vulnerability assessments, data classifications, and a very interesting discussion towards the end of this module about advanced threat protection. So, Anna, if you combine network security, access, identity, authentication, data protection, security management, we really do believe Azure SQL is an enterprise class capabilities for security, just like SQL Server does. But we're going to show you how to put that all together in terms of capabilities and tasks within the Azure ecosystem. So I think, Anna, the best way to start is maybe talking about the concept of network security.
Yeah, I think it's a great place to start. And, you and I went back and forth on how much network security to include here. But I think we ultimately decided that, it was important for folks to have a general understanding of what's happening so they can work with other teams, other networking teams, but also be aware of how people are potentially getting access to this. What are your thoughts kind of on that?
Well, I struggle with it too, because I'm not a networking expert. But you have to know enough capabilities and how to make the basics of it work, because you need to go to your team to explain, is it possible to secure the deployment of Azure SQL in a way that fits our business requirements? You have to understand, is there a firewall concept? Should I use that? Is there a way to ensure that SQL is not actually exposed on the internet? Is that even possible? Because many people think that's not possible. So Anna, the way I love you've approached this is why not use visualizations and demonstrations to kind of show what is possible with Azure SQL Database and managed instance, enough information for you to then go to your networking to say, hey, this is how it's possible to configure Azure SQL so it can meet our security needs of our enterprise.
Awesome. Thanks, Bob. Yeah, we will get right into that. I did notice we had a question coming in. So again, just feel free to keep sending in your questions. This question is a great question, so I'm going to interrupt our spiel. This guest says, hi, do you have recommendations on which books to read for a beginner? Bob, do you have some thoughts on that?
Love the shameless plug. Whoever that is, I guess the check's in the mail. We're going to talk about we're going to give you a lot of resources at the end. So if you hear us talk about various things and already even mentioned the fundamentals we're talking about today, we're going to give you a resources slide to talk about all different things where you can go further. And I have to admit, and I did go on a journey last year writing a book called Azure SQL Revealed, where if you're a SQL Server professional today and you want to get started with Azure SQL, this is probably could be a good book for you, because we're going to go over all aspects of Azure SQL, including the history of Azure SQL, and a great comparison of how you take your SQL knowledge today and get into Azure itself. And I think you're going to love it, because it's a little bit in a way a deeper of some of the things that we've done already or are going to do further in this series.
Awesome. Thanks, Bob. And we'll put the URL in the chat, but it's aka.ms/Azure SQL book. Okay, so let's get back to network security. All right, so like Bob mentioned, we're going to use some visualizations to get everyone on the same page. I'm going to try to assume that you know nothing, and we're going to all get to the same level. We're going to go pretty deep, pretty fast, so try to stick with me. All right, so this is my simulated Azure environment. What you see first is these 3 blue boxes. Now, these are supposed to represent virtual networks, which is a way of grouping networks and grouping resources together in Azure within a virtual network. So you can see I have a virtual network in West US, and I have 2 in East US, but they are different virtual networks. Now, on top of that, what I have in each of these virtual networks, I have an Azure virtual machine that's trying to connect to SQL, so to Azure SQL Database in this case. Now, this Azure virtual machine has a public IP address, which you're seeing right now, but it also has a private IP address. And while these are virtual machines, you can also kind of substitute in app service or other Azure services that might fall into a virtual network. Okay, so then over here on the right, what we have is our Azure SQL Database logical server, which we're going to try to connect to. And in blue, we also have some information about the DNS hierarchy. So this is going to be publicly available information about your database server, just given the name. And I'll show you that in a demo as well. And then finally, we have this little building that says on-prem to kind of represent an on-prem type of network. All right, so now we have the resources defined. Let's look at the first scenario. So in this first scenario, let's say you set up the option, allow access to Azure services. Now, there are 4 options we're going to talk about today, and we're going to go from least secure to most secure, at least from our recommendations perspective. So with allow access to Azure services, this is really easy to set up. You can set it up during deployment. You just flip a switch, and anything in Azure can try to connect to your service. Now, it would still need to be able to authenticate, but from making a connection, it would be able, from a networking perspective, it would be able to connect. Now, you don't have to set up any of these individual rules. It just happens because you're saying anything in Azure can connect. Now, some of the downsides is that this doesn't allow for your on-prem network to be able to connect, and it doesn't. It makes it so that even it doesn't mean just your subscription in Azure. It means any Azure resource anywhere can try to connect to your database server. So this is great for things like dev test. However, when you move into production or move into more serious workloads, you might consider turning this option off. Now, if you do that, the next option you have is firewall rules. Now, what you'll notice is none of these connections really change, except now we can connect from on-prem. And just like it kind of suggests by the name of firewall rules, what it means is that you can create a firewall rule for each of these services, so your Azure service and your 3 virtual machines. You create 4 firewall rules to connect to all of those things, and that's going to allow you to connect. But some of the cons of this is that you're having to specify a firewall rule. Now, many virtual machines, and especially if you're using VPN, have dynamic IP addresses. So you're going to have to find a way, and there are ways to manage this, but you're going to have to find a way to manage every single IP address that's needing to connect to this database server and then update accordingly these rules. So that can be a bit of a headache. From a securities perspective, some other things that you might notice is that this DNS hierarchy is still pretty public. So we'll take a look in a demo, but you're seeing information about the region that it's in, maybe even the control ring that it's in, just information you might not want to be publicly available about your database server. Now, I wanted to note that you can use a combination of firewall rules and allow access to Azure services. That's something I see people often do, again, in dev test. However, like I mentioned, some things with the firewall rules and then wanting to turn allow access to Azure services off might lead a lot of customers into the next level of security, which is virtual network rules. Now, I want you to notice a few things that had changed. So what happened is now we're connecting from the private IP of our virtual machines. So this is a more secure way of connecting, because what it proves is that we're connecting from within the virtual network as opposed to publicly over public IP addresses. Now, in addition to that, you notice that we're using some virtual network technologies, and I'm not going to talk a ton about these, but these are basically different ways to connect virtual networks or even on-premises networks together. So what we've done here between VNet peering, VNet to VNet, and something like VPN express route is we've connected everything to this virtual network. And then we created so we only had to create one virtual network rule to this virtual network. And now we can connect to this database server from all of these options. So this definitely makes it a lot easier than connecting from firewall rules. But again, it's a little bit more secure because we're connecting from inside. Only the virtual networks that we've specified can connect. Now, one thing I wanted to point out is this public DNS hierarchy is still containing a lot of information you might not want available: the region, the control ring, a public IP address. So what we came out with more recently is something called private link. Now, notice not a ton changed in this picture. We're still connecting virtual networks together and connecting from a virtual network. The big difference is this: we deployed a private endpoint into a virtual network. So we basically gave our Azure SQL Database server a private IP address and said things can only connect through this private endpoint to the database server. Now, what this is going to allow us to also do is potentially turn off access to the internet if we want. So this can make it really locked down and very secure. And finally, what we did is you'll notice now there's less information available in the public DNS hierarchy. So we're only seeing things that we can't really do a lot with. Now, I know that was a lot, so I have a little demo, and we can just take a look at some of these things and see kind of how they work out and how you might actually see things like the public DNS hierarchy. I'm going to switch over to my VM, and first we're going to start with this database server I have. It's just called AWS Server DR. It's meant to be a disaster recovery server for something else that I do. But what I wanted to show you is down here on the left-hand side under firewalls and virtual networks, you'll see that right now I'm using an IP address rule. So I've added the IP address of this virtual machine. And in addition to that, I could allow Azure services and resources access to this server to on. Now, either one of those things is going to allow me to access this database using the what's known as here as the public IP address of my virtual machine. So let's take a look at what I mean by that. So I'm going to switch over to PowerShell, and what I'm doing is an NS lookup on that DR server. And so what we're seeing is a few things. Now, some of these things are kind of interesting. So for example, this address here, this is for any Azure resource. So regardless of public IP address, private IP address, type of resource, you're going to get this Azure IP address returned. However, since this is using a public IP address, you're seeing some information about the database you might not want to be able to see publicly, like the control ring, the region, a public IP address, things like the data slice. These are some things you might not want to be publicly available. Now, another thing we can use is in SQL Server Management Studio, what you can see is I have a very simple query. It's basically selecting the client net address. So this is saying, what IP address am I connecting from? And we can just confirm that we are connected to that DR server. We'll go ahead and connect, and we can run this, and we can see that we're also connecting from the public IP address of this virtual machine. Now, this is going to be the same whether we're using allow access to Azure services or firewall rules. Now, when this changes is if we decide to use virtual network rules or private endpoints. Let me just show you real quick. I have another Azure resource here. Now, this is the non-DR server. And down in firewalls and virtual networks, I can see that I've actually turned off allow access to Azure services. I don't have any firewall rules configured, and I don't have any virtual network rules. Now, if I go into private endpoint, I can see that I do have a private endpoint that is enabled and approved for this server. So let's see how that changes things. So I'm going to go back to SSMS, and we can go ahead and we can change this connection. I'm going to change it to the main server. Go ahead and connect. And we'll run this. And now we're seeing this other IP address. Now, you might be wondering, okay, what is this other IP address? Well, it's actually, let's take a look. It's actually, so this is the virtual machine I'm connecting into right now. You can see the public IP address. What you can also see is now we're connecting from the private IP address, 10.1.0.4. So we see that again here. Now, I want to note that this is the same result that you'd see even if we were connecting with virtual network rules enabled or private endpoint. Either way, we're coming from within the virtual network, and that's why we're getting this private IP address returned. Now, if we only had virtual network rules enabled, over in PowerShell, we would still see this public DNS hierarchy that you're seeing now for the public endpoint. However, with private link, what you get is something different. So you can kind of compare and contrast these two. So we're still getting that Azure IP address, but down at the bottom, we're getting something very different. So we're not getting any information about the data slice, the region, the control ring, any of that information here. We're only getting this, the name of the server with private link.database.windows.net and a private IP address. Fun fact, note this matches the convention of because it's in the same virtual network as this virtual machine, the 10.1.0. That's kind of the virtual network that we're using here. And the interesting thing about all this is that you don't have to change any connection strings. You just keep connecting to this endpoint. So that's really useful if you decide to switch to this at some point in your development. And you can't even try to connect to either of these endpoints either. So that's private link. That's an overview of the things in network security for Azure SQL Database. And, we're not talking about it a lot today. Actually, there's lots more we could go into. There's even some new stuff that's being worked on in this space. But for managed instance, I think a good way to start thinking about it is that it's very similar, except instead of this private endpoint, you basically have a dedicated subnet. So you can think of a subnet as like logical grouping within a virtual network. You have a dedicated subnet where you deploy managed instances into, and then you get some sort of private IP address. Now, I should note, this is something, a fully private DNS hierarchy is something we're still working on for managed instance, but you pretty much get that kind of out the gate. Now, you either have to deploy with this subnet configured, and it has some pretty specific guidelines, or you can deploy a new subnet when you deploy the managed instance with the required configurations. Now, Bob, it was kind of a lot to talk about. Can you kind of take us up a level and tell us, like, okay, how should we think about this, and what should we take away from this going forward?
Yeah, thanks, Anna. People can see maybe why we struggle a little bit in how we were going to present this. But I love, Anna, the way you did a logical step-by-step approach, especially in the database side, about try this option, then try this option, then try this option, and then the effects of how you would see that. So maybe we should look at kind of a decision tree. You're thinking in your term, like, how do I do this? So for Azure SQL Database, I think it was very, very clear, Anna made, if you can do private link, do it. That's the most secure method that we recommend, and it is the most thing that we recommend. And then you would deny public network access. Now, to be clear about that, and Anna, you and I have done this a million times, if you're just getting up and running, if you're doing a little dev Azure SQL Database and it's not production, then this may not be the right route for you, right? But for production scenarios, this is what we recommend. And it could be that that's not possible for you. If that's the case, we still recommend turning allow access to Azure services off for production scenarios. For me personally, when I just spin up a database and doing a dev test type scenario, have a lot of VMs that I play with and use in Azure, I would use this allow access to be on because, again, it's a very quick way to get connected to a database. But for production systems, you would turn that off, right? But then if you turn that off, what are you going to do? How are you going to connect? So you're going to use either firewall rules or virtual network rules. Virtual network rules may be a little bit sometimes more complex to set up, but a lot more flexibility because you don't have to worry about how do I do IP ranges and how do I ensure that they meet the needs of my clients connecting in. So that's kind of Azure SQL Database, how you might approach it. For managed instance, Anna just showed you, you're either going to configure a virtual network as you deploy managed instance or before you do it. Now, let me give you some tips there. Number one, if you're just going to the portal and you're spinning up a managed instance, part of the portal will lead you to the process of just picking a new VNet for your managed instance, and we'll build it for you. There are several requirements for that VNet to work and the subnets within it. So let's say you're going to do it before you do your managed instance. Now, I experienced this when I used instance tools, and there's a lot of requirements there. So here's what I recommend. We have a really nice thing in the documentation for an ARM template. We've mentioned this before in previous modules. You can use an Azure template in the docs. You just point and click. It'll bring up a series of things you fill out, and it'll build all that necessary requirements to get you up and running with a VNet that you can use for your managed instance. So those are the two different scenarios, but here's the most important point. You may be working in a corporation today or a company where you have very specific requirements or policies and procedures for networking for your SQL server. And you're wondering, how do I do Azure SQL? Well, we're trying to give you the basic necessary information and decision steps to make so that you can go talk to your networking organization on how to set this up the right way. So in summary, get up to speed fast. There's options we've shown you, but for the really great recommendations for enterprise class production systems, follow our advice, talk to your networking team, and decide what is the best path for you.
Awesome. Yeah, definitely agree with all that. And, we're about 30 minutes in and we really just dove right into it, Bob. We got right into networking and some of the security capabilities and tasks. I'm going to go ahead and put up our first poll. We have a few questions. Maybe we'll take a few now and a few because there's another knowledge check after this. So go ahead and take a stab at this question. Bob, one question we got in the chat is from Patrick. And Patrick says, is there any impact on latency for either options?
Yeah, I'm not sure exactly the options, maybe just the options we talked about there. But actually, as it turns out, a lot of those options we mentioned are not going to completely affect your latency options. What's going to more maybe affect that, though, is your choice on what we call a redirect or proxy. I think, Anna, we kind of mentioned that maybe in our last module, but that's where latency is going to become more of a factor for you. So double check those options to use when it comes to things like latency.
Yep, definitely. That's exactly what I was going to say as well. This second question, I'm not sure if this is a question or more of a comment, but Jonathan says, this is very handy. I was only setting up a client SQL server today. I wondered if private endpoint would help.
Yeah, I think the key here is that if you're setting up just SQL Server today, think about how you do things in your network or for your clients. How do you secure it? Do you use a firewall? Do you actually put it in a virtual network? How do you secure things in your data center and then translate to what we're doing? Here's the difference. You're in Azure when you put these things in SQL. And so as Anna talked about, there are certain options where certain pieces of information are exposed on the internet. And if you want to totally lock that down, the private link would definitely help you in that scenario. In fact, it was one of the number one requested things we did in Azure SQL Database to ensure that we've highly secured those endpoints.
Yeah, and one other thing I'll add to that, and then we'll answer this question, is I didn't mention, but private link isn't something specific to Azure SQL Database. It's something coming to many services in Azure, like storage and other Azure services. So this is something we're adopting because it's becoming the standard. So we're really investing heavily in private link. And all that said, I think it's going to hopefully make the answer to this next question very clear. So the question is, what is the recommended way to protect your network for Azure SQL Database? And Bob, I'll let you just take it away.
Well, let's use our process of elimination again, even though I think we just talked about this, right? And as you know, I kind of like to do multiple choice answers that way. So if I looked at this and we talked about what we just said, allow access to Azure services is not the recommended way to protect your network. We said it's the recommended way to get up and fast really easy, but not to protect. So that can't be the answer. We did also mention, and you talked about the fact that firewall rules are good, but you still are using those public IP addresses. So virtual network rules and private link are those really two possibilities on the recommended to protect your network. And we just said that private link is the best recommended way because of the fact that you're not exposing information and you've got that private endpoint not exposed to the internet. So I would pick D.
Yeah, exactly right. And it looks like from our votes that are in, about 90% of people said D. So well done. You guys have passed the first knowledge check. Now, this second one, I will say, is much trickier. So,
but that's what you do, Anna. You continue each week to try to trick your audience. You're like that professor nobody wants to get in the class.
Thanks, Bob. I appreciate that.
Exactly.
I'll add that to my title tagline on Twitter.
You should.
Yeah, professor that nobody wants.
That should be the tag. I agree.
Yeah, okay. So we have this other question. Again, this is a more complicated question, but the question is, consider the example from the unit where the Azure VM public IP address is 174.1.7, blah, 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 and the Azure VM private IP address is 10.0.0.2. So these numbers are a little bit different than my demo, but these are some example numbers of a public IP address and a private IP address for a virtual machine. Now, the question is really asking, when you're using virtual network rules, so not private link, not firewall rules, you're using virtual network rules to configure network access to Azure SQL Database, what's going to be returned from this query that basically returns the IP address from which you're connecting to SSMS. So think about virtual network rules and what that entails. How are you connecting to a SQL database server when you're using virtual network rules? So again, this is a little tricky, but I think you can use Bob's process of elimination and probably get pretty far.
Okay. Are you seeing some stuff come in, Anna?
Yeah, I'm taking a look at what's coming in.
Okay.
And also if we have any questions.
Okay.
But it looks like people are pretty split between A and B. Maybe more B's than A's, but it's kind of changing fast.
Kind of a fluctuating poll, huh? Okay.
Yeah, maybe you can give people a tip for those that haven't answered yet and are maybe between A and B.
Well, let's do process elimination to kind of, you said A and B, so it's good that they're saying that, because if you think about this, there's no way that query could be both or neither. Because by the way, when you first said the question, I had to double check it was the right number to line up with what you said. I just wanted to make sure we don't want to trick somebody that way.
Did it?
Well, it did, but I know you're tricky. You might have done that, right? So anyways, so C and D cannot be the answer. So you got to limit those. So it's all down to A and B. And again, let's think about this. You've got an Azure VM public and private IP address, but you're using a virtual network rule, which means that the Azure VM is in the virtual network or somehow tied to the virtual network to the database. And we said that within the Azure virtual network system, it's the private IP address that you're going to be connecting with. In fact, you showed a demo to run this exact query, and those weren't the same numbers you showed, but remember, you went over to the portal and said, oh, well, here's my private IP address, my VM, and it lines up this result. So the answer, therefore, has to be B.
Yep, exactly. And it looks like about 55% of you guys got that. So some people got a little tripped up, and that's okay. This is a confusing topic. I would recommend definitely check out the Learn module, which we'll share again the link to that, and kind of review these concepts. It took Bob and us a while, and we met with a few people to make sure we really understood what was happening here and had a good handle on what that means.
But it ties into the last knowledge check, right? What we said, what's our recommended approach? Because you said that the private IP address is what would be used if you use virtual network rules or private links. So it kind of accentuates what we've tried to teach you with those connectivity options.
Yeah, definitely. So now we're going to move forward from networking into access.
Yeah, again, we just did network security. Remember our little areas, the 4 pillars. Now let's talk about identity and access, which really come down to things like authentication. Okay, today you're using SQL Server in your data center with your client, with your customers, and you may be put in a situation where somebody says, oh, you've got a domain account, here's a SQL Server, connect to it and start going. But somebody had to give you a domain account. Or you might be in a scenario where somebody's going to give you permissions on a server, Linux, Windows, whatever it may be, to do things outside of SQL and inside of SQL. Well, how does that work in Azure? And so if you think about the Azure ecosystem that we talked about, there has to be permissions or abilities to do things to even start deploying Azure SQL itself. So Azure Role-Based Access Control, or RBAC, you'll hear Anna and I use that term frequently, RBAC. And look at that comment, the very first bullet point. All Azure operations are controlled through RBAC. In fact, that statement applies to everything in Azure. For example, Anna and I today have a subscription. We talked about that in the ecosystem, where we have permissions to do things in the subscription. And in that subscription, we have roles like owners. These are, notice the idea of security principal and role-based system. So Anna and I have Active Directory accounts within Microsoft, and then we have permissions within this subscription to do things like owners or contributors or read access. So for example, I could go in a very clever way if I wanted to today. I think I might do that after this session. And I could deny Anna all access to my subscription. That would be kind of fun. You know, it would blow away her demos. Maybe I'll do that in the middle of this.
Really fun.
No, don't do that. But it's really true. So we have roles like contributors or owners. Owners would have obviously more rights than a contributor. But if, for example, if I gave Anna contributor rights to my subscription for everything, she now has access to deploy pretty much anything she wants for Azure within our subscription, within the limits of the subscription. And so notice about the scope here. The scope of these role-based access controls are the subscription itself at a higher level, or even down to a resource group or an actual resource. I kind of love this concept because I could go, Anna could, for example, could create a resource group of several resources for Azure SQL and then limit other people to say, oh, you only have access to go into this managed instance versus maybe a VM or a virtual network within the entire resource group itself. So you have scoping within this RBAC system itself. Now, today it's decoupled from SQL security. So you have this concept of outside of managed instance or database and inside SQL. And if you want to know, like, how does that work within Azure? Because a lot of people only see this RBAC through the portal. It actually applies to anything to do with Azure, including things like AzCLI and PowerShell to do operations against Azure resources. We have other things as well. So, for example, RBAC allows separation of duties if you think about this. Consider these built-in roles you see here on this screen. This is a really interesting concept. SQL Managed Instance Contributor, for example. I can assign Anna that role within my subscription, and now she's only got the capabilities to deploy managed instances and actually connect into those managed instances. If I gave her that role within even a resource group, she wouldn't be able to see things outside that resource in the group itself. So it kind of gives you that nice scoping of doing security rights, again, outside the SQL, Azure Managed Instance, or database. And these built-in roles are specifically designed for that purpose so that you don't have to go through all the different nuances of using RBAC to assign these specific permissions. So we also have something called Azure Locks. I forgot to mention that. That's kind of nice because we could set that up within our sub or resource group to protect resources from being even modified or deleted. Let's say you wanted to set it up in such a way that even contributors within your subscription couldn't delete resources accidentally. I can use that concept. So Azure RBAC is all, again, about setting up permissions outside of the SQL instances for database and managed instance, but it's a very important part of using the Azure ecosystem. Okay, so you've got RBAC, but then it's like, Bob, that's really interesting, but I need to get authentication to Azure SQL itself. Now, in SQL Server today, you have this concept called security modes. One of them is called integrated security only or mixed mode security. You may have seen that as you deploy SQL. And by the way, the default for SQL is integrated only. And of course, that means if you do that, you can't use SQL auth. Now, prior to even just recently, mixed mode, which allows both SQL auth and integrated auth, was actually forced for Azure SQL Database and Managed Instance, but we now have in public preview the ability to set up Azure Active Directory only authentication. And we'll talk about the significance of that in a second. So let's assume you got the mixed mode auth going. You have something called SQL auth for a server admin. So when you actually deploy Azure SQL, even if you have only Azure Directory only, you're going to put a server level principal. You're going to put a SQL name and a password. And for Azure Database, that is a server level principal for the logical server of all databases for the server you're connecting to. Remember, we talked about last week the idea of a logical server for your databases. That same server admin for managed instance will be a member of the sysadmin server role for the complete instance. Now, I jumped ahead and talked about Azure AD a little bit, and you're like, well, I do need Windows authentication. I don't need just SQL auth. What do? We have Azure Active Directory Authentication for that purpose. So let's break down kind of the concepts between logins and users for a managed instance and a database. Take managed instance first. You have the ability to do an Azure AD server admin in addition to this SQL server admin. And in fact, when you do that, if you have Azure Active Directory only set up, that is the only way somebody can connect. The Azure AD only option is interesting because you can create SQL assets like SQL logins. You just can't connect with them as long as that option is turned on. That's a little bit like SQL Server when you can create SQL logins. When you're using integrated only authentication, you just can't connect with SQL logins until you turn on this mixed mode concept. So for managed instance, you can have an Azure AD server admin along with the SQL admin. You can have SQL or Azure AD logins. Then you would have database users in your databases, because it is a SQL instance, mapped to those logins. You could even do an actual contained database, just like we do in SQL Server today. And then we have this new concept that we just launched last year called a server trust group. And we use those for instance-to-instance communications, like a distributed transaction scenario. What about Azure Database? How is it different? How is it the same? So first of all, you too can have an Azure AD server admin for your Azure SQL Database. You also can have SQL logins, just like you would have for SQL Server itself or for managed instance. And then you have something very interesting. For the logical server, we have some server roles, okay, for limited server admin access, like a login manager or a database manager. And you can assign people to those roles to do specific purposes that are not the full admin capabilities. Now, you can do database users with Azure Database to map to the logins you want. But here's what we recommend, and this is a very interesting aspect to give you that feeling of a contained database with Azure SQL Database. Because remember, that's really what we're trying to build here is you just deploy a database. And that is, you can use Azure AD to have a contained database user. Imagine you going in and not worrying about logins, just create your logical server, create your databases, and use Azure AD to assign users to log in directly to the database. And that is our recommended way to use Azure SQL Database. So that's kind of, Anna, like a breakdown of how I look about your options for authentication to Azure SQL, both for database and managed instance.
Yeah, I think it's really useful. And I think that separation of, what you can do in Azure versus what that means you can do in the database is kind of an important call out. We actually had a question from Steph. Looks like they say, so according to the documentation, what you're saying, the SQL roles can't actually access the database. And I get that to a point because we'd never have non-DBAs doing those things in roles. But what we're struggling with is what's the correct roles for our Azure SQL to mirror as we have for our DBAs for on-prem.
So I'm not sure if the question is RBAC roles or SQL roles, but for, let's say, the RBAC roles, there are ways to control, and think of it this way. Think about who has access to go deploy a managed instance, for example. So just like today in your environment, you have probably permissions about who has the ability to do setup for SQL Server, and the same concept for Azure, right? That's one big thing. Or who can manage, for example, who can go change the scale for managed instance in the portal versus access within SQL. And then if you think about what's inside Azure SQL, the same concept of roles that SQL supports, that's all there for managed instance and Azure Database. So you can still use all those same concepts within your deployment, but you need to first think about who's going to have access to do things outside the deployment. It could be, by the way, that all you do is give someone specific access to do all the deployments of your needs. And then you're going to give, let's say in our scenario with our subscription, I might be the person that controls everything to do with deployments in Azure. And the only permission I give to Anna is the ability to go connect to Azure SQL and not do anything about the Azure ecosystem itself. That's very, very possible to do that.
Awesome. Thanks, Bob. I think that really helped. And if we kind of take a step back and think about, okay, we talked about the capabilities. So what does this mean for you as you go to set up and configure authentication? Now, what I really like about this is that you deploy with your SQL Server admin. Your admin can create other admins. Sometimes maybe that includes an Azure AD admin. Then those admins can create users. And then this is a great part of a lot of what we do in this series is you grant access just like SQL. So at the end of the day, the way you do all those things are the same way that you would do it in your on-prem environment. So we thought it'd be cool to kind of take a look at an example, give us a little break. So what I'm going to do is I'm going to hop back to my VM, which keeps locking me out. And what we can see is we're going to go back into the portal, and I'm going to go to this database. Let's see which one. Give me one moment. So if we go to the server, what we can do, not this server, sorry guys, give me 1 second. Let's go to this server. In the security, in the settings section, we see this option for an Active Directory admin. So that's what Bob was talking about, how you can have this Azure Active Directory admin. And you can note that I've set it here to myself. One important thing to notice here is you can only set one admin here. So if you want this to apply to multiple AD users, then I recommend using some sort of group here instead of a single user. But once you have an AAD admin, then you're able to do things like connect to SQL Server using AAD. So you can see here, I'm connecting to that AW server with my Microsoft or AAD credentials. Now, once I'm connected to that, then I can start going ahead and, just like SQL, granting other users access. So for example, I might start by connecting to master. Let me just make sure I'm connected to the right server. Yep. Okay, so what I can do is I can connect to master and create a login with a password. Now this is something you would do in SQL Server. Now then I can create a new user in a database for that login. So create user for login. And finally, just like SQL, until I give users access, they have no access to read or write data, just like SQL. That's a pretty simple scenario, straightforward. And really what we're trying to show you all is how it really is just like SQL. Now, Bob talked about this idea of contained database users, and this is kind of the standard that we've used for Azure Active Directory, but it's also something you can do in the context of any user database with SQL logins as well. So for example, I'm connected to a database, and what I can do is I can create a new user in the context of that user database. So notice I'm skipping login, I'm just giving user with password. And I had to create Bob Loves Tennessee. I don't know if you guys knew this about Bob. He's a huge Tennessee Titans fan. So his password even relates to Tannehill. Okay, so now Bob can only log into this database. So something interesting about this is this means Bob really only has access to that one database. So he has to put in this database credential. And in fact, if he tries to browse the server, he's not able to. So he's not even able to see what the other databases on the server are. Okay, so now Bob can just log in to only this database. Now, finally, and this is the thing that's a little bit different from on-prem, is this new verbiage around create user from external provider. Now, when it comes to Azure AD users, they must be created as contained database users. So you can use this create user from external provider. You have to be connected as the Azure AD admin. So I couldn't connect as the SQL admin and do this. And then just like SQL, in order for Bob to read or write data, he has to be given access to do that. So this is just a really simple example of how creating users compares to on-prem world. And Bob, in your experience, how does it compare?
Well, think about what we just did. I mean, the SQL stuff you did is just about the same. About the only thing you really showed differently, quite frankly, is this ability to do users that are not logins, which I love. I think people will love that concept. So a lot of stuff you just showed seems very familiar to me. I think the biggest difference that people will find is this RBAC stuff, that you've got to go find a way to set up your access within the Azure ecosystem to even get to the point to deploy or manage your SQL resources. But you know what, Dana? I mean, for me, somebody I've just used Windows, domains, and Linux servers and so forth, it wasn't that difficult to get involved and understand the whole RBAC system. But I just love your demo because once you get all that set up, connecting into SQL, granting all the access. I love the fact you showed those roles because that's everything. You do this stuff all the time. You get a new login, a user, you give them the database reader or writer roles just to get access to data, and you just move forward and use it just like you use SQL today.
Awesome. Yeah. And so now we've kind of talked about identity and access. The next thing is protection. And this is really important. Bob, can you tell us more about encryption?
Yeah, but think also when we just got to that breadcrumb, right? You know, you set up, think about it's almost a little bit in the order how you might do a few things. You set up connectivity a certain way for your assets. You've got RBAC set up, right? You got SQL authentication to get access to stuff. And then now you want to go protect your data. And it all starts with encryption. And SQL's got a really great, rich set of capabilities here that you may be using. So a lot of people don't really spend a lot of time on this, but you probably use this more than you realize, is encrypting connections itself. And what you'll kind of like about Azure SQL is that we enforce connection encryption for database managed instance, provided the client driver you're using supports that. Now, you're asking yourself, well, I don't even know if it does. Well, the newer drivers all just do. And so using connected encryptions is just happening naturally. Or you're going to find out in our best practices, though, you should set that in your client connection because otherwise we have to do some negotiation to kind of enforce that policy. Now, it could be, though, that what you'd like to do, you'd like to protect yourself from older client drivers to ensure that they enforce this. So you can set what's called a min TLS version, TLS being the protocol we're using for encrypted connections. And so as it turns out, there are certain versions of TLS that are better than the others. And so you can even specify a minimum TLS version. You can do that at the time you deploy your Azure SQL assets or configure it after the fact. And so that might be a way to ensure you're rejecting the older client drivers that don't enforce or don't even work with encrypted connections. So that's the connection side of things. Now, we have standard data level encryptions that we support just like in SQL Server. So we have column level encryption. We've had that for a very long period of time. And then we have transparent data encryption for data at rest. Turns out that's on by default in Azure SQL Database and Managed Instance. You can disable those, but it's something we recommend you use in our environments. And there's an easy way to do that when you deploy through the portal, or do that also with your standard SQL commands that you've used just like with SQL Server. Now, you may not have heard of this technology. It dates all the way back to SQL 16 and now enhanced in SQL 19 and Azure SQL, called always encryption. And that diagram here to the right kind of explains a little bit of how it works. So think of an end-to-end encryption scheme where pretty much the owner of the application or the business owners control actually the unencryption part of this story. So in SQL Server, we're going to be storing location to where the keys are for the encrypted data, but it prevents things like admins from going in and looking at unencrypted data that has been protected with always encrypted. Now, if you're worried about managing those keys, Azure Key Vault is something that's very nice that can be integrated with this story or with any of our encryption stories with Azure SQL, even the ability to bring your own key and store that in the Key Vault. And then one thing we just announced recently with always encrypted is the ability to secure enclaves. We announced first the support for that with SQL 19 in 2019, at the end of that year. And now in preview, we have the ability to do enclaves with Azure SQL Database, where the unencryption happens actually on the server side. And the way we implement this is that there's a new set of Azure VMs that support Intel chip technology, where the enclave, which is a memory region on the server engine, this is where all the unencryption happens. So you don't have to use all the way across the wire to go back and do things like certain levels of expression detections. And it actually opens up new rich query capabilities. So that's something we really encourage you to go take a look at if you're going to use this always encrypted technology.
Yeah, this is definitely a really hot space that we're in. We're investing a lot here, and it's really interesting to see what the team continues to do as the technology advances. Now, another part of protection might be masking. Now, in SQL Server and Azure SQL, we have this idea of dynamic data masking. So you're seeing an example on the screen here. Let's just take a quick look at it. So we have this T-SQL available that allows me to do things like mask sensitive data. So in this case, we're masking a first name, an email, and maybe even a discount code. And you're seeing we have different functions that we can apply. So we can apply a partial mask with some X's. We can apply an email mask, which is specific for emails, or some sort of random mask and say, hey, just put a random value between these two numbers in. Now, if you want access to any of that information, or you want someone to be able to see it, then you can grant unmask to a specific group or a specific user. So in this case, we have a role. This isn't a built-in role. This is a role for the scenario called data officers. And in that situation, they need to be able to see this data. But for normal end users, they shouldn't be able to see this data. So from a select statement, what you're going to see here is, as a normal end user, what you would see. And one thing to note is that you are seeing random values in that discount code. And then the role data officers are able to see everything that they need to see. And there is one more thing that you get in Azure SQL that you don't get in the on-prem space, and that is this idea of getting recommended fields to mask. So what you can see here is just a screenshot from the Azure portal where you actually go into that dynamic data masking blade, and there's actually some recommendations for you of what we think you should mask. So what type of sensitive data you should mask. And there's a really interesting exercise in the learning path, in the Learn module, that you'll hopefully go complete, where you actually go through setting up data classification, which we're going to talk about, auditing, and dynamic data masking all in one kind of end-to-end scenario. So definitely something cool to check out with regards to dynamic data masking. Now, when we talk about, okay, we talked about the capabilities, now let's talk about the tasks. How do you set this up? How do you configure it? Now, ensuring your application's forced connection encryption is going to be very important. You're going to want to set the TLS version, minimum TLS version, to the highest, which at this point is 1.2, if your application is set up for that. If you can do that, definitely recommend doing that. You want to evaluate your use of transparent data encryption, or TDE. Note that this is on by default for new databases in Azure SQL Database. So if you're migrating, you need to evaluate if you want to turn this on if it isn't on already. Talked about dynamic data masking and how to take advantage of it. And then really, if you want to go for advanced protection, you can do something like leverage always encrypted. Bob, do you have any other insights on this section and data protection?
Yeah, thanks. One of the things about always encrypted we get common questions about is like, is it really, really limited? And so, things like join, group by, distinct, those common operators you do in things like equality comparison and so forth, that stuff's all supported. So that stuff works as always encrypted. Enclaves opens up that space a little bit more, but it's important to know that some of the basic operators, again, join, group by, distinct, those kind of type things, they all work with always encrypted.
Awesome. Thanks, Bob, for that tip. I think that might be a tip for something coming up in a knowledge check. So hopefully people caught it. I would never do that
to your audience, and would never help them.
You would never. So we're going to go to this first question. This question is about dynamic data masking. Hopefully not a tricky question, but the question says, how can you manage who has access to view masked data? So this is data that's already masked. How do you manage who has access to actually view that masked data in its unmasked form? So hopefully that's a little tip for you. I'm going to take a look and see if we have any questions coming in. Go ahead and post your questions if you have them. Okay, so I do see one question coming in. The question says, do you know any impact on performance after enabling encryption? It's a good question, Bob.
There is always an impact to performance. It's just a basic fundamental nature of doing encryption. It's just a matter of what the impact might be. So for example, TDE, there's a little bit of an impact there, just the basic way the TDE works. But notice that we put it on by default for Azure SQL. We've seen enough customers that feel that the performance impact is negligible enough compared to the benefits that they get from that. Always encrypted? Absolutely. There can be some performance degradation for that. And you hate to say the word it depends, but unfortunately it does, depending on how you set that up. But like always encrypted with secure enclaves can be actually a more efficient way of doing things. Building indexes and so forth, because of the fact that we don't have to exchange with the client the entire time. But even connection encryption requires a negotiation between the client and the server to ensure things are ready to go. But this is where you can help things, because you can force encryption on your client to kind of reduce that traffic. But Yes, there always is some penalty with encryption. It just depends on what that penalty looks like compared to your needs to trade off that security with performance, and it depends what options you pick to do. Dynamic data masking, for example, there's no penalty. It doesn't matter because it's a very easy thing for us to look up to decide how to go, what we're going to return from a result perspective.
Awesome. Thanks, Bob. Hopefully that was helpful to our viewer. Okay, let's take a look at this question. Bob, it looks like most people are coming in with the answer B, but a few people are saying D as well. You want to take a stab at this one?
Let's do process elimination again, because we're just teaching people to do these things along the way. So how do you manage who has access to view the data with mass data? So it can't be C, because that's the whole purpose of doing this, right? It can't just be anybody. And it can't be you can't, because that is the idea of doing access to view mass data. When you set up masking, your idea is to set up the mask and then who access it. So it can't be A. So it comes down to these final two here. And notice the answer for D, add masked with T-SQL. That is to add the masking. That is not about who has access to what's masked. Therefore, the answer must be B.
Yes, so it seems like some people got a little tricked about what the question was asking, but add masked with is how you can create the mask, like you said, not how you can kind of manage who gets to see what the mask data is. So it looks like about 85% of you guys got that. So well done. Now we have a question about always encrypted, which Bob threw in a little tip about before we started this knowledge.
What are you talking about? I don't know what you're talking about. Yeah.
So hopefully you were paying attention to that. This question says, when doing equality comparisons on encrypted data with always encrypted, which operators are currently supported in Azure SQL? And Bob, we had another question that came in about always encrypted. They said, once I enable it, can I disable it at a later time?
You can. Always encrypted is set up at the column level. So it's T-SQL or actually tools based with Management Studio. So yes, you have the ability to go turn that on, turn it off as you need. There are certain operations to go through that process, but absolutely. If it's something that, and we actually recommend that you do that. Obviously, with anything like that, you need to be testing out that type of functionality. But it's a column level setting you're doing with your tables. And again, you need to make sure you have your keys set up right. You have something called an attestation service you've got to deal with. There are some complexities to get it going, but it's a very nice technology some of our customers have taken advantage of.
Awesome, thanks. And then one more question. This one's about data at rest encryption, or for TDE. And this is talking about, your key management, I think. They say, can we use an on-prem KMS server for data at rest encryption TDE?
You have the ability to bring your own key, that kind of type thing. You're probably talking about like the HSM type systems and so forth. So what you really have today is to bring your own key technology, which you would integrate with something like Azure Key Vault. That's your way of having that kind of type functionality.
Awesome. Thanks, Bob. All right, let's take a look at this question. Looks like we've gotten 14 responses. A few more responses are coming in, but it looks like we've got 100% of people saying one answer, and that is D, all of the above. So, Bob, what do you think?
Well, I don't know why that would be the case. I mean, I'm not sure, what's going on there. But, what we talked about specifically about always encrypted was a quality operator, comparisons with these operators. And, the answer, if you just look at this, I even mentioned specifically join and group by, right? So just those two alone are both applicable, which tells you it can't be A or B because it's both, and it can't be C because I just said A and B. It's D is the only possible answer. And we just wanted to emphasize the fact that those type of operations are all possible for you with always encrypted.
Awesome. Thanks. I think we have one more knowledge check coming up in this session, but now we're going to move into security management. So we've talked about network security, identity and access, data protection, and now kind of how do you manage, how do you monitor, how do you get alerts? And the first thing we're going to talk about is auditing. So if we think about it, at a high level, you can audit Azure level activities with Azure Monitor Logs. And this kind of makes sense that you're going to be able to audit those Azure activities with Azure Monitor Logs. Now, when we think about managed instance versus database, let's start with Azure SQL Managed Instance. This is using SQL Server audit. So this is just using what you used in SQL Server. The biggest difference here is that those logs are going to be stored in Azure Blob Storage. You also have the option to use target endpoints of Azure Monitor Logs or Event Hub for this. And when it comes to the options, you have failure or continue, but no shutdown. And that just has to do with the fact that we're keeping your server on. Now, when we think about Azure SQL Database auditing, it's slightly different. It uses this thing called Azure SQL Audit, which is powered by SQL Server Audit. And most of the server and database audit action groups are supported. Some of those default action groups include batch completed group, successful database authentication group, and failed database authentication group. So you can keep track of those things. And a few other things that are kind of new is we recently released the addition to audit Microsoft operations. So what that means is if you open a case with support and we go and look in at your database or try to do some analysis, you're going to be able to turn on the capabilities to audit what was done during that investigation. Now, you'll also be able to store and analyze your general audit logs in various places, in Azure Log Analytics, in an Azure storage account, so that's where those XEL files might go, and in Azure Event Hubs. And like I mentioned kind of earlier, in the exercises, there's actually an opportunity to combine these things all together and take a look at the X event log files that are stored in Azure Blob Storage and take a look at the log analytics dashboard and try to figure out when various things happen. So this can be very useful. And we'll do more on that on the Azure Log Analytics capabilities in coming modules as well.
Yeah, now before I go further, I just want to clarify one thing on one of the questions that came out, because I'm not sure I fully understood the question, but they've been talking about an HSM, which is a way to do extensible key management. So Azure Key Vault has now capabilities to something called a managed HSM. It's in public preview. So go take a look at that if you're looking for the ability to use like custom key type management. Okay, so when you think about auditing, you think overall just more about monitoring and managed security. And so kind of take a step back. If you're looking at monitoring access to Azure SQL resources, you got to look at activity logs. You may even have like event logs today or journals with Linux where you look at these kind of outside operating system type activities. So for Azure, since we're a platform as a service, you need to use activity logs and even RBAC auditing to monitor Azure itself outside of SQL. If you look at Azure SQL Managed Instance, as Anna just talked about, you're going to want to configure SQL Server Audit for Azure Managed Instance. That's going to be a normal way for you to monitor what's going on inside in the actual managed instance. So that's an important concept. And one of the things to keep in mind there, Anna just referenced this a little bit, when you do SQL Server Audit, remember the target for that audit, you do not have access to the file system, so you're going to be doing something different to put this thing into Azure storage. But it is the full SQL Server Audit capabilities with some exceptions, specifically because you can't restart the managed instance. Now for SQL Server, forever, since I've known SQL Server, by default, failed logins go into the error log. You ever run into that scenario where somebody says, I'm trying to connect, I get a login failure, but I don't know why? Well, for very secure reasons, we don't tell you why you can't log in, because somebody would try to go figure out that, oh, it's a bad password, and you would start using that as a way to inject yourself and attack SQL Server. So login failed is a generic message. What you have to do is go into the error log to figure out a state number and more details of why that login failed. So that exists with managed instance because you have access to the error log, and failed logins by default are on. Now, we also have the ability in the engine to track successful logins through a configuration option, but you got to restart SQL Server, so you don't get that with managed instance. However, you have X events. So you can use extended events to actually track both failed and successful logins yourself, redirecting that X event session to say like an Azure Blob Storage for you to analyze later. So for Azure SQL Database, just like Anna talked about, it's called something slightly different using the same technology. We call it Azure SQL Auditing. So configure that for your Azure SQL Database. I had an example, Anna, just recently where I was having a login failure using the new SQL Insights technology that maybe you've heard about as in preview, and I couldn't figure out why things were going on. And I turned on Azure SQL Auditing to figure out why were logins failing. So for example, those state details I just talked about that you would see in an error log, you get to see that in Azure SQL Auditing for your Azure database. So you can solve a problem why somebody can't authenticate and get into your database deployment. Now, one of the things about Azure Database that's interesting, though, is we provide DMVs, metrics, and alerts at the Azure Monitor level or within SQL at the logical server to track events or aggregates of things for auditing for Azure Database. So for example, sys.event log will track things like what you see here, the number of successful or failed connections, or the number of people blocked by a firewall. Therefore, you could do an alert to say, hey, am I seeing a large number of people that are getting blocked by the firewall? I may have set up a firewall and all of a sudden somebody's trying to attack my instance. I could use this to actually go alert myself or see metrics about that. So that's something unique to Azure SQL Database to see things at a more aggregate level, DMVs, metrics, and alerting. Now, however, just by doing this alone, you may want something more. You may get alerted to more advanced ideas. So there is a way to set up alerts for something called advanced threat protection. And we integrate with something called the Azure Security Center. So in total, you can see all the different things you can do to monitor and set up management for security. But Anna, I think that leads into a topic that we should kind of close on a little bit more, and that is this advanced concepts for security. Would you like to know a little more about that?
Yeah, definitely.
Yeah, so we actually used to call this advanced data security. It was kind of like a term we used. And last fall, we kind of separated this idea of classification with a branding called Azure Defender. Many of you have probably seen Windows Defender from a Windows perspective. Azure Defender being a suite of services across all of the Azure ecosystem, and Azure SQL plays very well into that. So you do have this concept of called data discovery and classification. We introduced that with Azure SQL and SQL 19, the ability to go in and label things within your database at the column level so that you could go in and kind of investigate what types of data are in my system and how secure are they. And maybe things like GDPR classification could be something you could benefit. But the other benefit you would get is you would be able to audit with SQL Server auditing that we talked about anyone who accesses what you've classified in your system. We'll look at a demonstration of that in a second. Azure Defender really comes down to two sets of services that we're going to provide as part of your Azure SQL deployment. And what I love about this technology is we really try to make sure this is something we offer across all of our Azure SQL assets, whether it's virtual machine, database, or managed instance. And we're even starting to go down to the path of looking at this for Azure Arc. Vulnerability assessments are us. Think of this like a proactive best practices of us looking at your configuration deployment and giving you suggestions of things you should take action on. And what you'll love about this, Anna, this isn't us just making this stuff up. We're actually using industry benchmarks to go out there and look and see what are best practices we can apply to look at your actual deployment. It's more of a configuration thing, though. But you want something more. Maybe you would like the ability for us to proactively look at people accessing your Azure SQL resources and give you advanced notice of those things. And we call that advanced threat protection. So one example that we've seen here, this is one of the biggest reasons we did this actually, was things like SQL injection attacks. So imagine you've got people constantly out there, and quite frankly, it happens even in maybe your own data center, that are actually trying to go and attack your deployment. And one of the things that they do is something called SQL injection, where they try to run queries against your database. And often this is done through sometimes poorly designed applications where people can go into like a form and type in a string because they know you're taking what you type in that string and attaching that to a dynamic query and throwing it to your SQL server. But what about other things like detecting unusual access to your deployment? And if, for example, you may have set up that network security pattern like you talked about with certain VNets and so forth. What if all of a sudden somebody is trying to connect to your Azure SQL Database resource from a region or something else you didn't even anticipate, and it's happening out of nowhere? Well, we can detect that kind of activity and alert you to that. And what I love about this is that it not only allows you to have alerting capabilities, both at like a text and an email scenario, but it also ties in to the overall Azure Security Center so that you can see this across all of your Azure resources. I think, Anna, perhaps the best way to really look at this is perhaps to see a demonstration of this.
Yeah, so, I'd love to take a look.
Yeah, let's go take a look at it, right? Let's see in action. I mean, you've really done a lot of great demonstrations today. So let me go ahead and share my screen. Let me see, give a few seconds here, and we'll let that kind of come up.
I can see it.
Perfect. So what you're looking here is an Azure portal, and you've noticed here on this left here, I have pre-selected this data discovery and classification option. Now, you do have the ability with T-SQL to do that, and even look at this, Anna, look at this. You now have the ability now, we're starting down the path of integrating some of these capabilities with that new thing you've heard called Azure Purview. So we're even getting comments and giving you guidance about going down that path. Let's look at just classification as we see it from the Azure portal. Again, you can do this with T-SQL, but what we're doing here from T-SQL is we're looked at your database and we've looked at your column names and said, you know what, we might have some recommendations for you. So you can click here and then notice here for this is based on AdventureWorks example. I can go here and see for all these column names recommendations for the type of data it is or what we call a sensitivity label. So for example, we know a little bit about GDPR. We've spent some time looking at that, and we happen to know that names are something that are part of GDPR compliance. Now, it doesn't mean that we're going to make you compliant, but we're going to help you along that journey if you use our recommendations. So I could take this entire list. I could say select. I could say accept recommendations, right? I could then save those recommendations. It'll take a second to save off this data, successfully save this now. I can go back into overview and look at this. I get a graph to show me what are the different labels I have from a sensitivity perspective. Here are the GDPR ones, for example. And then here's the type of information I have. Now, these are rules built into our system to discover what you have. And it's purely based on the names of the columns you put into your tables. But you also have the ability to go configure and add in your own rules manually, either through the portal or do that through T-SQL. So that's data discovery and classification that comes along with what you're using with your Azure SQL deployment. Now, I also can do something with advanced threat protection, Azure Defender specifically. And you notice here in the portal, I have two things that I'm seeing here. One are incidents and alerts, and you can see here I already have a potential SQL injection. And the other are vulnerability assessment findings. So let's look at vulnerability assessments first. Now, what we have here is we have an ID system, and we use that ID system to build and classify in our own internal systems a series of rules. Now, notice here I can go click on one of these, like minimal set of principals should be allowed as fixed members. It's a rule that we provide. And again, what we're doing is a scan of your system, of your deployment. And notice these recommendations we give. Now, I love this for one particular reason that people don't realize. Today, you may be looking at a lot of these different checks at a database level, but does anybody ever go look at their master? Like in this case, this is your logical server. So if you want to, based on this, we could make sure that you're tracking all users from an auditing perspective, or maybe setting up a server level firewall will make sense for your system. Let's go pick on something like database owners are expected. You notice here, Anna, that I've got a risk level. So we actually take a look at some of these rules and say, hey, if you don't have this set up right, we think you're at a high risk. But you want to go in and take a look more at the rules. Like, how do you guys really decide this thing? We give you a description. Notice here, this is that benchmark I was talking about. There's something called FedRAMP, which is an industry standard. So we're looking at FedRAMP as a rule and applying that to your deployment. We even tell you what the query we're using here. So I'll just pull this on you. We can tell you what SQL query we're using. You could actually look at that in the query editor, and we give you a remediation script. So if you wanted to do this, you could actually run the script to actually make sure the rule doesn't fire again. But Anna, you may look at this and notice this is interesting. This is actually a rule set up for doing elastic jobs. So you may say like, look, this is actually allowed in my system. So you could approve this as a baseline, and future scans we do, which we do periodically, we would not fire this rule again. So it's a way for you to decide and customize the rules that you want applied to these standards. Or you could clear the baseline and have us in the next scan pick it up. But let's go back and look at, let's see here. Let me go back and look at more of the injection attack scenario. Let's go back here. Let's pack the database. Let's go back and look at that SQL injection that I mentioned earlier. So I click on this. We're going to give you a lot of information. In fact, I had one happen earlier last month. This is one that happened just a little bit recently to me. So I'd like to know a little bit more about that. So I can click on here. I get a lot of interesting information. I can say click view details here. And now we're going to go in to tell you, like, where did it come from? We're going to give you investigation steps, and we're going to give you the entire SQL statement. And I notice this pattern, this string pattern. For those of you that kind of follow these type of technologies, this is somebody taking like part of a where clause that somebody built into a form and added in special strings so they can try to run extra commands after this to do things like drop your database. I'm sure that's not something you'd like to do. But I love the ability to look at this because we're going to give you details of the query, who did it, how you can go look at it further in the documentation. We give all sorts of documentation about this. And the beautiful part about this, Anna, is that we can alert you to this. So let me go over and show you this right here. Guess what happened when I turned this on? I got an email. I got an email to show me that I detected a possible exploitation of a SQL injection. So I'm monitoring my email. I can look at this. I can go and hit view alert to see the details in the portal, what this looks like. So I'm giving you that actual proactive notification. And then finally, if I go back over and look at this again, the other thing you can look at here that I really love is I can go in the security center of my overall Azure resources, look at Azure Defender. Now, check this out. I'm seeing all this type of coverage across everything I'm doing in Azure, whether it's a server, a Windows or Linux server, a SQL Server and VM, a Kubernetes cluster, Azure SQL databases. I get graphs to show me alerts over time. I love this. If I'm somebody that has to worry about my security and Defender notifications across all my Azure resources, Azure SQL is a part of this, but I see this across all my Azure resources. So, again, Anna, I got data discovery and classification to help me with things like GDPR. I got vulnerability assessments. I'm getting best practices from Microsoft based on industry standards. And I get this idea of Azure Defender where we're looking out for you to see who's attacking or accessing your Azure SQL resources.
Yeah, I mean, I definitely think it's a great set of capabilities. And, one of the things I think is just really powerful about advanced threat protection is like how fast that alert comes in. Like in the exercises, you can trigger this yourself, but like it comes in within seconds. Like within seconds, you have it in the Azure portal. And then a few seconds later, you get an email alerting you saying, hey, this thing happened. So it's really powerful.
And remember this, Anna, I can set that up so that it goes out and does that same detection across SQL and Azure VM, Azure SQL Database and Managed Instance, and even your existing SQL servers. We have it across your SQL resources, the same technology we're giving you that power of Azure Defender.
Yeah, definitely. I think I did a data exposed episode with one of the PMs for that, and he said, Azure Defender for SQL anywhere.
Yeah, there you go. Exactly.
Pretty powerful.
Yeah.
Okay, so what you guys see is the next set and the final set of knowledge checks. We have some knowledge checks, some important things to close out on before we wrap up. But this first knowledge check is about T-SQL auditing. Now, notice we didn't explicitly cover this, but I think you should think about what you do and don't have access to when you think about this question. So the question is, which of the following T-SQL for auditing is not supported in Azure SQL Managed Instance?
Okay. So are we seeing anything come in on this already? Because you're right, we didn't really call this out. And once again, Anna the professor tries to pull a trick on our audience.
Yeah, that's what I do. You know what? I think we actually have another question being displayed. Let me go ahead and we'll skip ahead to that one, and then maybe we can come back to this one if there's time. Give me 1 second.
So we have another question that you're jumping ahead of your audience, give them a harder question.
Yeah.
Back to the tricky question. Okay, I got it. Okay, got you. This is the one they're seeing then, right here.
Yeah, so this is the one they've been answering. It looks like we've already gotten a good number of answers in for this one, but this one is, which of the following are ways you can monitor security-related events for Azure SQL Database? Again, maybe not one we explicitly called out, but hopefully you'll be able to figure it out.
Oh, no, I think we mentioned this one. I think we did cover this, yeah.
So, Bob, I'll go ahead and let you take a stab at it. It looks like a lot of people have said D, a decent number of people have said C, and a few people have said B.
B, okay. Well, let's look at this. Which are of the following are ways, which here you go again, are ways. So honestly, you kind of gave them a little bit of a clue when you said ways. I mean, somebody could say, well, she just meant one way, but you did say ways. A is definitely true. We just covered that. We said, hey, Azure SQL auditing, I even gave you guys an example of that. Specifically called out that we have like DMVs where you can go look at the number of successful and failed connections and blocked by firewall. So B is true. Now, if A and B are both true, right, it can't be A or B because they're both true. Therefore, they're eliminated. And it can't be C because A and B are both true, right? Even though Azure Metrics Alert is true, so D is the only possible answer. And we did say that. Use Azure SQL Auditing, or you can actually do Azure metrics. Remember, I even gave an example. Do an alert to say how many people are blocked by a firewall for I see a large number of those. So D would make sense.
Awesome. Nice work. A decent number of people got that one.
Okay.
Right. I'm going to pop back up this question. I think we might not have it in the polls today, but I still think it's a good one for us to talk about. Bob, why don't you take us through this question?
Sure, absolutely. So which of the following T-SQL for auditing is supported? Oh, no. It says is not supported. There is, once again, Anna Hoffman. So I'll quick mea culpa. Anna did trick me on these in some cases, and I actually questioned her. I'm Bob Ward, right? I said, Anna, no, going, Anna, hey, I don't think this is right. And she's like, well, why don't you read it again, Mr. Ward? Little old Bob Ward, why don't you read this? And I did. I'm like, oh, you said not. So this is the key here. It's a not, right? So T-SQL auditing, not supported, okay? So look at this, what we talked about. We said you can do SQL audits to Azure storage, and therefore the answer A can't apply because it says not supported, right? We talked about doing auditing to things like event hubs or other resources. So B works, therefore not doesn't apply. And it can't be all of above because A and B, can't apply. So the only possible answer is C, but we specifically said you don't have access to the file system. Keep that in mind with all of Azure SQL paths, database and managed instance. We're abstracting you from the VM, the operating system, and the file system. So guess what your file system is? It's Azure storage. So when you do like X events or auditing and so forth to a file system, you're going to use Azure storage, and we're going to give you capabilities to actually do that.
Awesome. Yeah. Well done, Bob. And it looks like we tricked about half of the people.
We have it. We have a poll. We have a poll up for it. Okay.
Yeah, it did come up. It looks like a lot of people said C, but some people said all of the above. So they missed some of the not and maybe got. Well,
even if you said is, right, it couldn't be that because you can't do the file. So, but yeah, once again, Anna tricking the audience. I hope these are helpful though. We have found, quite frankly, Anna, I know you feel the same way. We've really found that the knowledge measures really kind of add a wholeness to the learning that we're providing.
Yeah, thanks, Bob. And yeah, I definitely agree. I think, people enjoy these knowledge checks. It helps engage. We wish we could be in a room in person with you all, but this helps us gauge and kind of engage with you all and see where you're at. Just to wrap up quickly, we covered a lot today. We talked about the security capabilities with regards to authentication, network, data protection, and also the tasks that requires for you. We also talked about Azure Defender, how to configure your network, what's the most secure, and other topics like that. And we have so many resources for you. I know someone asked earlier about books for getting started. There are 2 books here that we've been a part of in the past year. So definitely check those out. This learning path is at that first URL, aka.ms/Azure SQL Fundamentals. And I would love if you would tune into our show. Here's a shameless plug for Data Exposed. Actually, Bob, you're coming on the show this week with Buck Woody, and we're doing a special Ask the Expert session. So that's in the same place on Learn TV at 9 a.m. Pacific on Wednesday. So, Bob, that'll be interesting. People can ask whatever questions they want, especially if they didn't get them answered here. That's a great place.
Yeah, but did you say Buck Woody? Okay.
Yeah, he's
I'm going to prep myself for that. And I want to give also a quick plug for your show, Data Exposed. I mean, you talk about getting like the latest news on what's going on with Azure, with SQL. You get it in this show from everybody. You get so many different experts, and it seems like you're doing a show like 2 every week or something crazy like that. But also a plug for Azure SQL for beginners. If you kind of liked what you heard today, how about 60 plus videos of Anna but again, in little bite-sized chunks going through this process. And here's one last thing for you to consider. Anna, people have come to us directly and said the DP300 exam, I think what it's called, which is a certification for Azure for relational databases, they've just taken this training and they passed that exam just by doing that. Wasn't our intention, but we think it's a great benefit to all of you out there.
Yeah, definitely. So more reason to go ahead and complete this module on Microsoft Learn. That's that URL for you, Learn Secure Azure SQL. And, mark your calendars because we're going to keep going. So we're about halfway through. We've got 3 more great modules to cover over the next 3 weeks at the same place, at the same time. We're really looking forward to continuing to dive into what Bob calls the meat and potatoes of SQL Server as we talk about performance, availability, and putting it all together. We've got some interesting exercises, some interesting new demos and new content for you all. Finally, just want to say thank you for spending time with us today. Bob, do you have any closing thoughts?
Well, we know everybody in here has so much stuff they're doing today just in their jobs, but we really appreciate taking the time today to listen to us. We really believe big in this content. If you're a SQL Server person, you want to learn Azure SQL, we think this is the right content for you to learn. And Anna, it's always a pleasure to get together with you. For me, I always learn something from you as well. So thanks, Anna, for having me on today. And thanks everybody for joining us today on Learn Live with Azure SQL.
Thanks. See you next week. So this is our 4th week. Like we mentioned, we have 2 more weeks, and we're basically going through all the modules in the Azure SQL Fundamentals learning path. Bob, just a quick recap. Can you take viewers through, what we've done so far and what's still to come?
Sure. I mean, we built this in such a way that we thought everything built on each other. And so if you start with just what is Azure SQL, get introduced to the topic, how do you compare that to SQL Server? What are those options for you? SQL Server and Azure Virtual Machine, managed instance, and Azure Database. When would you choose these? When does it make sense to pick one versus the other? And then you got to start by deploying the thing or installing the product, right, and configuring it just like SQL Server. So that's why we did that in week 2. And these next 3 modules, we did security last week, or the meat and potatoes. Remember that one, Anna? The Texan term, right, of SQL. They don't go in any certain order, quite frankly, to be honest with you. It's not like security, performance, availability have an importance versus the other. They all kind of go together, but they're really at the heart of the course of what you learn about this. And then, of course, today is about performance. And then, we cap off next week by talking about availability, a really cool part of Azure SQL as well. And then we'll have that great last module where we kind of put everything together about everything we've been learning.
Yeah, it's going to be a great module. And if you want to follow along with us after the session, this is the Learn module that we're covering today. It is part of that learning path that we talked about. And you've probably heard us say in previous episodes that, we've heard from the community, we've heard from multiple people that by going through this learning path and going through this Learn Live series with us, you can go do things like pass DP300, which is the certification exam for administering relational databases in Azure. So this is something to know that all the demos Bob does today are going to highlight exercises that you can actually go complete yourself in Microsoft Learn for free in the built-in sandboxes that they have. So that's definitely something you're going to want to check out after the session. And I also want to remind you that this is live and meant to be interactive. If you haven't joined us before, you'll be excited, hopefully, to learn that we do have lots of knowledge checks throughout this whole thing. So we'll be quizzing you as we go. And we also have some subject matter experts, so other members of our team, standing by to answer any questions that you have. We encourage you to head over to Learn TV to interact with us. That's where all the knowledge checks will be taking place in a more formal way. But that being said, if you're streaming in from somewhere else and you don't have head over to Learn TV, we will also be monitoring the questions that come in there as well. Please ask your questions, make comments, let us know what you think throughout. That helps us keep it a little more engaging since we're not actually all in person today. Now, with that, we're going to get right into the module, which is performance. We're going to do just like we've done for security and like we will do for availability. We're going to start by talking about the capabilities and the tasks. So you want to know what's going on with all these things you're already familiar with in SQL Server when it comes to performance, and how do those capabilities come into play when we talk about Azure SQL Database an Azure SQL managed instance. And once we kind of understand the capabilities, then we're going to move into the task. So how does this apply to you? How can you configure and maintain for performance? How can you troubleshoot performance? What are some of the monitoring capabilities that you have in Azure today? I think Bob actually has a really cool new Divo to show you all, really kind of hot off the press on that one. But when we think about performance overall, Bob, what really stands out?
Well, a lot of people do ask me about this specific topic about performance with Azure SQL compared to SQL Server. And they're a little bit concerned that they don't have the same capabilities with Azure SQL that they get with SQL Server. And I tell them that's just not true. I mean, all the capabilities exist there today that you use with SQL Server. There are some differences, though, you got to be aware of. So, for example, with a SQL Server deployment, you usually go try to do a sizing exercise, right? You go figure out, what are the capacities I need for resources, things like database size, number of cores or CPUs, how much memory. Think about SQL Server as a resource. You need CPU, memory, and fast storage to make it a really great experience for your application, right? So you go the exercise of looking at bare metal servers or virtual machines for that. But it comes to platforms as a service, you don't have access to those resources. So how do you do this, right? And we talked about in previous modules that we've done in this series about service tiers, right? And compute choices and so forth. So I thought it's kind of interesting to go look at the maximum capacities. Now, this is kind of changing. This is an evolution for us, and we're kind of always building and making enhancements here. But today, if you look at your availability possibilities or your performance capabilities for Azure SQL Database, depending on the hardware generation you pick, you can get up to 128 cores and 4 terabytes of memory and 4 terabytes of database size. A lot of people don't realize that's possible. That would be, for example, like your general purpose tier using like the M series, for example. But Hyperscale, we've mentioned that, certainly that option before with Azure Database, go up to 100 terabytes and quite frankly, unlimited storage capabilities using Azure SQL Database. Now for a managed instance, today the capacities look like 80 cores, about 400 gig of memory, and 8 terabytes, although we're looking very quickly to try to expand that size as well. And then we're going to mention this DMV OS job object. I mentioned before a little bit in a previous module about what a job object was, a concept under the covers. We're using Windows Server to restrict the resources that a particular VM gets or a process gets in a VM. And we do that with Azure SQL to make sure we maintain these capacities. So that's the maximum capacity for this. So what about indexing, right? Like, what about indexing? So all indexes are supported. This is a thing that people forget. Your performance skills with SQL Server definitely apply still in the cloud. I'm going to talk about auto indexing at the end of the session today. But all those indexing things you're used to doing, online indexes, resumable indexes, column store indexes, very important concept you still should be paying attention to. Those are all supported for your use today in Azure SQL Database and managed instance. So don't have any fear that you can't do that. I do recommend that if you have like specific jobs you run and so forth to maintain these things, that you ensure that they run well in the cloud. But all that kind of type capability is there. Now in memory OLTP, a specific capability for low latency type transaction needs for an application that exists today in SQL. Now today in SQL Server, that's in Enterprise Edition and to some extent in Standard Edition with a little limitation. You need a business critical tier, whether it's in database or managed instance, to get that capability. But we do some things for you, like we'll auto create the file group for you, and then we fix the amount of memory you need for those capabilities within your overall memory limits and your capacity for your service tier. So that's one aspect of this. What about some other parts of this? Partitions, a very popular concept in SQL Server today to partition out data. That exists for database and managed instance. Now, a lot of times people will take partitions and place them on file groups to put them on specific storage drives. You don't get that capability with Azure Database or managed instance because you don't control disk storage placement of files. In fact, the whole idea is that you don't worry about that anymore, but you still can use partitions as a concept in database and managed instance. And a lot of people still like to do that. In SQL 19, if you remember back, I keep saying Anna last year, but that was really 19.
Right.
We launched SQL Server 19. And we had some pretty cool performance enhancements in that release, but a lot of people don't realize that a lot of that was in Azure SQL first, intelligent query processing being one of those. And towards the end of the session today, we'll cover what is intelligent query processing and go over that. So I think it's kind of important for folks to see this slide to say, you know what, a lot of the stuff I'm used to doing in SQL Server, it exists in Azure SQL. just because I'm on platform as a service doesn't mean I don't get the full capabilities of the SQL Server engine. So it's kind of important to see what's possible to do that. So we talked about configuration in Module 2 overall for Azure SQL, but as you look below here in our breadcrumbs that we have, we're going to talk about configuration and maintenance specifically for performance for Azure SQL. Then we'll talk about monitoring, a very important topic, and you see the various other things that will go down the list during today's module and do some great demonstrations for you as well. So configuring performance. When I thought about building this slide, I thought, what are the things that I should highlight for configuration performance for Azure SQL Database and Managed Instance? This is not everything, but I think it's really some of the things that you should pay attention to because it could highlight some of the differences, even though the capabilities exist the same for SQL and Azure SQL. It all starts with TempDB. Certainly not a controversial topic in the space of SQL family and SQL land is configuring TempDB. But here's some interesting things for you. First of all TempDB files are always kept on local drives. So don't even worry about I/O performance. We're going to put these on local drives, SSD drives for you, so I/O doesn't become any issue for any situations with TempDB. But usually what people are concerned about most is not that. It's about the number of files that you get to partition out our allocation pages to avoid latch contention. And for Azure Database, since it's a fully managed database service, we will pick the number of files for you automatically, and we'll scale that with the number of vCores. It kind of makes sense. The more concurrent workloads you might do, the more files you might need, so we do that automatically for you. Now in Managed Instance today, you just get 12 files, but we are specifically looking to have a similar experience for database, or even allow you to do more configuration with it like you do with SQL Server in the future. Some of the options used for the database, which used to be trace flags, that stuff's just on by default, just like SQL Server. And today, TempD metadata optimization, which was in SQL 19, is not in a managed instance today, but we're looking to actually see if we can support that. Kind of just get rid of any of that latch contention issue you may worry about. Overall, though, I would say the message is TempDB is pretty configurable and auto-configurable in the cloud for you. So that's one aspect. What about just databases alone? Now, this is not just configuration for the database for anything, specifically for performance. And one of the areas people concern themselves is minimal logging for bulk operations. Very important to call out that only full recovery supported. It's configured automatically for your databases, both for a managed instance, both for Azure SQL Database, and you can't change that. Well, why is that? You're going to find out in the next module next week that for availability, we have something called a service level agreement, and we need to use full recovery to ensure we keep you highly available. So keep that in mind, minimal logging not available for you. It is available in TempDB, and you all have the ability also to things like bulk load it with column store indexes to improve that efficiency. Now, the third area that I picked was files and file groups. So with Azure Database, you don't worry about that. But for Managed Instance, you do have the ability to add files and change sizes of files. You just don't physically place the files. Now, you may see that point and go, uh-oh, that's a showstopper for me. I can't use Azure SQL. Well, I'm here to tell you that when we're going to talk a little bit more about scaling performance, we have specific resource and service level objectives for I/O performance, whether it's latency or IOPS or overall I/O throughput, that you get depending on the service tier and the vCores you pick. So I have found that many customers kind of like the fact they don't worry about this anymore. We place these files, but then we have these resource limits and level objectives that we give you depending on the choices you make. Now, having said that, for Managed Instance in a general purpose tier, we're going to be using Azure Storage behind the scenes. So it turns out that the number of files and the size of these files you pick could increase I/O performance. We have a very specific set of documentation to give you guides on this. And the reason why is that depending on those choices you make, we may pick higher level premium storage disk sizes, which have better IOPS or better I/O performance. So keep that in mind when you take a look at Managed Instance. And then just keep in mind, if you want to use file groups, again, you wouldn't use it for file placement, but to just organize your objects, you do get that capability to user-defined file groups for Managed Instance. Now, max degree of parallelism, which we also call max DOP, another non-controversial topic in the SQL family. Some good news here for you. Number one, we do pick some defaults for you, but alter database scope configuration exists for you to make changes to this, both for SQL Database and Managed Instance. Now, if you want to change this at the server level, remember, an Azure Database is not a server instance for you, even though we may use that behind the scenes. So SP configure is only available on Managed Instance today, but you get query hints, Managed instance does support resource governor, so you can change it there. And then we're looking to decide in managed instance, should we change some of the defaults we're using to actually help make it easier for you? Now, for resource governor, that topic alone, a lot of people like to use that capability to do things like limit workload groups and tie it to an app for things like I/O, CPU, et cetera. And that is available to you in a managed instance. Again, that is one of the promises of managed instance, to give you that instance level type capability. And resource governor is one of those features that we do that. Now, I mentioned before in previous modules that we use resource governor behind the scenes to do certain things, but the actual resource governor T-SQL is available to you in a managed instance, again, for pools and workload groups. So that should give you kind of a feeling, Anna, about what are all the different things that I should concern myself with configuring for performance for Azure SQL.
Yeah, it definitely does. So thanks, Bob. And I'm going to throw up this first knowledge check question, but I do have a question for you as we kind of let people kind of look at this question. You showed us a lot of the capabilities and in many ways, like things that are kind of set by default and ways we can change them. Like for the most part, do you think we set things like at random, or do we use some sort of best practices when we go and set these things? And do you have any guidance around when you might actually go and actually change some of these capabilities or default settings?
That's a great question. And it comes down to what we talked a little bit before in our deployment and configuration module. It is your choice of product, service tier, compute choice, hardware, things of that nature, and your vCore choice, remembering the vCore model, that kind of dictates a lot of these defaults that we pick. So I would say, in general, when you make some of those choices and you look and see what are we configuring for you, a lot of these things are just set up for success for you, just to use. But the managed instance one's a great example where we're taking a look at customers that are contacting us, because we use max.0, by the way, in managed instance today, which is just use degree of parallelism at will in SQL Server, right? Whereas in database, we don't do that. But in managed instance, we're doing that. So we're taking a look at it saying, customers are struggling with this. Why don't we just set it to 8 or some number that we think is a good default number so people have less problems? Because we're trying to promote the idea that it's a managed service, right? So it's a great question, Anna. I think these choices you make for service tiers, for vCores, et cetera, are going to dictate a lot of the defaults that we're going to set. But I always want people to know that you do have some capabilities of making some configuration choices in case those defaults aren't appropriate for your app.
Awesome. Thanks, Bob. Yeah, and I think it makes sense to kind of, we're going to try to figure out what's best, but then, the great thing is that you have this flexibility to try to meet your scenario where it needs to be, and we're not so fixed. Okay, so let's take a look at this first knowledge check question. Hopefully people are ready for it. It is a Monday, but the question is, the number of files for TimDB is configurable for Azure SQL Database by which method? So go ahead and head over to LearnTV and put your answer in the poll and let us know what you think the answer to this is. Bob did mention this at the beginning of the last slide, so hoping we're going to be able to start off strong here, Bob.
Yes. Anna, I'm sure, Anna, I'm really proud of you though, because, again, remember, you're the professor that people generally would prefer not to get because you ask these really hard questions. And this one I think is pretty straightforward. So I'm kind of hopeful. I haven't seen the rest of the knowledge checks, but I'm hopeful today that you're not throwing just these really tricky, hard things at people on a Monday, for gosh sakes.
Yeah, exactly. Yeah. That's true. Yeah. We'll try to keep it relatively not tricky and annoying.
Yeah. I don't believe that. It's we'll see.
We'll see what happens. Yeah. Okay, let's go ahead and we got some answers in. Looks like most people are saying C, increasing the number of vCores through the portal. But some people are saying using file properties in SSMS. Can you take us through the answer for this one?
Well, if you remember, Anna, we kind of use this process of elimination idea. And this is Azure SQL Database. And I specifically called about some configuration choices for managed instance. But I mentioned that for Azure Database, we just picked this thing for you, right? So it's configurable though. And I mentioned how, and it was a scaling thing. So alter database statement A cannot be the answer. As it turns out, the file properties in Management Studio just uses alter database. So the B can't be the answer. So C must be the answer. And that is, you just mentioned it. We picked some defaults, but you configure it. And one of the ways you do it with Azure SQL Database is through number of cores that you pick. So it has to be C. We're going to scale files for you as you add more cores.
Awesome. Yep, that is exactly right. So well done. Off to a good start to most of our viewers and you as well, Bob. We're going to go ahead and put up the next knowledge check question. So we've got a few now before we keep going through the performance content.
Okay.
And this next question is kind of similar in what it's asking. It's saying you can configure I/O performance for Azure SQL Database by which method? And while you all take a stab at answering this question, I do want to call out someone commented that this is not live. This is very much live. So,
oh, it's not live? Oh, so I recorded this yesterday or something. I just. Hey,
so we are live.
Look at my shirt I'm wearing. This is live. I'm getting ready for tonight. This is live.
It's funny. But yeah, we are very much live and we do have members of our team standing by to answer your questions. So please put in your questions now because our team is standing by to answer those questions live because this is very much live.
Okay.
Sometimes I have to warn Buck that on shows, you know, that a reminder, this is
live. You
still
have to warn me. I'm not Buck, so I get it. So.
Okay, so we've gotten some answers in, a few answers. Seems like people are between B and C right now.
B and C. Okay, that's what they're saying. Okay. Okay.
I think if you want, Bob, you can go ahead and take a stab at taking us through this one.
Sure. So you can. So the question is, you can configure I/O performance for Azure SQL Database. Okay, that's what you said, Azure SQL Database, and we specifically said several times, placing objects and file groups. First of all, you can't use file. You don't get user-defined file groups in Azure Database, so it can't be C. But remember, you don't get to place files anywhere with Azure SQL Database, so it can't be A. Because we may use Azure storage behind the scene, but you don't know that. As it turns out, we actually do, but for like general purpose. But you don't get to make that choice. That would be something you would do, for example, in Azure Virtual Machine, right? So it can't be A. So it's got to be B, which means remember we talked about this. What is the service tier? What are the different things you pick? And then we have certain objectives for IOPS, IO delays, IO throughput, all those kind of things.
Awesome. Yeah. And it seems like we ended up getting about 75% of people got that one. So we tricked a few people, but I think most people are on board so far.
Well, Anna, one of the things I think that was tricky there, just real quick, is I said specifically for managed instance that the number of files and the size of files could affect IO performance because of the size of Azure Premium Storage we pick on the back end. But we do that for you. You don't place files there. We just do and place files for you. You don't know what storage we're picking, but we do have some documentation that the number of files and size in managed instance could affect this.
Right. But for Azure SQL Database, it does not.
Correct. Yeah, we're doing all that for you. We have objectives that give you the performance you need. That's correct.
Awesome. Great. Now, as we move forward, we talked about some of the capabilities. We talked about configuring for performance. I think the next topic really is, how do I maintain for performance? All these things I used to do.
Yeah, I thought about this topic some as we're building configuration maintenance. Because again, remember what we're trying to do. We're trying to understand and relay to you what are the tasks that you do today for performance, and then how do you translate it to Azure SQL, right? So when you maintain performance, there's a lot of things you do maybe, but it really comes down for SQL databases to these tasks, right? I maintain indexes, I either rebuild or reorganize them, or I maintain statistics. And here's the great news, this all just works like SQL Server. Now, it could be very controversial for you to decide, do I need to do it? Do I need to rebuild indexes anymore? Do I need to reorganize indexes? Should I use auto update stats? Should I update my statistics? And that's a whole entire series that somebody probably could do for us, right? I'm not here to kind of debate that or discuss with you what you should do. I'm just here to tell you that all these options exist for you. Now you're going to see, for example, on the index side, again, at the very end, we'll talk about some things we're doing in the Azure database space to help this automate some of this. But if you need to rebuild, reorg, online, resumable, auto stats, update stats, all that stuff just works for you for Azure database and managed instance. Here's the good news, Anna, is that if you have a bunch of tools behind in your tool belt to do these things, this is just going to work for you. Now, you may need to schedule it a little differently. Azure database, you might use Elastic Jobs because you don't have agent. Managed instance has agent, right? But all the T-SQL you use here is just going to work in the cloud for either one of these options.
Yeah, I think that's kind of a theme that we like to harp on when it makes sense. And that's, it's just SQL. And that's a great example of that. Okay, so we have another knowledge check question. This one is, I think, pretty good softball. It says, how do you maintain indexes with Azure SQL? So Bob just talked to us about this. So take a stab. We're going to put up this poll. And in the meantime, let's see if we have any questions that have come through. Remember to keep your questions coming in. We have someone from India saying, thanks for sharing all the great knowledge. It's really our pleasure. I think Bob would agree with me. We're sad we can't go travel around the world right now, but we're super excited to get to share this information with you all.
Absolutely.
And we have some people sending their answers in.
Okay.
Looks like people are pretty split, actually, between A and B. It looks like maybe A is starting to take the lead.
Okay.
Keep your answers coming in. And remember that theme that we talked about. It's probably a big hint, but the it's just SQL theme.
Okay.
Okay, Bob, we got some votes. It looks like 83% of people have said A so far. So I think you can go ahead and take a stab at taking us through this one.
Yeah, let's eliminate it, right? So look at C. I just said everything's supported, right? So the word not supported shows up. And you didn't say Azure SQL Database or managed instance here, which was very open-ended of you, but that was clever because I also said both for these are possible. So C can't be it because we just said you can do offline, online, all that works, right? Same thing kind of for B. It just works. You can rebuild indexes anywhere you need it. So B can't be the answer. Therefore, A has to be the answer. But I did emphasize that. And why did we do this knowledge check? We want to just keep emphasizing to you, you get to do the things you want to do with indexes with Azure SQL, just like SQL Server. So don't fret. Again, you should study and look at whether you do need to rebuild indexes. That may be something you need to revisit. But if you need to do that, all those capabilities exist there.
Definitely. Okay, so we've talked about the capabilities. We talked about configuring for performance. We talked about maintaining for performance. And I think the next really big topic, because these are all really big topics like you mentioned, is really around okay, how do I monitor what's going on with performance?
And there's probably no more bigger topic in this space than this right here. And that's monitoring performance specifically. And again, I've seen people come to me and say, I'm very concerned. I have a specific set of processes and tools I use in my data center. It's not going to work in the cloud. I'm really worried. Or my skills are gone because I used to have all this expertise to monitor performance. I'm here to tell you that none of that's true. Now, for Azure SQL Database and Managed Instance, it's platform as a service, right? So it's not like you're running perfmon and just looking at the thing, right? But we have some capabilities you're really going to like. So first of all, Azure Monitor is an ecosystem. It's part of that Azure ecosystem we talked about early on to monitor metrics, get alerts, do logging for important telemetry for performance for Azure SQL. And look at this new bullet point, Anna. Here I am today to add something new. SQL Insights. Our friend Elaine Dormal is just going to love this. Hope Lane's online listening. We have announced a public preview just recently for something called SQL Insights. You're going to see a demonstration of that today. And the idea is that let us go help you here. Let us go build a monitoring machine in the Azure Monitor ecosystem to help you monitor your Azure SQL assets. Let's light up for you all this rich telemetry that you're used to seeing inside SQL, and let's do that outside of SQL. So I think you're going to love what you're going to see there. I'm going to show you a demonstration of what's possible for you. It's got a really cool story because not only is there visualizations here, but the extensibility is amazing. And we're going to use open source software called Telegraph in a virtual machine to monitor Azure SQL, all of your Azure SQL assets. And then you can actually see these in log analytics and workbooks. You can get it. You yourself can go see the Telegraph queries we're actually using. So it's a very extensible framework. It's open source, and it's really, really cool because people that use and love things like perfmon are going to see this and go, oh, finally, that's what I've been looking for. So we'll show that off today in a demonstration. Awesome. But remember, Anna, that's outside your SQL deployment. You then connect inside SQL, and you're wondering to yourself, do I get dynamic management views? Do I get extended events? Well, we're here today to tell you yes, and you get more. You get the same SQL capabilities you get in SQL Server, plus some additional things that make sense specifically for the cloud. Now, lightweight query profiling, a very feature of SQL Server that's in Azure SQL, a lot of people don't really know about, on by default. Imagine, Anna, you walking up to a SQL server. That sounds like a joke. You walk into a SQL server. You walk up to a SQL server and you say, for this long-running query that's chewing up all my CPU, I would love to see an insight of what it's doing while it's running instead of having to see it after it ran. Well, lightweight query profiling gives you those capabilities. You can go look up in the docs about how to go get insights to that. It's really powerful. And then a lot of people are query plan debugging geeks, Anna. They love looking at things called show plan. You ever seen a show plan with all these complicated operators? People make a living at looking at show plan. All that stuff works. All your query plan debugging statements, all going to work for you in Management Studio, extensions for Azure Data Studio, NT SQL, all that stuff works with Azure SQL. Now, Query Store being a very important functionality, we released in SQL 16 and in the cloud, it's on by default. And in fact, it lights up some very important capabilities that we have, like new performance visualizations in the portal and something that we're going to show you later for auto indexing. So Query Store being huge, giving you deep insights, but just look at this list right here. I mean, this is the stuff people use in SQL Server today, Anna, and it just works, whether it's outside of SQL or inside SQL.
Yeah, it definitely just works. And improving your performance has real benefits. You could maybe even scale down. And I think we're going to talk about that and save your company money just by helping with these things that many folks have been working on for years. Bob, I always joke that you're hyper-focused, and I say things like, okay, now time for some hyper-focusedness. And I think our viewers would love to hear a little bit more about the specific things that they might want to consider when it comes to performance and DMVs or extended events. Can you geek out with us?
Yeah, I mean, I remember, Anna, you using that term like on social media, hashtag hyper-focusedness or something like that. And I remember showing that to my wife, Ginger. And I said, is that a compliment? She goes, for you, Bob, it's, Bob, she just patted me and go, just take it. And just roll with it, man. It's a compliment, right? It's a thing. Right? Hey, listen, I spent my career at Microsoft with this functionality right here, DMVs, Dynamic Management Views. And so for Azure SQL Managed Instance, here's the news for you. They just work. Everything you have today for all SQL Server DMVs works as is today. So just take your scripts, put them in Managed Instance, and just run them. And, Anna, there's a new DMV for Managed Instance. This is pretty cool. So inside SQL, you can take a look at the overall resource usage for the managed instance itself, CPU, memory, IO, everything. That's pretty important because you may take a look at that and compare that to the service level objectives, the resource limits for your IO, CPU, and everything you want to do. So that's Azure SQL Managed Instance. All the stuff you know and love, all going to work there. DM exec request, OS wait stats, all work. Now, Azure SQL Database, a little different in this way. Remember, we don't expose the entire instance for you. That's the whole idea. But we do expose most of the common DMVs that you need. So you want to look at blocking problems, you have the DMVs to go do that. You want to look at procedure stats, query stats, you can go do all that stuff. You can even do OS wait stats. So it's going to feel like a database to you, as it should, but most of the ones you need to do common things are all available to you. And just like with that managed instance, we're going to give you new DMVs. They're going to give you resource usage for your single database, or even for like an elastic pool of a series of databases. So you just see this right here, and you can tell that I'm going to be able to use the things I know and love today in Azure SQL. Now, there's some things you should be aware of that are interesting. For example, when you look at IO latencies, you may be used to looking at some things at the operating system level. Well, remember, it's platform as a service. So IO virtual file stats, which we've exposed in SQL Server for years to give you IO latencies specifically for the files for SQL, that's there for you. So you have that capability of looking at those things at a database or managed instance for the files that matter to you. And SQL Server performance counters, specific one just for SQL, a lot of people I've talked to don't realize we have a DMV for that you could use, and that's lit up in both Azure SQL Managed Instance and Database. So batch requests per second, anything you're used to seeing, you can see there. But the other cool thing is, though, you're going to see that show up in things like SQL Insights. Now, I love these last two DMVs over here, Hannah, Instance Resource Governance and UserDB Resource Governance, because I've talked about service level objective being these, CPUs and IO and rate, log rates and all these kind of type things, IO latencies. But I would like to kind of see that at a configuration level, like through T-SQL, right? Rather than just looking at a table and a documentation page, could I run a query to see what is my max DOP that I'm possibly set up my system? Well, those DMVs get to show you that. And then, yeah, you're going to want to geek out. So you want to see some really internal DMVs, stuff that we use to look at the deployments going on to solve problems. We use these. And like resource governance, resource pools history EX, wow, what a mouthful. That's a good example of something where I'm going to show you an example where you can use that and monitor what we're looking at there, because it's kind of a polling DMV to look at really interesting things like log resource usage when you're looking at your log rates. So we have the DMVs you need. We have new DMVs for certain scenarios for the cloud. This is a great story because this is one of the tried and true tools of SQL Server performance, and I think people have what they need here. Now, extended events, our new tracing capability that we've had in SQL Server since 2008, and we pivoted from SQL Trace and Profiler over to this with SQL Server over several last releases, and in Azure SQL as well. So you're asking yourself, well, do I get tracing with Azure SQL? Azure SQL Database, most of the common events and actions that you need, I've looked at all of them. The ones you need for monitoring Azure Database and tracing it, they exist. Now, targets is where you place your extended event data. It's where you are going to go send your data. Ring buffer and counter exist, but what about file targets, which is usually what you want to do? Remember, you don't have access to the file system directly. So what do you use? Use Azure Blob Storage. Azure Blob Storage becomes your disk drive, per se. When you need things like auditing, we talked about that last week in security, or extended events. So you're going to store your Azure SQL Database extended event sessions in the Azure Blob Storage file target. Managed instance, it's a complete SQL Server. So you get all the events, targets, and actions that you have in SQL Server just comes with managed instance. Everything you need exists there. But just like Azure Database, file targets, you don't have access to that file system, right? So your file targets are going to go to Azure Blob Storage. So again, if you think about Azure Database and then you go look specifically at managed instance, you have the things you need to do extended event tracing. And we're going to actually use that ourselves in other things like SQL Insights and other type of tools. But if you want to use these trace capabilities, they exist. Azure Managed Instance even has a few new events that are specific to Azure that you wouldn't see in a SQL Server. So I love the story here, Anna, because I have both DMVs I need and extended events I need. Looks just like SQL Server. Maybe in some cases, like in database, you may not have everything, but I have found, like in the Azure Database case, all the things I normally use exist there. So it's a good story.
Yeah, definitely. And I think people are going to be really excited. I mean, I think we're always well received when we talk about DMVs and extended events and how, for the most part, it's just SQL, except in some of these occasions where we even added more events or views for people to look at. Now, I want to go through like a typical kind of scenario. So, let's imagine, you get a call at 2 a.m. Maybe this happened to you when you were working in support, and there's some performance issues with someone's SQL database, and you're on the hook. What happens now that we're in Azure SQL Database or Azure SQL Managed Instance? Can you walk me through kind of like the decisions that get made and what I should go look at and how I should deal with this?
Sure, Anna. But remember, I got paged at 2 a.m.
Oh, paged.
Paged at 2 a.m. I didn't get called. I got paged. Do you know what that is? Pager? No, you've never seen it. You've seen it. You've seen it at the Smithsonian. You told me. You went there and you actually saw it there. No, I give complete credit to this concept, Anna, to Keith Elmore, my longtime colleague, and he's still in support at Microsoft. Known Keith for so long. We've been almost at Microsoft the same time together. And Keith's just a guru on performance. And I remember having this conversation so many years ago when we talked about this concept. And it was at lunch with Keith. And I said, Keith, I just love errors. And he had this weird look at me like, you love errors? Like, what's your function? What's your problem? And I said, I love error messages because I can go to the source code and find exactly what caused an error message. What are those conditions? And debug a customer's problem and find out exactly the cause almost every time. But in performance, no one ever calls and says, oh, by the way, I have a specific query plan operator that's not performing correctly. They just say it's slow. I don't even know what to do. It's a very vague description. So Keith constructed a very genius way, which we still document and use today. Is it running or waiting? And it all starts, Anna, with checking your resource consumption of SQL. So today you do that with like Perfmon or maybe a Linux tool or so forth. But how do you do that with Azure? with Azure SQL? Well, we have these DMVs we just mentioned that you can take a look at. Or you can look at the Azure portal, things like SQL Insights we're going to show you. You can look outside of SQL or inside of SQL to find out what is going on with my SQL deployment. Am I using a lot of CPU or not a lot of CPU? If you're using a lot of CPU, we call that a running scenario. Typically caused by what? It's caused by queries that are executing and using a lot of CPU. Could be a bad, inefficient query plan. Could be, though, that maybe you have a lot of queries that need a lot of CPU. You don't have enough CPU resources for your workload. And you might see something called an SOS schedule yield wait when that happens. You could use the query store. Look at the DMVs. There we go. Here are some DMV names you're familiar with that you might use to go look at a problem like this. So that's the running scenario. And typically what happens is you go down and find out what queries are causing this. If it's not enough CPU resources, you get more CPU resources. I got a really cool story to show you on that one for Azure, though. It could be that your query plans are inefficient, so you might debug and make changes there. Now, what if it's not running? What is it? Well, guess what? It's waiting. And it's waiting on several different types of resources. And it could just be a blocking problem. Or it could be something called a latch wait. Maybe it's waiting on I/O resources, which you've seen before in SQL Server. You could see still in Azure SQL, which means maybe you need a new deployment option or bump up vCores to get more I/O capacity for your workload, or it could be query tuning opportunities. What do you use to take a look at it? Well, you use these common DMVs that you're used to using in SQL Server, or you're going to use the query store to look at this and find out who's waiting on what are the top wait types I have, how long are they waiting on, go find what those look like and try to resolve the problem for there. So Anna, this is how, quite frankly, I have found success over the years of breaking down almost every SQL Server performance problem. And we have a lot of experience doing it. And we've been very successful doing that here with SQL Server. And you can see now with Azure SQL, it's a very similar process.
Yeah, and I think this is really, really helpful. And it's also probably pretty useful to kind of see what different DMVs you might use or what tools you might use to actually diagnose this. I think it would be really cool, Bob, if you could show us an example of you kind of monitoring performance in action.
Absolutely. Let me share my screen here and let's do that. So through the magic of screen sharing, here we go. Screen share and okay. So Anna, here is a computer. It turns out this is a client of mine, a client with a virtual machine. And I'm going to do this. I'm going to kick off a workload using the popular tool called OStress, another Keith Elmore special, by the way. And we've used this for so many demos that we're doing. So I'm going to run this workload and I'm going to go with SSMS. And I'm going to use the DMVs you're used to seeing to monitor its performance. Now, you're going to notice very quickly something interesting about this pattern here. Number one, notice how many of these requests are in a state called runnable and how many are waiting on that SOS schedule yield wait. This is a pattern that's happening over and over as I'm running this particular workload. Now, I mentioned a new DMV, DMDB resource stats. Let me run that one. We will pull automatically for you resource usage behind the scenes. Can you see a problem here? My CPU percentage is going up pretty high very quickly. In fact, I'm going to run this again because what we do is we automatically just pull this for you every 15 seconds. You see the results of it. Now you can see a pattern emerging here, right, Anna? You can see I'm using CPU a lot every one of these intervals right now, right? So I can maybe tell based on my experience and that scenario I just said, high CPU, SOS schedule yield, it's probably what I call a running problem, okay? Now I'm going to go back and look and see in this particular case, this query is still running now. And I run this again, I still see the same pattern, but it looks like it's kind of going down a little bit, which probably means that the query is almost done. It's down to like 66%. What I'm doing is I'm just running a bunch of concurrent queries that need CPU resources. The plans themselves are fine, but maybe I don't have enough CPUs for this just by looking at this information itself. So let me go back over here. I'm going to see, Anna, that this query finished and just kind of bookmark and keep that in your head here, a minute 16. So I'm going to show you an additional tool. It's available in SQL Server. You've seen it before, called Query Store. I'm going to look at a report called Top Resource Consuming Queries. And if I click here, this is the query I'm running. Now, if I hover on the query plan here, I can quickly tell something here. I can see that the average duration in milliseconds is only 3 milliseconds, 3.4. And you're like, well, that's not that bad. But look how many times I'm running this thing. I'm running this thing a bunch, almost 200,000 times. Great example of me running a query that uses a lot of CPU for a short period of time, but I run it all the time. So it looks like I'm consuming CPU the entire duration. Now I can also look at query wait statistics. Now you're going to find this interesting. Sometimes you can be running but waiting, and you're like, that doesn't make sense. Well, I'm waiting on CPU resources. That's what SOS schedule yield kind of looks like. In fact, the average wait time for each query is that. That's almost the entire duration of the query. Well, that's kind of crazy. So it is a running scenario, but the reason we're waiting on this resource is because we only have so many schedulers to schedule your work, because we only have a couple of CPUs. How do I know we only have a couple of CPUs? Funny you ask. Let me go in and look at this query. This is using that do DMV to see what is my CPU limit for this database. And sure enough, here's the answer. This is that service level objective. It's an Azure SQL database, general purpose, Gen 5 hardware, but only 2 CPUs to run this. And you can see it's another way with database property EX down here as well. So this is me, besides just looking at the portal, looking at the documentation, I can tell how many CPUs I get from just looking at this. Now I'm gonna later on in a demo do kind of a scaling thing. So what I wanna do is I'm gonna flush my query store database so I can kind of compare and contrast. But Anna, before I do that, I'm gonna flip over and show you something else. That's inside this VM. So let's go look at the Azure portal and look at this. Okay, so this is in the Azure portal, this database, and I can tell right now, I can see I have this 100% utilization going on. That's interesting, of course, but how about something new? Let's go look at this view. This is SQL Insights. Okay, this is my new SQL Insight I'm looking at here. Let me refresh this real quick, and I'm gonna see a similar chart, see, I'm seeing a similar percentage of my usage in SQL Insights, but look what else is here. CPU, memory, IO, processes blocked, data IO, wait stats, a rich set of telemetry. Remember, this is outside of SQL. I'm looking at this in Azure Monitor with SQL Insights. That is pretty amazing. Now, Anna, there's more. There's more to this story. That's just my database. Let me see here. Let me click here. Let me get to this one. No, let me flip over. I'm going to get to this screen right here. This is my SQL Insights set up for 2 databases in Azure. That's actually pretty impressive. And then when I bring up these databases in 2 different servers, and notice here, look at all the stuff I can start playing with here. I can get all sorts of things. I get transactions per second, batch requests. Oh, this is looking pretty cool, isn't it? Is this impressive?
Yeah, this is
block
pretty cool.
Processes, deadlocks, and then I look at space usage. I get transaction usage. Here's what I really love. You really want to geek out? Go to Explore Metrics. This is going to feel like Perfmon to you. So look at all this stuff. You're going to scroll down and see. You can start doing whatever you want. And then because this is part of Log Analytics, you can create custom workbooks to make any view you want. This is our default GUI view for you, but we have all this rich telemetry that you can customize and make and then pin it to like your portal. Now it doesn't stop there. Those are Azure databases. Anna, here's my managed instances that I'm monitoring as well with databases inside it. And then it goes further. How about SQL Server and Azure VM? I can do that too. And then if I want, and I haven't set this up yet, I can do the read replicas of my availability groups as well, all in a single profile, all from a virtual machine that's monitored using Telegraph. How about that?
That's pretty cool.
Yeah, great stuff. We just announced that in public preview. Check it out. It's really powerful stuff. I'm really excited. Every time I show this stuff, I kind of get excited because I just see so much rich telemetry that I can organize any way I want to do that.
Yeah, definitely. I mean, I think it's really interesting, and I've played with it a little bit, and it just seems like there's so many different things that you can go look at, and you can even go build your own custom workbooks if you want. So I think, people are really going to continue to like this. We've seen some examples. We also got a question in from Michael, so I thought maybe we take a second and take a look at it. The first question, actually, now we have a few questions, but the first question from Michael says, are there available queries that will tell you how much CPU IO network your queries are using and how much you are paying?
So you don't do query, you don't look at pay or your billing at the query level. You look at your billing at the compute and storage level, right? But you can correlate this a little bit, right? Because you can go look at what queries are using most CPU to find out, okay, this is how much CPU I'm paying for. Well, what queries are consuming the most CPU during that range of what I'm paying for? So you can do that for sure. And we just showed you the rich capabilities of SQL Insights. I get all sorts of deep information there about everything about my deployments. And then, Anna, we're going to show you later in the session about how through a vision. I showed you how to look at queries with Query Store, like in Management Studio. How'd you like to see it in the portal? So I'm going to show you later in the session how you're going to get that query insight look at that level in the portal, which again can show you historically which queries are using the most CPU. And then you can go look at your subscription and say, okay, during that time range, how much did I pay for that? So you have that option. And don't forget, Anna, you've mentioned this before. We talked about this earlier, that serverless, gives you the option to only pay for the compute you actually use. So that's a really cool option that where you're not using your server and you're not using any compute, you can actually have your database pause and not pay for any compute. So.
Yeah, definitely. Thanks, Bob. I think hopefully that helped Michael answer your question. The second question I'll take, it's from Rashad. Rashad said, this video is part of a series which covers the first learning path of the Azure Database Administrator Certification, DP300. Is this enough for sitting in the exam, or do I need to go over the remaining 6 learning paths? So from our experience, Rashad, and this isn't really any official guidance, but from our experience working with people, they have said that by going through just that first learning path that's recommended, the Azure SQL Fundamentals, which has 6 modules, and sitting in one of these series with us, they've been able to pass DP300 without the other learning paths. But that being said, the other learning paths have some really interesting and useful information. So, I might still, depending on your expertise, you might still consider going through them. So hopefully that helps, Rashad. Okay, so we've talked about a lot today already, Bob, and we still have quite a lot to cover. The next, we're going to talk about some performance scenarios.
Yeah, I mean, again, we talked about is it running or waiting, and that's absolutely true. I mean, that is going to apply here, but there are some things that we discovered. Remember, Anna, if you think back to the history of this, we were assessing SQL Server and comparing that to Azure SQL. And then we said to ourselves, okay, are there any running or waiting scenarios that you just see in the cloud that are really specific to the cloud? And so this is kind of important to call. And the very first one is the most important one, and that is log governance. In order to meet service level agreements and our service objectives, you just can't use unlimited transaction logs to just whenever you want to do it. We have to govern this some. And so when that happens for, say, an Azure SQL database, say general purpose tier, you're going to see a new wait type called log rate governor that may show up. This may impede your performance, some of your applications, but for a very good reason. Or you might see it show up in other managed with these other different wait types. And so we'll do a demo in a second to kind of show you. I want to call out here a little bit, though, that your log rate that you get is based on the deployment choice you picked. So, for example, business critical is business critical. So we're going to give you more log rates there than we would say in general purpose, or Hyperscale has really high log rates, right? So log rate that you need may depend on your deployment choice, but also remember that you could have bursts of this, right? You may have like a huge bulk operation that needs more logging, whereas your normal usage may need a lower log rating. So you need to kind of monitor and see what the needs are of your application. But again, so bulks could be using a lot. You may end up potentially, changing the scale of this as you need, depending on what type of workload you run. So log governance being one of those very first ones. You don't see that in SQL Server. You only see that in Azure SQL. Now, worker limits are interesting. The reason I called the worker limit is that for managed instance, today worker threads look just like SQL Server. So a lot of people may run out of workers and see thread pool weights. Don't forget that when that scenario happens, it may just be a poor application blocking problem, not because you don't have enough worker threads. Don't feel like you got to go bump up worker threads just because you see that. But the symptoms look like that, thread pool weights. Azure SQL Database is different today, at least. We have concurrent worker limits, again, based on that service level objective that you can look up. And when that happens, you get an error. So this is a new app thing you kind of take a look at. You may have run out of the concurrent workers that you need for your application. And so an error may come back to your app, which requires you to do a retry. But it could be you need to go look at, maybe you need to bump that limit up, or again, it could be an app issue that you need to resolve. But keep that symptom in mind. And then you have business critical HADR weights. Anna, you had a question about this one before?
Yeah, I did. When we first started working on this, I was doing some performance testing with business critical, and I started getting these HADR weights. And I came to you and I said, Bob, why am I getting these?
Yeah, and I didn't understand I remember we went back and forth. I'm like, Anna, yeah, that's by design. And you're like, no, wait. I just deployed an Azure SQL Database business critical. I mean, this doesn't say business critical or what's going on here, right? So remember what we talked about, and we're going to talk about it next week. And I think we got a whole architecture series on business critical, but we're deploying an availability group behind the scenes for SQL Server, an actual SQL Server availability group. So if Anna, today you deployed a SQL Server availability group with like a sync replica, a header sync commit wait is normal. That's like a write log wait. Like that is the time it takes to synchronize and harden the log on the secondary. It may be a low wait time, but it's normal to see that. So I remember coming back going, okay, I get it now. You didn't deploy an availability group, because I remember telling you, Anna, this happens when you do AGs. You're like, I didn't do an AG, but you did. You did by doing a business critical service tier. So we don't want people to be surprised when this shows up in their normal weight analysis that we're using an AG behind the scenes. And these other weight types are similar, but they apply to a similar concept where, to meet service level agreement, you may see these weight types showing up and how we throttle synchronization to replica. So that's why that showed up. I remember that sequence, went back and forth several times, and finally we just got on the phone to get into it, right? So, Hyperscale, we talked about some. We'll talk about it next week. The one thing about Hyperscale that's really cool is it's a new tiered architecture that gives you great scalable performance, but we introduced some new concepts where we've extended the SQL Server engine. And so things may show up a little differently, but we want to make sure you give you the telemetry you need. So we might, and in this case, we might throttle log rates, not just based on log usage at the engine level, but based on what's going on in the tiered architecture level. We got to make sure our page servers and things are keeping up on track. And if that's not happening, we may throttle the log a little differently. So you might see a weight called an RBIO weight show up. And we document exactly those scenarios. And then because of this tiered architecture, some of our IO goes to something called a page server. And so we're gonna expose some of those IO data to you in DMVs, views, and events for page servers, so you can kind of see what that flow looks like. Whereas normally you wouldn't see that, say, in a SQL server or a general purpose or say business critical. So those are some of the specific scenarios you might see in Azure. So log governance is interesting, and I want to call out to you that we don't have this today in our Azure SQL Fundamentals lab. It's something we added because we said a lot of people had questions about exactly how this works. So if you don't mind, let me flip over and show you a couple things about log governance that you might find interesting here.
That'd be great.
Let's do the screen sharing again and just double check with me, Anna, keep me saying here that you can see this.
Yep.
So I've got another SQL logical server here. I've got a couple of databases. I've got a general purpose database here that's 8 cores and a business critical that's 8 cores. And so let me flip over and show you a couple of queries here. So first of all, if you look at the general purpose one, I'm going to look at this here. I'm showing you some of the queries that you can use to look at log governance. So first of all, this first one is looking at that same DB resource governance query. And notice here, I'm looking at what's called the log rate. So the log rate can tell me, for this general purpose, I get about 36 meg per second, right? And wait stats are still applicable. So let me just do this. Let me clear this. And what I'm going to go do is I'm going to run a workload. Now, and I can't help myself, though. I love my sports teams. So there you go. I'm sorry, but there's the table we're going to use. We're going to run a select into, and I picked this specifically because it's a parallelized operation. It's parallel operation here, kind of doing a bulk type insert. And so I'm going to go look at log governance, and I'm going to go look at these weight stats here, and I'm joining more DMVs that you might not normally see. Now, why am I doing that? Because since it's a parallel operation, exec request won't show me everything. So you can see here just by looking at this number. It's a parallel task that's running, but in some cases, the parallel workers are getting throttled on log rates. Now, I may want to see, am I hitting my limit just by running a workload. And I can see that through DMDB resource stats with a different column that I showed before. And maybe you can see now, Anna, that we're almost hitting 100% of the limit that we were given based on the service level objective that we used. Now, I was going through producing this, I asked myself, well, how much I'm using? Like, how can I tell before I hit my limits? This is where I'm picking that geeky one, you know, that one we showed before called workload groups history EX. I'm going to run that query here, and I'm looking at this, and I can see now my log rates look like I'm approaching that limit that we're throttling on. So I can look at the overall wait stats when this is done, and this is finished now, by the way, and I can see that log rate governor. I've had several waits on that at a certain average wait time, you know, per query. So if you go over and look at, say, business critical, what does that look like? And it's the same number of cores. So I'll go look at the business critical one, and I see this limit here. And I'm not going to run through the whole demo here for you, because what you're going to see here, I have 96 meg now. That's almost 3 times as much, right? So if I run that same workload now, I'm going to find out that I have just a few log waits going on for log rate governor. I can run the same set of queries here and observe that I almost don't wait at all. And in fact, if I go look at the select into, this thing took like, if I go scroll down here, this took like 47 seconds. If I run the same exact thing on the same database in business critical, it takes like 10 seconds. So it just shows you that for performance throughput for log rates, for like a bulk parallel operation like that, I'm pushing the limits of my log, and I may need to go to a different service tier. But keep in mind, maybe I don't do that all the time. So it's not like this log rate thing is something you always may run into, but if you see it, I want you to be able to recognize it, how to go diagnose it with the tools through DMVs, and then decide like, how do I deal with it?
Thanks,
so that's
Bob.
log rate governance.
That's a great demo. I really like that demo, and maybe we should look at maybe getting it added into the series so people can get hands-on with it as well.
Absolutely. We should, yeah, those scripts are, you know, I should just share those scripts out. You're absolutely right. We can put that on our GitHub repro and make those available to everybody. I agree.
You didn't know I was going to assign tasks to you during this live series.
You know, this is very much like you. Usually after one of these assignments, it's like, Bob, can you go off and do this or do that and do this? So, by the way, that's a complete lie. Anna does so much work behind the scenes for this. I know I sound like I'm whining here. So, you know, where's the cheese with that whine, right?
Oh, I'm just giving you a hard time. But it seems like, you know, people are really, really receiving all of this really well. We're getting a lot of comments throughout all our different streaming platforms, especially on Twitch. People really took liking to your, someone walks up to a SQL server, and we've got quite a few jokes that people have come up with.
People come up with some interesting jokes to that one, right?
Yeah, exactly. So again, we've been talking about a few things. We talked about monitoring and scaling. I'd love to talk a little bit about accelerating and tuning and some of the things you've learned from working with SQL Server and Azure SQL.
Sure, thanks, Anna. You know, again, you know, we told you about problems. What about solutions, right? So when it comes to scaling, notice the problem we just presented to you. We presented you a problem that we think that we may need more CPU capacity. Now, Anna, here's your problem. You manage a SQL server on a virtual machine that's hosted with a bunch of other virtual machines in a hosting environment or in your data center. And you run into this problem. And you're like, I need more CPUs. Oh, no problem. This is a virtual machine. I'll just get more vCores. You may not have permissions to get more vCores. Or your administrator says, we're out of capacity on this server. So can you just migrate your VM and your database to another server? And by the way, that might be a month from now. And you're like, no, my business is down. Like, this is a problem, right? Hey, here's the cool thing about Azure SQL. You can scale CPU capacity dynamically, very easily with general purpose or business critical or even hyperscale using the portal, using T-SQL. I'm going to show you that, PowerShell or REST. And the downtime can actually be very fast with no migration required. You don't do the migration part. In fact, what we try to do when we scale this is we wait to the last possible second to shift you over to this new deployment so that your downtime is very minimal. And then auto scale, what about serverless? So you want it dynamically scaled, like what I just showed, you know, for this 2 CPU problem, you wouldn't even have to scale it because you could pick a range of CPUs with serverless and we just do this automatically for you. And then hyperscale, it's just like general purpose. We should call it the fact that hyperscale is like general purpose here, where the data files are remote storage. The scale can be very in constant time, unlike business critical. One of the issues of business critical and scaling is that the databases are kept on local storage. So trying to find another set of local storage and then get replicas synced up and everything going for you could take a little longer if it's a very large database. But for hyperscale general purpose, the scaling of CPUs can be in constant time, whether it's 2 or 80, which is pretty cool. So that's CPU capacity. What about I/O performance? Like, how do I get that faster? First of all, you should know what IOPS are. Like, if you don't know that concept in your data center and your SQL server, go figure out how to measure IOPS. Look at I/O, things like disk transfers per second, things of that nature. And sometimes when you have restriction on IOPS, they show up in form of longer I/O waits in SQL Server, page I/O latch waits or write log waits. So understand what that looks like. Look at our service tiers, look at our slows. It shows you the IOPS you get for your deployment. And then if you need higher IOPS, it's usually a scaling operation. You go to more vCores, or some cases you need to move to a different service tier to get a higher IOP rate. Now remember, in any things I'm talking about in these scenarios, CPU or I/O, there could be query tuning opportunities, right? This is assuming you've gone through that process. So I/O latency can be critical for very high-speed transaction processing, right? So if you don't have a good enough latency story with your deployment for, say, Azure Database general purpose, maybe you need to go to business critical or hyperscale, where we're going to get lower latencies there for you. Or same thing in managed instance. And don't forget, though, we mentioned earlier that changing files and file sizes can give you faster I/O performance in general purpose for managed instance. And then finally, don't forget about multi-statement transactions. I've seen people literally take a singleton I/O, singleton loop with insert statements on their laptop and go run that in Azure Database Business Critical and go, see, Bob, it's not as fast as Azure. And then I'm like, hey, man, I get it. But I mean, do you have like an auto DR system set up on your laptop with service level agreements and everything behind the scenes? Or you probably don't. So it's not a fair comparison, right? So if that's the case, though, when would you ever run that in your actual workload? You usually use multi-statement transactions. So I have something, Anna, that's not even in the, I don't think it's even in the fundamentals, but in our GitHub repo, where you go through the process of looking at application latency for logs with your transactions. So we talked a little bit about workers, but what about memory? I didn't really even mention about how to get more memory, right? Well, I did kind of say that, and that is the fact that you don't just go use max server memory or something like that. You actually use vCores typically to scale up. It's a similar story with like 10 TB files. The more cores you get, the more memory will give you for your application needs. So scaling up gives you higher memory limits, and we document what that all looks like. And then don't forget about application latency. And I only say that because of our experience we've seen. Anna, you've seen this before. You've mentioned before this concept of redirection versus proxy. I was blown away by the speed difference between those two, but it kind of makes sense based on that concept. The fact that you don't have to go to that gateway every single time you're running a query. And then this is one thing we've seen, especially when people are in their own data center. Sometimes they get away with performance with chatty applications. Seen people not even use stored procedures before, move to the cloud, say their app is still on premises, and all of a sudden now they're across the internet and running into performance problems. So look at those chatty application issues. And here's one of the most important parts of this slide, Anna. Tune your queries just like you would SQL Server. Indexing, batching, procs, parameterization, even processing results in a timely fashion. These concepts that are tried and true, which is part of the skill set you have today, they still apply in Azure SQL.
Awesome. Yeah, this has been really useful, and I'd love, again, to toss it back to you to take a look at how that previous problem we were seeing, where it took, I think, 1 minute and 36 seconds, how we might be able to address it and scale performance.
Yeah, it's kind of like not finishing a novel, right? Like, we got to finish the story here. So let's go back to the VM we were running. This is the one we were running when we were doing our log governance. Let's go back, though, to the workload we were using. Remember this one. Here's that minute, 16 seconds. And I told you that we were running a 2 vCore. Let's get that back up. This is the database. Now, I don't want to confuse everybody. This was my server for my log governance. This is my server for the scaling scenario. We're using this database, AdventureWorks Azure LT, a non-sports reference, Anna. There you go, a non-sports reference for you. So I'll run this again. Remember, this is 2 CPU. So what I think I need to do is go to 8. That'd be kind of cool. So can I do that to T-SQL? I can. So I'm going to go here to modify service objective. Look at that. Altered database has been modified in the cloud to scale up. So let me just run this thing. Whoop, I scaled up. No, that's not true. So
not that
what's
fast.
happening here, this is like a deployment operation in Azure. So if I kind of go over here, maybe look at the portal real quick, you'll see here, it says updating pricing tier. And I know, Anna, sometimes it can get a little confusing for people. The pricing tier is where you go make changes like the service tier. and your vCores and everything. And instead of using the portal, I just use Azure Database. And this is just showing that behind the scenes, I'm changing it. Now, the database is still available to me, even though this is going on. This is a very quick operation that happens. And once this occurs, I can go back over here. Let's kind of go back over to our VM. And then what I can do is go back to this get service objective query and see, do I have 8 CPUs now? Oh, look at that. I do. In fact, you can see here now, I'm at that 8 CPU limit. So what would be kind of interesting to see is that, do I have to change any code to get faster? No, I just went to 8 CPUs with a declarative change. I ran this workload, and now let's go back and look at the DMVs that we were kind of monitoring before. So what about exec request? What does that look like? And this is the behavior of a better scaled operation. Notice here, more running statuses. Then we have a few runnable, so we even have more scaling opportunity, but more running statuses and less SOS schedule yield weights are occurring with this workload. And then we're showing you the DMDB resource stats, which was the Azure specific stuff. Let's run that. And you see here that I am still using some CPU, but I'm not hitting that 90% like over and over and over and over that's running. In fact, I suspect it's even finished. Sure enough, I can go over here and see that. I went from 1:16 to 28 seconds just by making that one change and alter database. But I'd even like to go further in my monitoring. Let's go to Query Store and see what it looks like. So let's go to the top resource consuming queries. This may fool you a little bit here in the sense that the same query is showing up with a different query ID. That's because inside Query Store, the first plan, Anna, was running on a 2 vCore. It wasn't possible to run it in parallel. And so Query Store is going to record this as 2 different queries, even though it's the same text. So if I click here and look at this plan now, this faster one, right, you can see from the graph. Remember the average before was like 3.41 milliseconds. I can see here the average duration is like a millisecond. I'm running the same number of executions, but I'm like 3 times faster just by doing that small scaling operation. And then I've demonstrated this. I think we did this even during one of our earlier modules. If I ran that same demo with serverless, it would have just scaled. I wouldn't have had to do anything. So what I'd like to do is also just go back and see, what does this portal show me? I mean, is it any different? So let's go back here and see. Now you can see here, let's go back and go here. Sure enough, you can kind of tell the graph. It's still using some CPU, but it's less CPU than I had at this pure 100% story. And then this is the really interesting part. Like, what does SQL Insights show me? SQL Insights, still loving it. It's still showing as well a smaller CPU. The graph is kind of further out. In fact, let's go pull it out. Maybe the last 30 minutes. The last 30 minutes can show me both graphs that we're actually running. So here, me showing SQL Insights. I'm looking outside SQL. I'm going inside SQL with the Query Store. I'm looking at it from both angles now. And I think I've shown you, I've got the telemetry, the tools, everything you need, and I can scale pretty fast with no database migration on a common performance problem.
Yeah, I mean, it's definitely really cool to see what you can do with the tools that most people have already in combination with some of these other things and make it easier to do that, like T-SQL, so you can just run an alter database command, and SQL Insights. And the fact that, like you mentioned, and maybe some people miss this part, is we're going to keep you online as long as we can, even during the scaling operation. So you just have a minor blip, which I think is different from what would happen otherwise if you weren't running in Azure SQL. So really cool. And, Bob, we have, 15 minutes left, and I think it's really important we spend some time talking about intelligent performance. Now, there's some capabilities from SQL Server that people might be familiar with, like intelligent query processing and automatic plan correction. But because of the telemetry that Azure SQL Database specifically has, there's also some machine learning that we can do to make you run even more intelligently and help you with performance. I'd love, Bob, if you could spend some time and take us through it and maybe even show us that last one.
Absolutely. Just keep in mind one theme as you're looking at this. And if you could kind of go to the intelligent query performance slide there, Anna, I think it's going to help people resonate here. Here is our idea. We want to get you faster and not change your code. Anna, you're a developer. You kind of like that one, right? Like, I just want to get faster and I don't want to change any source code. Don't change my stored procedure, any of that kind of stuff. Why can't SQL Server just do that? Intelligent query processing is one of those options under this intelligent performance umbrella. It's built into the query processor engine, Anna. This is something you just don't turn on like some feature switch in the cloud or a checkbox. You do need to go to a new compat level for your database to take advantage of it. But it's almost like you change your compat level, and then the engine now recognizes all these different scenarios. These scenarios are not things that we just made up in an office somewhere. Joe Sack is not just sitting around in his office going, I think I'll do memory grant feedback. Joe's going to love that comment. I'll probably hear from Joe later on that one. But the idea is this. These are real world customer scenarios. Some of these you may even recognize where support team has told us about it. We've seen it in benchmarks. We've seen it from customer interactions. We've baked this into the query processor. We started this journey in SQL 17 and in the cloud with DB Compat 140. You see that on the left-hand side. We continue that journey on the right-hand side all together with 150. And we're still working on this. This is like a journey that we're not done with. In fact, it kind of is our goal not to ever have to show you this tree or something, but we want to make sure we tell you what we've lit up and help you get faster. Why? We had customers that got faster in SQL 19 and didn't understand why we had to show them this. This is what happened to you, how you got faster. So again, built into the query processor, no code changes, right? In the engine itself. Now, automatic plan corrections, a little different. It is technically part of the automatic tuning family for Azure SQL and SQL Server. And the idea being is that it's all about query plan regression problems based on the query store. So in the query store, if you've got that turned on, we can recognize if a query plan caused worse performance than it did before. Notice the plan 2, plan 3 comparison. And if it did, we can tell you about it. And then if you'd like, you can turn on automation or automatic plan correction, and we'll just revert back to the plan that was faster. Okay, that's on by default for Azure SQL Database. And you can see the results of what we've done through like a DMV. Again, all based on the query store. A good example of us lighting things up in the query store. We've had an Azure SQL for a few years. Also existed starting in SQL 17 and in SQL 19. What's really interesting in the cloud, Anna, here you go. Professor Anna, Anna has to make sure everybody understood what we were saying. So let's all play along with Dr. Anna on a Monday and make sure we got it right. Here we go, Anna. You're going to trick them. I'm sure you're going to trick them. So go ahead. Go ahead.
Oh, man. That was good. Surprise. We're going to do a knowledge check.
Surprise. Yeah.
Okay, so you all should be seeing this up on Learn TV, but basically we're just going to take a quick second. I think I have two questions. Which best describes intelligent query processing, or IQP? So this might seem like a simple question, but you maybe had to have been paying attention. So we're going to take a quick moment, go ahead and get your answers in for this question, and then we'll move on to the next question, and then we'll get on to that very exciting topic that Bob was ready to get into.
But I mean, this is just like being in class. I remember in college where I'm ready for the end of the class hour, and my professor throws up a pop quiz. That's what you're doing here, basically. Yeah. Are you paying attention?
It's a fun pop quiz, though, right?
It is a fun pop quiz. I agree. Let's see what's happening. What's everybody saying, Anna?
It looks like most people are saying C, and then a few people are saying A. Bob, you want to go ahead and take people through it?
Sure. Remember IQP being a query processing in the query processor. And the way you light this up is through database compat level. So it is definitely not A, because it has nothing to do with that. Okay. Now it could be that statistics help us in query processing decisions, but intelligent query processing isn't us changing stats to make things faster. The query processor makes decisions based on a DB compat level. So it's not A. And it's in the query processor, so it's not a background task. And it doesn't require query store. That's kind of nice, Anna. You don't have to have query store on, even though we recommend you turn it on. It's in the engine itself, so it can't be B, so it's got to be C.
Yes, that is correct. And it looks like about 75% of people got that, so that's good. We still have people with us. So thank you for sticking with us. We got one more question.
Okay.
This one is about automatic plan correction. So automatic plan correction can help recommend and fix which type of performance scenario?
Okay. Yeah. We did talk about this when we just talked about it, right? Yes. I used a certain term when I talked about this technology. That's the clue there. Did everybody got that one?
Well, hopefully. We'll see.
We'll see. Everybody's hanging on. They're like,
let's
please,
see.
no more polls.
No
In
more
fact,
polls.
some people attended today and didn't think they had to do any work. They were just going to listen, right? But I
But then
love these
it's
polls
easy,
because it
yeah.
really reinforces, are we really getting forth the message that we want to from what we're trying to teach everybody? So I like them.
Definitely. Looks like we've got a few answers in.
Okay.
Most of them are C.
Okay.
Why don't you go ahead and take us through these just for time?
Well, we just mentioned that this is based on the query store, and it really has nothing to do with indexing necessarily. Although indexing may be something that somebody does to cause a problem, really this is not about that. It's about query plan regression problems. So A is not the answer, and B is not the answer either because it's not about stats, right? This is about query plans that come in that were the same exact query, but a different plan was chosen, usually something called parameter sensitive plans. Also, Anna called parameter sniffing. How do you like that term right there? There's a huge debate on the internet about who at Microsoft invented that term. People have said, is it Kalen Delaney? Is it Connor Cunningham? Is it Bob Ward? None of us are admitting to who created parameter sniffing as a term. Nobody wants to fess up to that. Parameter sensitive plans, though, that is actually what we're really after. So query plan regressions, that's what automatic plan correction can detect and fix.
Awesome. Yeah, it looks like about 90% of people got that. Now, there's one more area we want to talk about today, and that is only available in Azure SQL Database. Can you tell us about it?
Yeah, I mean, you have a database. We have the ability in those scenarios to put some things behind the scenes to look at not your data, but your queries and your query performance. Like, what if we could take query store, visualize some things in the portal to show you, but what's even more powerful, what if we could recommend indexes, Anna? What if we could recommend indexes for you? And then if you were really bold and you just loved what we were recommending, wouldn't you like us to just do it? That'd be kind of cool.
Yeah.
So we have that capability now called automatic tuning, specifically index recommendations, the Azure SQL Database. I think I should show it to you.
Yeah, let's take a look.
Okay. So here we go. One more time, the magic of screen sharing. And this time I'm going to go over here. I'm going to go right here. You see that?
Yep.
Somebody asked about looking at queries and CPU and getting billing information. And I showed you Query Store with Management Studio. How'd you like to go to the portal, though, and look at this? This is a way for us to show you a rich set of query history per query and look at resource usage over a period of time. We're using the Query Store to do this. But here's what's really cool. How'd you like to see this one? Oh, wait, you have some recommendations for me? That's pretty neat. We can go over and recommend indexes to you now, and we can even show you indexes maybe that we helped you with. We can recommend indexes to create and even indexes to drop. And we can even tell you what we predict to be the impact of creating that index. You can go over to this option. You can do it for your subscription. You can do it for your logical server. You can do it for your database. Notice that force plan is on. That's that automatic plan correction, Anna. But create index and drop index are off. I could turn those on. And if those are on, when we feel like we've got a recommendation, we'll just do it for you. Now, you may say to yourself, wait a second, time out. What if you build an index that no longer becomes good for me? We will still monitor you after creating it, and we'll drop it if we need to. Now, here's a cool story. Anna, you're going to get on after this is over, and you're going to go, I got to get my hands on this. I'm going to go run a really bad query and watch it just create an index for me. It doesn't do that. It uses machine learning algorithms in the query store over time to look at your workloads, to look for repeated problems, right? Like if you run one bad query, you don't probably want us throwing an index out there that may affect the rest of your workload and make it bad, right? So we're going to go look over time for these workloads. In fact, when I've had to build this myself and look at these demonstrations, I've had to run something for like an entire day to kind of show the problem. And it's a good idea too, because we don't want to go out there and just build these things at random and make and cause worse performance problems for you. We want to build things that actually are really valuable to you. But let's say you're a developer out there and you're doing an Azure SQL database and you'd love for us to help you with indexing without having to have a sophisticated set of experts doing that. This is something for you. Or you're an administrator and you'd like to see what can we recommend for you first based on you see in the workload. We can do that for you as well. And then even eventually, if you'd like to, we can start applying these recommendations for you. So I love this functionality. It's showing a concept of query performance insight, visualizations in the portal based on Query Store, and the ability to do automatic tuning with index creation and drops, again, based on machine learning and data we're capturing in the query store.
Yeah, it's definitely a really cool capability. And again, just to highlight, this one's only available in Azure SQL Database. Is that right?
Right, that's correct. That's only today in Azure SQL Database. That's right.
Awesome. Well, Bob, it's been quite a day. I personally have learned a lot, and I think our viewers have probably learned a lot too. Just to kind of take a step back and think about and talk about what we talked about. We talked about the capabilities. So we talked about the different capacities of CPU, memory, and I/O you get from scaling up or down, or from your different deployment options. We talked about resource governance, and you even showed us a new demo, which we're going to work on adding to our series on log governance. We talked about scaling up. We also got to see that, so folks can get hands-on and see how to do that using that alter database command or the Azure portal or other tools. We also talked about tools, and we geeked out. We talked about the DMVs, extended events. You showed us how you would walk through and analyze a performance issue, whether it's running or waiting, and then how to address it. So that was all interesting, even seeing how the query store is on by default. So you could just go in and also analyze what's going on with that. And finally, we talked about intelligent performance, some of the capabilities that folks should be familiar with from SQL 17 and SQL 19, and then even new capabilities like automatic tuning, which are only in Azure SQL Database. Now, before I share some resources, can you tell us, now we've talked about performance, what's left in our series?
Well, now that your brain's exploded
Yeah.
with hyper-focusedness, right? I think it's fitting that in the meat and potatoes, even though this is really exciting stuff that we have today, that the last section be about availability. I know when I personally looked at this, it was some of the most powerful technology that we've put into the managed service. And I can't wait to show you guys, and for Anna, you also to show us some demonstrations of how we have built an HADR. I think you're just going to be blown away what we provide you in Azure SQL Database and Managed Instance for availability.
Yeah, it's definitely a fun one. So you're going to want to stick around for it. Just a few resources as we close out today and then tell you about next time. The first one, Azure SQL Fundamentals, this is the learning path we've been talking about. So definitely go check that out. Get hands-on on performance, on security, on everything else that you might have missed in previous weeks. We also have resources here for our GitHub where you can find all these slides under SQL workshops. We also have several different video sources you can follow, like Data Exposed or Azure SQL for Beginners, where Bob and I actually did this series, except over this course of 60 small videos. And then from a books perspective, Bob last year released this book specifically related to translating your SQL Server skills to Azure SQL. So we think it's a very good supplement and even a more deeper dive with some more context to what you learn in this learning path. And finally, we have a book for modern developers by myself and some members on the team. If you're newer to SQL and developing with SQL, I think this is a great option. Reminder that today the Learn module we did was delivering consistent performance with Azure SQL. So you can go there and try all these exercises for free. You can get hands-on on the Azure Sandbox. I know I say this every time, but it's just really great to be able to get free resources in Azure. And, just looking back, you can access all our on-demand episodes at aka.ms/learnlive. And if you want the calendar invite for the next two sessions, we'll be back here at the same place, same time. But those links at the bottom, aka.ms/learnlive Azure SQL Fundamentals, is where you can get the calendar invite so you don't miss the next few episodes. Bob, any closing thoughts on where we've been, where we're going, how the series is going as we close out?
Thanks, Anna. Thanks, everybody, for joining today. We provide you a lot of information, but here's what we tried to show you, just like we did with security, just like with availability. This is just SQL Server, but in a very unique way that's a managed service in the cloud. So a lot of your skills are going to translate, but we're trying to give you the knowledge you need to accentuate that and learn how does SQL Server run uniquely in Azure to make it what I consider the world's database. So it's been great to be with you again, Anna, and I just thank everybody so much for joining us today.
Awesome. Thank you. Hi, I'm Anna Hoffman, and welcome to another episode of Learn Live. Today, I'm joined once again by Bob Ward. Bob, how are you doing today?
And I'm doing great. It seems like I saw you last week, maybe.
And the week before that?
The week before that, the week before that. It's kind of been a repeating sequence. Yeah, so excited to be here today with you and everyone joining in. Talk a little more Azure SQL today about availability. Great, exciting topic, Anna, to talk to today.
Definitely. And for those of you that are joining us for the first time or haven't maybe seen the whole series, we are covering a series of modules which leads up the Azure SQL Fundamentals learning path. And as Bob mentioned, we are now on week 5 or the availability module. Bob, can you tell folks, maybe folks that have joined previous episodes or are just tuning in for the first time, like a little bit about this learning path and what we've covered?
Yeah, think about that journey 5 weeks ago. We tried to make sure we got a level set, a foundation for you of what is Azure SQL, whether it's SQL Server and Azure VM, managed instance Azure SQL Database, and all the various options you're going to be using, just to make sure you understand terminology, Azure Ecosystem, things of that nature. And then you have to deploy this first to start to use it. So deploying configuration being a great topic we covered in the second week, comparing that to a SQL Server experience, and then that meat and potatoes, right? We started with security. Last week we did performance. And this week, availability. None of one of those were a specific ordering, a priority ordering, because you really need all three, quite frankly, to be enterprise ready. But availability being that third topic in the meat and potatoes. And then next week will be a really fun discussion where we'll kind of put it all together and wrap up this entire series.
Yeah, next week will definitely be interesting. So people will have to tune in. They'll want to tune in because it's going to be the most interactive session. We'll have to figure out how that goes.
Yeah.
A few references you'll see on the bottom left and bottom right. That first one on the bottom left is going to be to this learning path in Microsoft Learn. And the second one on the right is a link to a bunch of resources that our team puts together related to SQL. If you select the Azure SQL Workshop, then there's a whole repository that includes the slides that you're seeing today. But today, like Bob mentioned, we're going to be talking about the availability module, and you can find that at the link aka.ms/learn Azure SQL. This is a really great resource because it allows you to get hands-on with Azure SQL services and other Microsoft services for free for a limited amount of time, but as many times as you want, essentially. So definitely go check that out afterwards. Most of the demos you see today are coming straight out of this Microsoft Learn module. We also want to remind you all that this is live and interactive. So just like all the other weeks from wherever you're streaming, we do have SMEs or subject matter experts from our team standing by to help answer your questions on the chat. We want to encourage you to ask your questions on Learn TV because that's where our SMEs are monitoring the most. So head over to Learn TV and be sure to interact with us, whether it's a question, a comment, something slightly related or a tangent, or you just want to say hi. We'd love to hear from you and interact with you. And of course, you know, Bob's favorite part is going to be the knowledge checks that we have. So we'll look for your engagement on those.
Yeah.
So without further ado, let's get into the module. We have a lot to cover today. So we're going to see how much of this we can get through in 90 minutes. I'm just kidding. We're going to get through all of it. It's going to be a lot of fun. So I'm going to get right into it with availability, capabilities, and tasks.
You know, Anna, if you remember kind of how we've done these last modules, we have our breadcrumbs right at the bottom, which are kind of the sequences of what we're going to do in the module. So as you're following along, look for the dot, the blue dot of where we are in the sequence, but you can kind of see ahead of where we're going. But this pattern is kind of how we molded a lot of the things in the last 3 modules for security, performance, and availability. We want you to understand what the capabilities are, so you see what's possible. And then what are the tasks you need to complete to ensure that your Azure SQL deployment is highly available? Now, this is one of the richest areas we have in these 3 sections about capabilities. Why is that? It's because we're using the power of SQL Server, but we're using the power of Azure. A lot of built-in capabilities come for availability, a lot of options for you to make it more highly available. Therefore, you're going to spend more time seeing capabilities here. And they include all sorts of things, right? Like, how about automatic backup restore? Or even in some cases, your ability to control that yourself. Or how about built-in HADR and read replicas? How about going further with availability zones, geo-replication and failover groups, even further just in a single instance type deployment? And then there's some interesting discussions towards the end about comparing just overall availability topics and database consistency from SQL Server to Azure SQL Database and Managed Instance. Now, Anna, replication is listed here as a capability, and I call that out specifically. We're not going to have a whole slide on that, but you need to understand a lot of people like transactional replication, and that full capability exists on Azure SQL Managed Instance. You can go and set up a full transactional replication environment. And a lot of people don't know this, but an Azure SQL Database can be a subscriber, both from a managed instance or even from a SQL Server on-premise environment. So replication, that rich feature that you've known and loved for years, it is available in Azure SQL. We didn't really cover all the aspects of that because it really is just the same of what you might be doing in a SQL Server environment. Now, once you understand these capabilities, what kind of tasks are you going to do? It all starts with recovery time objective and recovery point objective. You decide what those requirements are, and we're going to have something later where we're going to help you a little bit pick some of that. You're going to go pick what we call the addition. This is a combination of like service tier and availability zones and various type aspects in order to get the right RTO and RPO requirements for your business. Then you're going to go configure HADR accordingly. You may set up availability zones or geo-replication or something of that nature. And then you want to monitor. You want to monitor various aspects of availability. We'll certainly show you that. So Anna, that kind of sums up what are the capabilities and kind of what are the tasks you're doing. And the rest of this module follows on the sequence of those topics.
Yeah, I think it's going to be a great module, Bob, and we're going to get hyper focused, and I know you're going to really enjoy it, and so will everyone else. Okay, so let's get right into it, talking about backup and restore. Now, this is something that we get asked pretty frequently about when it comes to, okay, I've moved to a platform as a service. Where are my backups and what's happening? Well, the great news is that we're taking care of a lot of this for you. So typically we run a full database backup once a week with log backups every 5 to 10 minutes. Additionally, we have diff backups that are every 12 to 24 hours, and you get to choose where your backup files are stored. Now, the default option is usually that RAGRS, so read, access, geo-redundant storage. And what that's going to allow you to do is basically if an entire region goes down, this means that your backups are available in another region and you can perform what's called a geo restore. So right off the bat, you're kind of protected against the whole data center going down. But recently we also added options if you maybe for reasons where you want to keep all the data in one region, you don't want to do this. So we have options around locally redundant storage as well as zone redundant storage. And we're going to talk a lot more about zone redundancy later in the module, so you might get a better understanding of why you might choose this type of offering. Now, occasionally, we're also going to run backup integrity checks. So what this means is occasionally we're going to perform a full database restore on your database and make sure everything's running according to how it should be. We're going to run some tests and that sort of thing. And additionally, we have this ability to do a point-in-time restore. Now, this is something many people are familiar with from SQL Server. A few big differences. The biggest is that you can restore to a point in time, but you cannot restore in place. So this means you're going to be restoring to a new database. And really, we do this to protect you. So you restore to a new database, make sure everything is the way you want it to be, and then you can go through a renaming exercise. I actually have an exercise in the module where you can go through this yourself. Additionally, we support long-term retention. So this means if the standard length of retention, that's up to 35 days typically on most deployment options, is not long enough for you, you can actually choose on SQLDB and Azure SQL Managed Instance in public preview to store these backups for up to 10 years. So that's a big thing that customers use. You can even use this if you have deleted databases. You're able to restore your deleted databases from 5 years ago if you have long-term retention set to 10 years, for example. Bob, what's the significance of what we're doing here?
Well, Lena, as you know, spent a lot of time in support customers for enterprise customers for years, and no one really ever called me and said, hey, Bob, I'm really happy right now. My backups are working. My backup restore system is amazing. I'm just really excited, right? It was usually, I can't restore backup. I'm really in trouble. And so we would talk to customers, and I've actually visited customers on site about how to set up a system to do everything that you're seeing right here. This is not trivial. If I told you that I could help you just by deploying in our ecosystem with Azure, I could have automated backups like this. I could have the backups, redundantly stored, even in different regions around the world. I could have a self-service point-in-time restore through the portal. I have integrity checks automatically run. I could keep these backups for 10 years. And anytime I deleted a database, I could just go to the portal and pick and restore it. And if I had told you I gave you all of that, and just by clicking a button and deploying Azure Database, you might want to sign up for that. So, I mean, a lot of people have struggled to build systems like this, and this is a big part of what we're providing with a lot of automation from a platform service perspective for Azure Database and Managed Instance.
Awesome. Yeah, definitely. And it's great to have that perspective of someone who has seen the other side of this automatic backups and restore capabilities. So I thought it would be interesting to take a look at one of the exercises in the module. This is actually a point-in-time restore. Sometimes you'll hear people call it PITR, but point-in-time restore demo. Full warning, I did pre-record this because sometimes it takes a few minutes to restore the database, and we don't want to just sit here staring at it because we have lots of demos to get through. So I'm going to kick this off. What you have here is my AdventureWorks database. So I'm just running a simple select statement, and then we're going to simulate an accidental drop of a table. So let's say somebody accidentally drops a table. I'm just going to make note of when that drop happened. In the exercises, you'll actually go deeper into this process. But for now, we're just going to manually put in the time for when we know that table was dropped. We're just going to set that as the before error time and kick off the AZ SQL DB restore. We're going to specify the database name copy. So like I said earlier, you can't restore in place. You have to restore to a new database. So we're just restoring to AdventureWorks-copy of the AdventureWorks database to the before error time. So that's really all that AZCLI command is doing. Now, this does take a few minutes because what we're actually doing is restoring your entire database. So if it's a very large database, sometimes that can take a little bit longer. But what you're seeing here is we can see that the database is in fact restoring. You can also see what I mentioned about the AdventureWorks versus AdventureWorks copy. Now, once this completes, what we'll be able to do is basically confirm that we now have the before error time. So confirm that we do have that table that was dropped accidentally. So sure enough, we do have that table. So I can go back to Azure Data Studio. Again, this notebook is available in the module, but what we're going to do now is just go through a simple renaming exercise. So we're going to rename the copy database. Sorry, we're going to rename the original database to AdventureWorks-old. And then that's going to allow us to rename the new database from AdventureWorks copy to just AdventureWorks by itself. And now we're basically back to our starting state. So, of course, we were down during this time where all these changes are taking place, but this is going to make it a lot easier for you to manage that because it's just a few commands. And since we're going through this renaming exercise, you won't actually need to change any connection strings. So once this refreshes, you'll be able to see we do have that AdventureWorks database. We also have the old one, which we could delete if we wanted to. So that's a really simple exercise, but I think a powerful exercise that shows you the power of point-in-time restore. So definitely recommend you go try it out on the in the modules themselves. All right, so the next thing we're going to talk about, we talked about backup and restore. Kind of the next thing in our breadcrumbs, as Bob calls them, is we want to take the service tiers and take a look under the hood at actually the architecture that you're getting when you deploy these service tiers. And you've probably heard us allude to this throughout the modules and the learning path, but I think here is really where you're going to get to see what's happening. So first, we're going to talk about general purpose, and this is going to be the same across managed instance as well as Azure SQL Database. If you're familiar with SQL Server, then you're probably familiar with a failover cluster instance, and this is going to behave very similarly to that. So let me just take you through the architecture, and we'll see what I mean by that. So firstly, we have an application. Now, regardless of what service tier, you're going to have an application that's going to the gateways in the control ring, which is basically going to tell the application how to connect and where to connect. And that depends on, if you remember in module 2, we talked about redirect versus proxy, and that's going to change if you're going to the gateway every time versus then going straight to, in this case, the primary replica. Now, for general purpose on the primary replica, we have, of course, the TempDB running on directly attached SSDs. However, your data and log files are stored in Azure Premium Storage, and that storage is also locally redundant storage, or LRS storage. So you can think of this similar to a failover cluster instance. Again, your backups are going to be stored depending on what you choose, but typically by default, people store them in GRS storage. Now, when a failover occurs, what happens? Well, we're going to look for a node with spare capacity. We're going to fail you over, and then we're going to redirect the pointers back to the data and log files. And then we're also going to take care of redirecting you connecting to, say, the database name back to this actual primary replica. So this takes a little bit of time just because we have to look for a node with spare capacity and then fail you over. So we'll look at some other options and you'll see why they might be faster. But the cool thing is connectivity redirection is built in, and you've probably heard us say this a lot of times already, but I'll just say it one more time. Having retry logic in your applications is super important, because if a failover does occur for whatever reason, maybe the node is unhealthy, we have to fail you over, you don't want to enter this downtime because your application hits it and it's offline for, just a millisecond or one try or that sort of thing. You want to be protected against that, and that's why retry logic is so important. So that's the general purpose high availability architecture. Bob, is there anything you want to add to that?
No, I think the thing that's just really critical to kind of emphasize what we talked about with backup, if you look at this diagram, your data files and log files are on redundant storage in Azure. So there's copies of your database already. Their backups are on a different set of storage, and there's copies of those. So, and then we have our replicas that can be used for failover, again, like an instance. So we've given you abstraction to your connection. You don't have to worry about that, right? The app automatically, like you said, with a retry, the gateways redirect you wherever we're going to go. But your data is all redundant. So it's really powerful capabilities just for general purpose alone. That's just built into the platform. It's pretty powerful. And it kind of leads to the discussion about business critical. So if general purpose is like a failover cluster instance, what is business critical? Well, it's similar, but we're going to use the power of always on availability groups, our tried and true flagship HADR capability, using replicas we've had for SQL Server for several versions. Now, the app is still connecting to gateways. It's still going to be used for that redirection capabilities. And you have a primary replica, just like general purpose. But notice here in the primary replica that on the SSD attached drive is your data and log. Now, TempDB is also there. We just don't show that. But your data log are here versus being in Azure storage. And what we're going to do, just like an availability group, we're going to keep secondary replicas. We're going to create them when you deploy a business critical database or a business critical managed instance. And you see here, you have your secondary replicas and the data, of course, on local drives there. Now, we keep 4 replicas available at all times, but just like general purpose, those backups are going to be in a different location using Azure storage. As Anna said, the default would be geo, but you can change it, make it local. But the key is it's redundant. Now, stop, look at this picture for a second. I have redundant storage again, like I had in general purpose, but I'm using replicas for data and log redundancy, and I'm using Azure storage for my backup redundancy. Now, just like availability groups, you want to make sure you're synchronized, and we have to do that to be able to fail over. So we're going to make sure that at least one of these replicas can harden the log change before we're going to come back to the transaction and commit it to ensure we can do a failover. And what happens, like in general purpose for failover, it's a very similar process where we're going to coordinate SQL with Service Fabric, just like general purpose. But notice the difference here. Because of the fact we have a replica, failover is much faster. We don't have to spin up another primary replica or compute to go then attach to Azure Database. We already have been redoing log changes here, right? So all we're going to do is fail over to one of these replicas that isn't synchronized. And here's the cool thing. Your connection, your abstraction with the gateways is automatically redirected to this new primary. Recovery time can be extremely fast here. We're already redoing changes, and we're going to take advantage of accelerated database recovery, which we'll talk about later in today's module, is on by default in these databases. So the recovery time and failover can be extremely fast. And here's the other benefit. Just like you would when you would set up your always on availability group, one of these replicas can be a read replica for you for free. So you deploy business critical. Behind the scenes, we're going to put AGs for you on there, make faster failover time, hence business critical. We're going to put backups in different locations, but we're going to also give you, Anna, the ability to have a read replica. And Anna, you're going to use that same concept of read replicas like you do in SQL Server. Use application intent read only with the same gateway connection strings, and you're often running either using your read replica or using your primary compute.
Yeah, definitely. And it's really powerful, I think, that you can just, just to be clear, like you're not configuring anything. You're just deploying business critical and you're getting all of this.
And I
Same
should
with
comment
general
there that,
purpose.
we show these slides for a reason, to show you what is going on behind the scenes so you know what the capabilities look like. You just remember what we just said. You just go deploy a database, GP or BC, and you just get this. But we think it's important to kind of show you what's possible so you know why we say you're so highly available. And it explains why we can do these service level agreements, which we're going to talk about later.
Yeah, definitely. And, we thought it would be exciting. And this was actually, I think, Bob, maybe you came to me and said, I wonder, the failover time should be faster. I wonder if it actually is. And I said, oh, let me go see. And so this started this experiment. So let me just hop over to my virtual machine and show you guys this example. This is Azure Data Studio. So there's a lot going on here. What I have that you want to be aware of is that the left side, everything on the left side is going to represent a general purpose database. I have this hooked up to a general purpose AdventureWorks database, whereas everything on the right side of your screen is hooked up to a business critical AdventureWorks database. So the same data in the databases, just different databases, different service tiers. Now down in the bottom, what I'm doing is I'm actually using OStress to just do a simple query and on the business critical database here, and the same query over here, but on the general purpose database. Now, this is really just a simple query that's just querying availability. So if you see the number 847, it means that that database is available. So right now on the left side, the general purpose database is available. And on the right side, the business critical database is available. Now, what we're going to do is you can actually use Azure PowerShell commands to force a failover. Now, you can only do this once every 15 minutes. So, we don't want people taking advantage of this capability. But it's an interesting experiment to kind of see how fast is business critical failover versus general purpose. Now, before I kick this off, we would expect that business critical would fail over faster because we already have a replica basically standing by. So this redirection and reconnecting you to the right database should be a much faster process. So let me kick it off and just monitor the availability of each database. Remember, right is business critical, left is general purpose, and we'll see how the demo fares. So immediately you saw this business critical database become unavailable. And like I mentioned, what we're going to expect to see is that it's going to fail over much faster. And it looks like it failed over in about 5 seconds, whereas this general purpose database is still going to fail over pretty fast. However, it's going to take a little bit longer because we don't have an availability group behind the scenes, because we're looking for a node with spare capacity and then we're failing you over. Now, in my experience, the business critical database usually fails over between 2 and 8 seconds. I think one time, Bob, we were actually doing something when it was 2 seconds and you were like, that was awesome. And then the general purpose database, we can see it's back to being online as well. It typically takes around 30 seconds. So it's still pretty great because you just deploy it and this is what you get out of the gate. So that's general purpose and business critical, which are available in both Azure SQL Database and Azure SQL Managed Instance. And we usually talk about the vCore model, but this same architecture is what's used underneath the hood for the standard and premium in the DTU model as well. However, Bob, in Azure SQL Database, there's one more service tier. Can you tell us all about it?
Yeah, let's talk about Hyperscale. So Hyperscale for Azure SQL Database has a fairly unique architecture for a very specific purpose, and that is we are out to give you high scalability and large database sizes. And we have to use an architecture in Azure Platform as a Service with a database to give you that. So it all starts like this. If you look at this diagram right here, we're going to show you, you're going to have compute or replicas like we mentioned in the other diagram, and you're going to start with a primary compute node. And it's going to be running a SQL Server, just like it is in a business critical general purpose. But there's one interesting difference about this SQL Server, and that is the fact that in this SQL Server for this compute node is something called RBPX data cache. Think of this a little bit like buffer pool extension, which we released in SQL several releases ago, but a lot better. And so this represents an SSD drive effectively. And so when you're going after on this primary compute data pages for your database, we expect if possible, as much as possible, to get those pages from either the buffer pool of the primary compute or from the cache. All right. Now we'll talk about secondary computes in a second and how that works. So let's say that you have a huge database and we cannot fit, based on how you provision your vCores, your pages, you can't find them in the buffer pool for compute or in this cache, this SSD drive. So what we have something called our page servers. This is part of what we call a tiered architecture. These, again, are SQL servers that we've architected so that if the SQL server in the primary compute cannot find the page there, it will issue an IO request to this page server. And there are several page servers depending on the size of your database. It too has a buffer pool and an SSD cache. So you can see already here that our objective is for very large database sizes, we're going to use this tiered architecture. You may be asking, like, well, why would you do that? Okay, so what? I've got a 50 terabyte database. Why do you need this? Well, in order to support databases of that size, we're going to put the data and log actually in Azure storage, not in local drives, Azure storage, your actual database files. But you may be asking yourself, well, that's not very fast. But remember, we are mostly serving your data needs from this tiered architecture. We're feeding, and we'll show you in a second how this works. We're taking changes and updating these caches along the way so you don't have to go to the actual data file in Azure storage. It's pretty cool. Now, we'll talk about why it's important, though, to also have these data files in Azure storage in a second. When I first was doing this diagram, Anna said to me, like, there's one piece missing here, Bob. Like, what about the transaction log? Well, as it turns out, SQL servers had the capability for years to the engine itself to refer to transaction log that's remote in Azure storage. As it turns out, our transaction log in this model is in Azure Premium Storage. We call that the landing zone. Now, we also have a separate log service, a compute node, that is going to look at this landing zone here and take changes and apply them to page servers and to secondary replicas. It's not using the exact always-on availability technology, but similar. The concept being is that let's take changes from the log and apply them to keep our caches refreshed and the secondary replicas refreshed as well. Now, for long-term storage, though, because for point-in-time restore operations, you need to keep it for a long period of time, we will push log changes as they age into long-term standard storage for Azure. Pretty cool architecture already. You can see how we've actually implemented something in the log and a tiered set of page servers. Now, the reason we put these database files in Azure storage is very important as well, because we can use a technology called snapshots. So actually taking a snapshot of this database backup is very, very fast. It also allows us to do a point-in-time restore very quickly. And we've been able to demonstrate terabytes, like how about 50 terabytes in 5 minutes? That kind of type speed to do a point-in-time restore. But that's not the only cool story about this. And when we were first talking about this whole idea here, you can do failover just like you can do in the other tiers because we're applying logs to these secondaries. But I put on the slide 0 to 4 secondaries. And you told me we're having this discussion about reviewing. You say, Bob, I think you made a mistake. Surely you meant 1 to 4 replicas. You remember that conversation, right?
Oh, yeah.
Yeah, and I was like, hey, actually turns out 0 is correct, and here's why. The data files are in Azure storage, right? It's almost like a general purpose service tier. So I don't need a replica to do failover. All I need is to be able to get access to those data files and spin up and use my page servers to replenish another primary compute that you would spin up. But my failover time is going to be slower. So if I spin up replicas, my failover time will be faster because those changes have been applied from the log service. So this is why I get this idea of 0 to 4. But remember, in business critical, we only gave you 1 read replica in this environment. Now you get up to 4 secondary read replicas for purposes of failover and for read scale. And so again, that recovery time for here in Hyperscale is going to depend on the existence of these replicas. And you kind of think of this as kind of the best of both worlds. It's kind of the best of a general purpose type architecture, separated data in Azure storage, but also in that business critical mindset. So recovery can be very failure if you decide to put replicas in this environment.
Yeah, it's definitely a super interesting architecture, and I think you're spot on. It's interesting to think that, at least I would think that maybe the failover time if you have 0 replicas would be more like general purpose, because I know we didn't include that in the demo. And then for business critical, if you have more than 1 or 2 secondaries, I would think maybe Hyperscale would kind of behave like business critical. Is that a fair thing to?
Absolutely. Absolutely. Because these secondaries are getting log changes applied to it just like you would do from an availability group. We're not using that exact technology, but the log service is keeping those things up to date. And in addition, Anna, within this, we talked a little bit of this in performance last week. We have services that are monitoring this entire environment. And if necessary, we might throttle log changes to make sure everything is kept up to date so that failover will be fast and maintain our service level agreements.
Awesome. That's pretty cool. One other thing I wanted to call out here, and I think I had mentioned it before, it looks like you might have had a typo on that SQL Server XC. Do we need to update that?
No, Anna, I'm sorry, but this predates you as a person. But when SQL Server was born, this was the MS-DOS days. Do you even know what that is? Oh, yeah. You saw that in the Smithsonian one time. I remember, actually. Yeah. So in the DOS days, you had 8-character limitations dot file extension. SQL Server spelled out as more than 8 characters. So we first created the product. We had to put it as 8 with missing the E. Anna, I can't even begin to tell you, there would be mutiny if I ever suggested to our engineering team, hey, can we actually make that a 9-character thing? Like, I don't even know if the product would function anymore. But yes, it's a legacy of OS2 and MS-DOS days when you had this 8-character limit.
Very interesting. I guess it's just going to stay like that forever.
It will stay like that forever. As long as you and I, for the rest of our lifetime, yes, it will stay like that forever.
Awesome. Cool. Well, Hyperscale is super interesting. I thought it'd be interesting to take a look at a demo. Bob mentioned you could have 0 to 4 readable replicas. So let's take a look at, how that actually plays out in a scenario. So what I have here is I have an application that basically inserts a certain number of events per second, as many as we can. And this is a Hyperscale database, so it's able to insert, it looks like around 14,000 events per second, and we're just going to keep trying to kind of insert events. Now, what we have on the right is SQL query stress, and I'm just using this. This is a read query. It's not writing anything to the database, but I'm running it on the writable or the main primary endpoint. And what you can see is when I execute this workload, what happens is my primary takes a hit because, we're sharing the same replica as far as compute goes. So what's very interesting, and you can see we're going all the way down, it's like 11,500. This is just an average. So what we can do is we can scale up our readable replicas to 4, and then we can go back, and I actually have 4 other SQL query stress windows, just 4 to show we're doing the same workload. Primary events per second. Again, this is just an average, but you can see it doesn't take the big hit like it did on a quarter of the workload when we were running against the primary. So I think it's a pretty powerful example. You think about all these different things that are happening these days, especially HTAP and things like Azure SQL Database, and this can become a pretty big deal. And you can scale these out on demand. So you can say, hey, we're going to run a bunch of reporting or something like that. I'm going to scale up to 4. And then when you're done, you can say, well, I don't really need these anymore. Depending on my availability requirements, I might scale back down to 1 or 2. So that's Hyperscale. Now, fun stuff. We're going to head over to some knowledge checks. This first one is actually pretty tricky. I will give that warning. So be careful. We have had some questions come through on the teleprompter. So maybe we can use this time.
Well, we better, because once again, you've created something tricky. What a shock to everybody.
What a shock.
Yeah.
So
you got a question? You have some questions?
Yeah, it looks like we have one question. Bob, maybe you might be able to take this one.
Okay.
This question seems a bit more general, but it says what are the problems or potential problems with continuous replication?
Yeah, I don't know if it's necessarily a problem per se, but the one thing about a business critical environment or even something like Hyperscale is we do offer higher log rates there. We actually do that on purpose because we know you're pushing a lot of changes through. But because you're using a replica type environment, a log change environment, there could be performance ramifications to that, right? So like if you push a certain number of log changes through, we got to make sure we meet our service level agreements if those failures get very, very quickly. But the good news is that our log rate algorithms and our limits are higher in those spaces than general purpose. And we knew that. We knew that we have replicas to keep going around. So we don't want to put those log rates lower because that might impact performance of your app. So I think actually what could appear to be a problem doesn't actually end up being a problem because of the fact that we set those limits higher.
Awesome. Thanks, Bob. And hopefully that helped with the question that came through. Let's see. Oh, I'm seeing some results coming through now for this question. Maybe we can go ahead and take a look at it. But just to kick it off, the question is, which service tier puts the data and log files on Azure Premium Storage? And looks like we have been able to trick quite a few people because currently about 50% of folks are saying all of the above. So Bob, can you take folks through it and maybe kind of help them out along the way?
Yeah, remember, Anna, how we've kind of treated this before. It's kind of my personal own technique to do a process of elimination. Like I try to go figure out what not the answer is and get down to the point of what are my choices left and figure out what I think the best answer is. So yes, of course, you did a tricky thing. Once again, what a shock. The professor that everybody, loathes to get because she does tricky pop quizzes on us, right? So, oh, I'm sorry, and I make fun of you each week saying that, and you're actually a great professor, but you do make these tricky, man. You do this. Okay, anyway, service tier puts data and log files. We're talking about database and log files on Azure Premium Storage. Let's just put out there that you said Azure Storage. This eliminates B because we said in Business Critical, the data and log files go on a local attached SSD drive. This also eliminates D because obviously if B is not an answer, you can't have all of the above. So it's going to be A and C. We specifically showed you just a diagram where the data and log files for Hyperscale are on Azure Standard Storage. There's the tricky part. But for general purpose, and again, let's emphasize why that is. We can get away with that because we don't have to go after those data and log files except we do a point-in-time restore, but that's with a snapshot. So don't worry about the performance of Azure Storage for your data and files on Hyperscale because we don't really access them ever. But for general purpose, we do need to access them, right? There you go. And so we need to put those data log files on Azure Premium Storage. So therefore, the answer is going to be general purpose.
Awesome. Yeah.
Did I get it right?
Yeah, you got it right, Bob. So well done. I think we might have lost a few people because we only got about 11% of people saying general purpose. So okay. I think your explanation probably really helped. Hopefully help people get it straight.
Okay.
Now we have one more question, chance to redeem yourself if you got the previous question incorrect. This question is, which service tier has an always-on availability group deployed behind the scenes? So hopefully this is a little bit more of a straightforward of a question. While you guys take a stab at answering this, we did get one question in. Okay. And they say, does Azure Managed Instance get automatically scaled when it reaches its 100% storage?
Yeah, the answer to that question is no. Hyperscale does. In fact, there is no 100% storage. With Hyperscale, you don't even pick a storage limit. You just say, I'd like a database, and I'll hear some cores, and we just start giving you storage, and you just keep adding to it. For Managed Instance, though, you pick a limit. Now, one thing it's important to know about that limit, you have a possible limit with Azure Managed Instance for storage for all databases. Possible is based on your service tier choice. Right? You get like 8 terabytes for general purpose, although we're even considering Anna increasing that. And you get 4 terabytes for business critical. So that's the possible limit. And then you pick what is your limit within that is what you get charged for. So you don't have to pick 4 or 8 terabytes, but those are your possible limits. But yeah, when you reach 100% storage with Azure Managed Instance, you get an error. And then you have to go manage that at that point to decide. But we don't scale anything. But keep in mind that if you have a 8 terabyte general purpose managed instance system and you pick 4 as your limit, and then you hit that 4, you can go then scale up pretty simply, to this 8 level if you'd like. But we don't dynamically change that.
Awesome, thanks, Bob. Hopefully that helped answer your question. We got one more question that said, is there availability for the DTU model, specifically the basic and standard tiers?
Yeah, they deploy a similar concept like general purpose, right? So it's going to have that same feeling. We always want you to be available. right? And when you're using Azure itself, so it's going to feel more like the general purpose scenario.
Awesome. Great. Okay, so let's come back to our poll.
Okay.
And it looks like we have about 65% of people are saying B, business critical. So Bob, can you take us through it?
Yeah, so process elimination, right? General purpose is not it, because we just showed you that we use Azure Premium Storage, and you specifically said, Anna, it's like a failover cluster instance. So A and D are both eliminated, it leaves B and C. And I specifically said for Hyperscale, we use log replay type technology, log change technology, but we don't deploy an always on availability group specifically to do that. Therefore, the answer has got to be B.
Exactly.
And then one of the ways to know that, remember we talked about last week that you could see some weight types that you see during an AG deployment with business critical, even though you didn't set up the AG, we did. That's kind of the reasons you know that we deployed that technology. One quick tricky thing I'll say, okay, is that if you use like geo-replication, we may be using some of these technologies, even like in the general purpose scenario. So technically, somebody could come along and say general purpose with GeoDR or something. But I don't think anybody was probably thinking that in their GP answer. So
maybe I should add that as another option, so we keep it tricky.
That would really, yes. Why not? Why not, Anna? Make it harder. Sure. Yeah. Good job.
Okay. Thank you all for participating in these polls. It helps give us a tab on how you guys are doing, and
Absolutely.
if you need to like clear anything up or anything like that. So we've talked about the high availability for different service tiers, and now we're going to talk about a few ways that you can opt in to potentially take that availability a little bit further. So we're going to talk about something called zone redundancy, and we'll start by talking about business critical. Now, if I think first, if I take a step back and talk to you about what is a zone redundant type of database, or what is an availability zone, as you'll also hear us call it, we'll also call it an AZ. So an availability zone just means it has its own separate heating, cooling, water, power, that sort of thing. So it's more granular than a region. So in a region, if your region supports availability zones, then there's going to be multiple of these kind of independent units, and that's going to protect you from, for example, if a whole building goes down or something happens to a building and the power in one building, there could be somewhere else in the region or the data center, another place where your data is going to be stored. And this idea of having availability zones or using AZs to create what we call multi-AZ deployment, it is not just an Azure SQL thing. It's something that we're seeing across many data services and storage services in Azure. But the first one that zone redundancy came to is going to be the Azure SQL Database Business Critical tier. And so if we think about how this works, what you're seeing here is AZ1, AZ2, AZ3. So these are, again, separate power, heating, cooling, water, that sort of thing, each one of them. And so your primary replica is going to be in one. And then what we're going to do is, since you get, again, have an availability group with business critical, we're going to basically spread the rest of your replicas out across different availability zones. So in the case, and of course your backups are still stored in Azure Standard Storage, but in the case that a failover needs to occur because an availability zone goes down, we can very quickly fail you over to one of your other secondaries that's sitting in a different zone. Now, one thing to keep in mind is that you don't have visibility into any of these availability zones. You're simply connecting to your database, and it's going to connect through Azure Traffic Manager to point you to the right control ring of gateways and then get you connected to your database. So this is really nice because you kind of get all this built in, and this is free for business critical and premium service tiers. And this is just going to help keep you protected against zonal outages. So that's business critical. And if we look at general purpose, we recently came out with a preview for this. And that preview came first for your provision databases, and even more recently, I think just a few weeks ago, for your serverless databases. And this is going to help keep your database, again, resilient to zonal outages if it's a general purpose database. Now let's look at how this works. It's a little bit different. So since you don't have an availability group, what we're actually going to do is use your Azure Premium, your data and log files, and spread those across Azure Premium storage accounts that are in different availability zones. So you already have this redundancy before. It was just locally redundant storage, and now we're spreading it across multiple availability zones. Again, you can choose to have your backups in geo-redundant storage, but now that you know the different types of storage, you could also choose to put your backups in zone redundant storage, and we are seeing customers do that. Now, when a failover happens here, again, it could take a few seconds longer because what we're doing is we're going to look for a node with spare capacity, and then we're going to point you to your data and log file that's available in that availability zone because you've spread across multiple availability zones. So this is another way to keep you more highly available. And one thing to keep in mind is that this service is not free because by default, we aren't doing this zone redundant replication of your data and log files in the general purpose service tier. So those are the two main things related to availability zones. Bob, anything else you want to add about availability zones or connecting to services like this?
Yeah, absolutely. I mean, I think one critical point you just said, that you declare that you want this, right? Like when you deploy or later you say, hey, I'd like to be a part of an availability zone with your Azure database. But we show these architectures again because just we're doing all this behind the scenes. You just say you want it, we give it to you, and you see the power of what happens. The other thing is that Azure Traffic Manager, we just do that automatically. There's no app logic here for you. Your application, remember we talked pretty importantly about general purpose and business critical and Hyperscale as well, where the application uses the gateways to get redirected. Well, now Azure Traffic Manager talks to the gateways to direct you, and your app logic is free from worrying about that. So we show these architectures again to show you what's possible, why you get more availability, but a lot of this just happens behind the scenes because you declared you want to be part of zone redundancy.
Definitely. And this all kind of plays into something called a service level agreement, or SLA. And maybe folks have heard that term thrown around before, but Bob, can you tell people what that actually means?
Yeah, I mean, it's really cool what we built, right? And so you're looking at this going, wow, I think I could have a pretty highly available application and run my business on this, right? But like, does Microsoft put their money where their mouth is? Turns out we do when it comes to availability. So we have links for in the slides here, and in our resource at the end, we show you how to get these decks. You can click on it, but you can just search for this. Anna, you can say SLA for Azure SQL, and you'll come to an actual service level agreement contract that we publish on the internet. So when you go deploy as part of your description in Azure, we make a promise or we pay you back Azure credits if we don't meet this, what you see here. So first of all, look at this left side. This is about availability in something called nines or uptime. You may have heard this, Anna, in the industry, kind of a common terminology for uptime. So for basic standard general purpose, now again, we do have multi-zones for GP in preview, but we haven't added that necessarily to SLA because it's not generally available yet. So for general purpose, for example, because you have single zone today as GA, this is your uptime. 4 nines is basically what we call it. For business critical, it becomes 4.9. But notice if you go to zone redundancy, this becomes 99.995. Anna, did you know that's actually called 4.5 nines? And you might be interested to kind of translate that. It's about 2 minutes a month of downtime. So we're only giving you, we're promising that you're only going to have 2 minutes a month of downtime on average across the year if you'll go to a business critical in a multi-zone deployment. And then it's interesting, Hyperscale right here, notice this one. We said as you get more replicas, you're faster and you're more available, and our SLAs kind of back that up. So if you go to 2+ replicas, you're going to have more availability and an SLA than you would if you had like 0 replicas. So that's kind of like your SLA from a nines perspective. Now this right side's interesting, Anna. We're the only database in the cloud industry today that offers and promises RPO and RTO as part of an SLA. Now you'll notice here, we only do this today for business critical, and you must use GeoDR, geo-replication, or auto failover with business critical. And if you do that, notice our SLAs, 5 seconds for a point recovery objective and 30 seconds for recovery time objective. That's pretty snappy. So again, look at SLAs. You can look what we publish on the internet about it and your contract. You sign up for a subscription, you deploy it, You don't go have to pick anything. Just by deploying it, you're getting the promise of what we show here on this slide.
Yeah, I think it's pretty powerful. And, if most people go ask, their local center what their RPO and RTO is, a lot of times it's not going to be what this is, and you didn't even really have to do anything to get it.
Right.
So pretty cool. We actually haven't talked about GeoDR, like you mentioned, geo-replication or auto failover groups. So I thought it'd be a good opportunity to kind of just cover that. Now, there are differences between these, kind of a lot of differences, like why you might choose one versus the other. So I created this chart that basically compares things for geo-replication versus auto failover group, and then the blue is what might be preferred. So for example, geo-replication supports having your replicas in the same region as your primary. It also supports having multiple databases being replicated. So you might replicate to East US, East US2, somewhere in Southeast Asia, the UK region, all these different regions you can have multiple of, and you can use all of them for read scale. So you can kind of scale where your app users are, people running reports are. Now, something to be aware of with geo-replication is it's not supported for Azure SQL Managed Instance, and there's no aliasing over top of it by default, so you do have to update your connection string after a failover. Now, with auto failover groups, some of the things that you get that might be representative by the name is you are able to do an automatic failover if something goes wrong, or if you want to force a failover, and you don't have to change the connection string because you are just connecting to the failover group read-only listener versus the read-write listener. Some things to be aware of, though: you cannot have multiple of these, just one failover group per server, and it can't be in the same region as your primary. So that's just some things to keep in mind. For people who are more visual learners, Bob, can you tell us how it kind of displays itself in the architecture?
Yeah, I'm a very visual person. I love these diagrams and so forth to kind of talk through it. And if you go deploy geo-replication with Azure SQL Database today, for example, it might look something like this. Notice here and you mentioned before, just to be clear here, you could do geo-replication in the same region. We're showing this across regions, though. And the idea being, though, you have a database here using geo-replication to another logical server in another region, right, in this particular case. And your read-write traffic is going to this primary. But you could do failover, right, to a secondary server, and using something like Traffic Manager, you can redirect your app for write purposes into the secondary server. But you do have read-only traffic, right? And so read-only traffic is really interesting because read-only traffic can occur, obviously, in the secondary. So if you want to set up geo-replication and have your read-only traffic, remember, Anna, for example, a general purpose doesn't have a read replica. Remember, we talked about that, right? You only have that business critical. So let's say you need a read replica of general purpose. You could do geo-replication and have that capability. So you notice here that your read-only traffic is directed into that secondary logical server, which again, it could be actually in the same region we're showing here in a secondary region. Now for managed instance, as an example, or it could be with database, but we show this kind of a little bit with managed instance because this is your choice. There's a good reason why it's called auto. In geo-replication, you're responsible for updating connection strings when you do a failover for your read-write traffic, whereas in auto failover groups, that is being handled for you automatically. And in fact, the reason that's being handled is we have this listener concept for you to set this up so that that can be redirected properly. And you got a listener both for read-write traffic and for read-only traffic. But notice, Anna, here that you've got a multiple icons. It's called failover group for a reason, because multiple databases can be part of the group to fail over to the secondary, or you still have that same concept of having your read replica access on the secondaries as well. So if you kind of compare these a little bit side by side, you can kind of tell the differences here. So geo-replication being a great option for you, but it says manual failover, does give you read replica capabilities, whereas auto failover groups, that's why it's called auto, are going to give you that automation. Now, one thing I should call out here, Anna, a little bit is that you do have the ability in these cases to ensure things are synchronized during like auto failover. Like there's even options you can configure, like how long should we wait to make sure you synced up your changes before you fail over. Or there's even stored procedures you can add into your application to ensure things get synchronized before you do that failover concept. So there are some aspects to these that we document how to do it. These diagrams look fairly complex, right? but it isn't as sophisticated as it looks. In fact, I actually think you should do a demo. Maybe I'll make it seem a little easier for this visualization I just showed everybody.
Yeah, definitely. Yeah, let's take a look at a demo of auto failover groups. And again, this is one that is available in the Learning Path. So if you want to go try it yourself and see how easy it is, I'm not going to step through all of the steps today, but you'll be able to see some of them. So let me just resituate my screen. So again, this is another notebook in Azure Data Studio. This is a PowerShell notebook. And you can see up to step 7. So basically what that means is there were 6 commands that got me all set up. Deployed the failover group, deployed the secondary server, decided which databases I wanted to sync, add networking access to both regions that are going to need to have access to it. That's an important part. And basically we're able to initiate a failover from here. Now what I also have, and let me see if I can do something there. Didn't quite work, but that's okay. But what we also have over here is a very simple Java application. And what it's doing is it's connecting to the read-write listener. And then it's trying to insert a row there. And then it's connecting to the read-only listener and trying to read that row that was just inserted and just reporting back at whether or not it was successful or not. So what I can do is I can first use this command, and it's the get AZ SQL Database failover group. So in this case, this is for an Azure SQL Database. The process is very similar for Azure SQL Managed Instance. And I'm basically saying, okay, for my, you can see it here, what I've defined as my DR server, what's the replication role? And I can see it's in the role of secondary. And now what I can do is I can use this switch command, so switch Azure SQL Database failover group, and say, hey, I want the DR server to become the primary or the read-write. So now if I run that and I switch over and look at my Java application, what we should see is that for a certain time, and here you can see it, we're failing on our inserts and our reads as this failover takes place, and we actually switch under the hood what you're connecting to. And so we can see we'll get a few failed inserts and reads, but once we're back to being connected like we are now, we can see that without me changing anything in my application, we're back to being up and running. So a few things here. This is why it's so important to have retry logic in your application. And also auto failover groups having this read-only listener and read-write listener is so valuable. So again, just to confirm that we are now connecting on the read-write to the DR server, we can run that same command as before, getting the DR server's replication role and seeing that it is in the primary. Now in the exercises, you also have the opportunity to go ahead and fail back. And again, in the application, you would expect to see a similar behavior, some number of failures before going back to being successful. Now, one of the other interesting things that we won't do today, but you can do in the exercises, is to figure out how many read replicas you get from actually deploying this availability group, or sorry, this failover group. And it becomes an interesting question when you have, say, a business critical database and you deploy an auto failover group because, you have the readable from your main location region, and then from your failover group, you have the readable listener, but you also have another readable endpoint. So lots of options there. And you can see this failover occurred successfully as well. So that's auto failover groups. This is a fun exercise. I definitely recommend go checking it out and just seeing how it all works, and seeing, you can even use the Azure portal if you want to kind of see those failovers taking place. So now that we've talked about some geo-replication and auto failover groups, I think it'd be good to talk a little bit more about the databases itself and how do we keep them available and consistent.
Yeah, thanks, Anna. This is going to feel very engine heavy, so get ready for some hyper-focused engine stuff. But if you remember back on when we first talked about this entire exercise, the entire training we've done, a lot of it was assessing SQL Server that you know and love today to what happens with Azure SQL. Again, it's the same SQL Server engine there, but there's certain aspects that you're used to doing in SQL Server that you want to know, is it still there in Azure SQL? Do I even still need to do it? So from an availability perspective, first of all, you can't set your database offline or emergency mode. You're like, oh, I need that. I've got to go do that. Well, why do you need to do that though? Because you're trying to do some sort of advanced repair typically. In fact, I did that my entire career with SQL Server. That's not necessary because of what we have in place from an availability and HIDR perspective built into the service itself. Now, restricted user access is definitely allowed. So if you need that kind of type thing to kind of only allow certain people in to do certain things in the database, you can do that. And then if you want to do some advanced diagnostics though, and say you've got an application that blocks everybody, and it looks like your SQL's hung, but it's really not. You can use a dedicated admin connection. We call it DAC. You're allowed to do that. And I've been able to demonstrate that before and use that with Azure SQL Database and managed instance. And then we'll talk in a second about this powerful capability I mentioned already once called accelerated database recovery. This is on by default. And guess what? You can't even turn it off. We feel that important that we need that to maintain those service level agreements. So that's on there, just built into the service itself. And we'll talk about in a second why that's powerful. Now, Anna, for database consistency, I kind of made it a career patching customers a long, long time ago, customers calling in, having a problem with their database, and not necessarily because SQL Server had a problem. It was typically with the IO system. And so consistency became a big thing to check and to fix. Keep in mind what we already told you. We have multiple copies within the environment of your data and your backups by default in the system. So the likeliness of like a hardware failure causing problems for you and not getting access to your database becomes very, very minimal. You can, though, run CheckDB. If you want to just check the logical consistency of your database, you're allowed to do that and take a look at that. You can't repair it because that would require you to put database in single user mode, which you're not actually allowed to do. So you can't repair things with CheckDB, but that's actually okay. Because consider this. We put database checksum on default, by default, and if we detect a problem, in cases like in business critical, we can use the auto page repair functionality of availability groups to go back and online restore a page you don't even know it's actually happened. But also behind the scenes, we do a lot of monitoring of your system to make sure things are available. So any data integrity problems, we will actually monitor and get alerted to see if we need to help take action if something couldn't be corrected automatically. We mentioned already, like for backup, we do integrity checks, and we even do integrity checks to test restores of your database, so we're automatically backing up to ensure they have high integrity because we're using checksumming of the actual backups themselves. We even deploy things like lost write and stale read detection behind the scenes to look for very strange, kind of like tangential type hardware type issues we've seen across the years. We have those on by default. And then look at this. We may actually go do a repair of your database and not even notify you if we determine there's no impact to your system. But if we think there might be impact to your application and we need to do some sort of repair operation or some sort of advanced restore of some redundant copy we have a very robust proactive notification system with our engineering team directly to you as a customer with your subscription to kind of help you out. So if you kind of put those together, Anna, between what's possible for availability reasons for you, but also what we do so much from an automation perspective to keep you consistent, it's a pretty powerful story.
Definitely.
Well, there wouldn't be any more powerful story than to talk about accelerated database recovery. And Anna, let's do something fun. Let's kind of do a fun exercise. Let's tell a story of Bob, helping customers in his career at Microsoft. And it kind of goes something like this. So There's this guy. Have you heard this guy, Buck Woody, Anna? You ever heard him before? This guy, Buck Woody. So Buck, let's say he is running an application and we give him SQL access directly to run SQL commands. I don't know why we would even do something like that for Buck Woody, but he goes out and runs a transaction and he ends up accidentally deleting 1 billion rows in a table in a transaction, which is really bad, right? So because he does this operation, he's kind of blocked all the applications, which is actually bringing our business down. Now, Anna, you are kind of like a DBA, and you realize you've made a mistake to give Buck this kind of type access, but it's okay because you can kill his session. I know you probably want to take care of him, but you're going to kill his session. So you go in and kill his session. You think you've taken care of it. It goes in this rollback state, and you're like, "What the heck am I going to do?" You call me, like, "Hey, you were on the phone with me, you and Buck. You're like, hey, Bob, what are we going to do now? What's going to happen now? We're in this rollback state. How long do we need to be in this rollback state?" And I'm like, well, a while. It's going to take a while because it has to roll back. And so behind the scenes, though, on the phone is Elaine Dormal, our friend Elaine. He works with us. Now, Elaine read on the internet somewhere. You guys are talking to me, but he whispers to you, "I can fix this. I learned on the internet if I just crash SQL Server and we just tear it down and just kill the process and bring it back up, it'll just recover and it'll be great." And so you're like, oh, Bob, sorry, we don't need to click. And I'm like, what's going on here? Do they still need my help? And so Elaine does this, and you guys are trusting Elaine, and you do that, and you bring it back up, and in the error log, it starts printing 1%, 2%, and you're both staring at Elaine now going, great, what are we going to do? Now, Pedro Lopes, our other colleague, he manages the transaction log, and this entire transaction log cannot get truncated. So literally you run out of disk space on the system as well because the transaction log goes out of control. This is disaster. Now, Buck started the disaster. It sounds like Buck, right? But you all contributed to this problem. Actually, it's not your fault. It's SQL Server's fault. Like, why do we even allow you to get in this situation? Along comes accelerated database recovery. In fact, I did a LinkedIn post in this last year. ADR saves the world from long recovery problems, right? And so it's really interesting on how this technology works. Let's talk a little bit about it, okay? Then we'll see a little demonstration. So first of all, from an ADR perspective, what we're going to do is we're going to use a persisted version store in the database, not the version store in TempDB. We're going to record versions in your database to make things faster. Now, it's independent of locking and isolation levels, so all that stuff just still works. Regardless of our versioning, we're doing this all the time. But here's the interesting thing. For SQL Server, for snapshots, we use versioning in TempDB to support the concept of snapshot. Here we're using versioning for recovery and rollback purposes. Now, we get to take advantage of it, though, if you do a snapshot, but you still get read-committed isolation levels, even though we're using versioning. Now, rollback gets ridiculously fast. It's like so fast you can't even imagine. That crazy scenario where you kill this session would just roll back immediately, which would be kind of nice, right? You wouldn't have to go crash SQL Server and call me and all that kind of stuff. In fact, under recovery, even if Elaine had done that, what happened so fast, you wouldn't even see a percentage showing in the error log because it's that quick. And then Pedro doesn't have to worry about anything because the transaction log gets truncated. It's not tied to this big, long, active transaction. Anna, I know that sounds like way too good to be true. It's not for free. Like, what is going on here? But remember, accelerated database recovery is on by default in Azure for a very good reason. We believe that it will not greatly affect your application. And Anna, here's a great tip as a presenter for you. If people have questions like, does it require more space? Will it affect performance? The great thing to do is just point them to somebody else that's giving you the answer. So that link, people can research constant time recovery. It's a link in the deck as well. It's a white paper written by the developers who wrote the code. They wrote this very extensive paper as a kind of a computer science type paper because of the project they did. And we first did this in the cloud. We turned this on in all these databases in the cloud. And then in SQL 19, we made it a feature that people could actually use. And I think you're going to love it. If you go look at that paper, all these questions are going to be answered. And in fact, what's really cool is that for availability groups, it even makes it more powerful for failover and for read replica purposes. So this is amazing technology. One of the most innovative things I think we've done in the engine space in several years. So why don't I take a second perhaps and share my screen, Anna, and I'll show you a little bit of what it looks like.
Please.
Would that be okay?
Oh, yeah.
But I promise not to, get anybody in trouble like you or Buck or Pedro or Elaine or something like that.
Yeah, so let's not kill anybody or any session.
Or their session. Yeah, their session. So, okay, let me know when you can see my screen.
I can see it.
Okay, so just for everybody's purposes, if you're using this demonstration won't work in Azure. You're like, well, why are you even showing us today? It's because it's on by default in Azure. So you can't see the differences between not having it and having it because we're just fast. But if you wanted to try this is part of the SQL 19 workshop, which we have resources at the end to show you how to get all our workshops. And so this is a T-SQL notebook, kind of like Anna showed you some notebooks with PowerShell. I'm just using a pure SQL notebook. And one of the things I'm going to do, Anna, is I'm going to create a database. And Anna, if you get to come on and say that Tennessee Titans are all this great and I love them and so forth, I get to promote my Cowboys. So here's my database called Go Cowboys. And I've got a table of about 100,000 rows. So what I'm going to show you, Anna, is that what does this look like when you don't have ADR and you have ADR? And Azure, of course, on Azure, it's on by default. So let's come along here, and we're going to delete all the rows in the table that Buck Woody had done if it's turned off. And so we do this. It takes about 5 seconds, but we have an active transaction now that's out there. It's only 100,000 rows, but it still could affect us. And one of the things it could do is affect log usage. So you see here, Anna, that the log here is used at 91% because it's an active transaction out there. Now, I made this a simple recovery database in SQL Server. And if you did that, normally like a manual checkpoint could free up the log. But notice here, it doesn't free up much of the log. And again, because I'm using an active transaction. So I'm going to try a rollback. Instead of like killing the session, I'm just going to roll back this transaction. And you'll notice here that it takes about 11 seconds. Now, why is that? That's because we're using the standard Aries algorithms now, not ADR. And so for all those deletes, I got to go put in the log a bunch of inserts to compensate for what I did to support the concept of recovery for rollback. So that's why it takes 11 seconds. So during this entire time, I'm down. Like I've blocked everybody. And the log can't be truncated, which is not a good situation. And again, if it was a billion rows, it could really take a long time. So I'm going to scroll down here and show you when I turn on this feature. In SQL Server, it's an opt-in for your database, where in Azure, of course, we're just doing this by default. So let's go down here, do the same thing to delete our rows. Now let's go look at that log usage, which was important before. And notice here now that after a manual checkpoint, I'm even down to 7%. So, I was at 91 and 79 before because an active transaction was there. The active transaction doesn't affect this because I'm using versions in the database itself. Now, how fast is rollback? Let me scroll and just leave it right there, Anna. Do you want to take a guess of how long it took to do this? It took 11 seconds before.
Like
what do you think?
5
seconds? 5 seconds?
Yeah.
How about less than a millisecond? Look at this. This is how fast rollback is.
Wow.
Now, why is that? I mean, is that like a fake thing? Like, do I fake type in that text in there? I didn't do that. That's because in a rollback, all we have to do is mark a single record in the log as being aborted and mark the version aborted in the row, and that's it. SQL Server handles the rest of it. I've got another exercise somebody could do offline that if you go do the crash SQL thing, you can see where it took like 5 minutes to recover the database with undo recovery. When you're using ADR, it happens so fast you don't even realize. It just happens and the database comes back up. This explains again, Anna, why in Azure SQL we can do these SLAs though. Because we're using ADR, and even if you've got a long-running transaction or something, we can do a failover and get you up and running very, very quickly because ADR is in place by default in the system.
Wow, that's pretty powerful. And so this is on by default in Azure SQL. So there's nothing to do here except to just take advantage of it.
Exactly. And watch it fly.
Cool. Well, thanks for showing us that. That was pretty cool. I'm pretty impressed how fast it was. I'm gonna have to go try that myself, but not on Azure SQL because it's
fast.
Okay, so we've talked a lot about different capabilities when it comes to availability, and really the last thing we want to talk about is the task. So what do you need to do? Well, a big part of this is just understanding what all the different capabilities are and the implications. How does it affect your SLA? What is the SLA that you even need? And what are the various things that you might use in order to reach that SLA? Are you going to need long-term backups? And, is 35 days long enough? Is 2 years long enough? Figuring out those sort of things are going to be really important, as well as, what type of read workloads are you handling? How many read replicas? Do you want it like in business critical where you have the read replica all the time? Or is it more ideal for a scenario like Hyperscale where you don't necessarily have one all the time, but you can scale up to 4 when you need them? Lots of things to think about, even when we talked about geo redundancy or GeoDR, whether you're going to use geo replication versus auto failover groups. And then Bob, a big one I think people overlook is your application ready? Can you give some pointers on what you might want to do there?
There's 2 things that stand out. You mentioned one of them, and that is retry type logic. But keep in mind this: today with SQL Server in your environment, when the computer is down, the server is down, or SQL is down, you're used to seeing a certain error when you connect to retry. Remember with our gateway system, the gateways could be up, but the SQL server is failing over, and you get an error there. It's not like a connection error. It's like, hey, you're failing over. So you need to get used to running in our environment and kind of see, do I need to handle certain types of errors a little bit differently to do that retry thing? Another cool thing, Anna, is that we have a new thing we just announced called DNS aliasing. So for like the GeoDR type scenarios, you can set up a DNS alias, and that could be directed automatically to the GeoDR. So therefore, you wouldn't have to change like the connection string of your application when we talked about that kind of thing. So there's a couple things from an app perspective. Mostly it's around the retry type of logic, but check out DNS aliasing. We just launched that.
Yeah, that's definitely an interesting one. The only other thing I would add is, when you think about these geo situations and disaster recovery, it's great that, we have all these options for your database, but you might want to make sure you're doing the same exercise for your application because, for example, if you fail over to another region, and your application is still in this main region, well, one, you're introducing a lot of extra latency that you might not have had to think about in the on-prem world. But two, if that region's down, maybe your app is down as well. So something to think about there. Bob, as people go to like look and say, okay, am I up and running? Like what's the process for monitoring?
Yeah, just like in SQL Server, there's several things you might want to monitor. One of them could just be like, is a region or data center available that you've deployed to? Like, is the West US down or something because of a problem in the actual data center or something of that nature? But you also might want to see, is my server available? Is the database available that I have? What does it look like from a backup restore perspective? My database is getting backed up. What's the history of doing restores, some of that type of nature? You might want to see my replica status, right? What is going on from a replica perspective? You want to see, like, is it being replicated to? Is it being synchronized? Is it synchronized? And then also, if a failover occurred, you might want to find out some reasons behind that happened. So there's different things you want to monitor. And then we give you certain assets to do that in different ways. One through the Azure portal, one through like T-SQL, and one through CLIs. So if you think about the Azure portal, you can use like service health dashboard and feeds to not look necessarily at your specific server or instance, but the overall Azure SQL availability. So if you want to know, oh, hey, is East US having any problems for like all Azure SQL users? We have a way of showing that through this dashboard, and you can do feeds to kind of see that as well. But if you want to see specific health for your resource, we have something called resource health that you can look at in the portal to see, oh, it looked like your specific database wasn't available at 3:15 p.m. for a period of time. And here's some reasons behind all of that. And then Azure Monitor helps you with this as well. There's some things you can do to look at alerts and metrics and even do log analytics to get those kind of type events. Now through T-SQL, we have things, for example, Xevent. Like backup history isn't specifically available. You can use Xevent though with say managed instance to go look and see the history of what backups are being done. Although you can for long-term retention see some of those things. And even things like catalog views and DMVs give you other capabilities to look at things. You have just the basic sys.databases query to see what's the status, of my database. And then because anything you can do in the portal, you can do CLIs. You have as CLI, you have PowerShell, and even REST APIs to go look at these various aspects of failover reasons, replica statuses, server and database availability. You can even monitor this, Anna. You could even do PowerShell, for example, to go through and monitor all the statuses of my servers or databases and kind of see where they are. So it's a rich set of availabilities. And I'd be remiss if I also didn't mention that we have management packs. Some folks are system center users and they want to know, I like management packs. We have specific packs for Azure SQL Database and Managed Instance that were built for the cloud that help give you some of those rich capabilities you're used to seeing on SQL Server.
Awesome. Yeah. Thanks, Bob. This has been a great overview of all the different options. I'm going to put up the next knowledge check, but while people are taking a stab at that question, I wanted to ask you, last week you showed us some of this new stuff. I think it was Azure Monitor SQL Insights. Yeah. Do you think that's a tool? I know you mentioned Azure Monitor. Do you think that's a tool that people can use not only to monitor performance, but also availability?
Yeah, absolutely. Because there are certain metrics in there that apply to just the availability of things, right? They're not so much as performance driven. I think SQL Insights is more of a performance tool for you, but there could be things in that model that you could consume with log analytics or even through the portal we have that could help this overall process of saying how available am I and how things are getting replicated and so forth. So absolutely.
Awesome. Thanks. That's good to know because that's a really cool solution that I just started recently getting my hands on that one. Okay, let's take a look at this question. So it says, what methods can you use to monitor region and data center availability? So Bob, we've got a few answers in. It looks like most people are saying option D. Can you take us through this one?
Well, we did say that the Azure dashboard, right, has the ability, and we focus on the fact that it's about a region and data center availability. So you have that, but we also said you can get alerted and do feeds, right? Things like text alerts and email alerts. We said that. So just by the fact that you can look at the dashboard and you can look at alerts, tells you that like it's got to be A and B for sure, right? Well, there is no A and B, but there's a D. So it just goes to make sense that D would have to be the answer because I can do alerting and the dashboard. So And we do this for an important reason. You might want to visually look at a dashboard, but wouldn't it be nice to get a text alert to say, hey, the East US is down. I better go look at something, right?
Yeah, definitely. And it looks like most people ended up getting that one. So
okay, cool.
Great job. Okay, we have one more question today. So this is the last knowledge check. We're going to step it up a little bit. This one is, which of the following is not a way you can monitor instance server and database availability? Bob, do you have any hints on this one? Because this one is kind of tricky. I think you actually came up with this question.
Yeah, I don't think so. Good try. This is an Anna special. There's a keyword in here that starts with an N, so I'd pay attention to that one. Looking at that keyword not is going to help give you some clue on what the answer might be. So yeah, make sure you focus on the word not and monitoring specifically. We're talking about individual resources here. That's kind of the clue, I think, if I would go through and look at the answer here. Awesome. But good try to put a knowledge check on top of me. That's not the case.
I had to try. It looks like we've got a few answers in on YouTube and also on Learn TV. Looks like people are leaning towards option A. Why don't you take us through it?
Yeah, we just talked about the fact that if you want to monitor your instance, your server, and database, you had this resource health capability, right? That was a way to do it. That can't be the answer because it's not. We're doing a negative question, right? So that works. And then I said for things you can do in the portal, you can do with CLI, right, with PowerShell and Ask CLI. So C and D are ways. They can't be the answer. So there's only one answer left, and that's Azure Service Health. And we're just trying to point out for you that that's more about the overall state of the service, which again, it does affect you and what you're doing. But if the overall Azure service is there, your database could actually be okay. So this is just a way to look at the overall health of a region or a data center and not specifically for your database. Just keep in mind, it's very important that you go out there and look at a data center problem, and it may not affect Azure SQL. It could be something that affects something unrelated to your thing. So if you get an alert to say, oh, East US has a problem, it may not be an Azure SQL issue. It may not affect you. But we are part of the Azure infrastructure. So there are other Azure resources like storage, networking, et cetera, that could impact your application. So it is important to monitor the health of services within the region you deploy.
Awesome. Yeah, I think that was a good question, but I also think everyone answered correctly. So
you probably, you went out there on one of those other things like you do, like in YouTube, and you just gave the answer, didn't you?
Oh, no, I
didn't. Yeah. Uh-huh. Yeah.
Sure. You got some smart people on the call.
I agree.
So let's summarize what we talked about. So we started with backups. It feels like a long time ago because we've been so deep into availability, but we started with backups. We led into high availability through the different service tiers, including things like read replicas, including getting a higher SLA, and in some cases with zone redundant configurations or multi-AZ deployments. We also talked about how you can go geo, get geo-distributed applications with things like geo-replication, auto failover groups. We talked about trying to figure out how to make the right choices so that you meet the SLA that you desire. And then, Bob talked us through some different things you can monitor and different ways you can monitor. So, this is the kind of nearing the end. We've got some resources and some other things to share, but nearing the end of the series, we have one more episode left. Can you tell us, Bob, a little bit about what's next?
Well, we covered that meat and potatoes. This is the end of that section, right? Security, performance, availability, very core SQL things we need to talk about. When we first built this series, you came to me and said, is that it? And I'm like, yeah, that's it. And you're like, well, let's put it all together somehow. And so I'm like, I love that idea, Anna. So we kind of brainstormed together and said, how do we find a very creative way for you to take all this knowledge we built over the last 5 weeks and put it together, like kind of from a solution perspective? And then also, are there other stuff? Are there other things that we didn't cover that don't fit nicely in this meat and potatoes? So I think that would be a great idea next week, is to kind of find a way to wrap together everybody's knowledge, and maybe even also talk about how to go bigger with Azure. We really kind of focused on how SQL works from an Azure SQL perspective and things that really are powerful for Azure SQL, but there may be more ways you can do more in the cloud. So we should sprinkle that in there as well.
Yeah, definitely. I think it's going to be a really fun week, and we'll keep it really engaging and put out some asks for you all to kind of participate with us. Before we go, we wanted to share some resources with you. We talk a lot about a lot of different things. So just to remind everyone, that first URL is going to take you to this learning path where you can get hands-on with availability and any of the other modules from the Azure SQL Fundamentals learning path. The second URL, SQL Workshops, if you go into that and select Azure SQL Workshops, you can also find other code samples, and more importantly to most people is the slides. That's where you can get these slides. That's where they're hosted. The Azure SQL Docs is a great place to find anything you're not sure about. Whenever I go to Bing with a question, I always type Azure SQL Docs and then the question. It usually takes me right to it. If you like videos like this or hearing from us, Azure SQL for Beginners is a series Bob and I did last year. That's 61 episodes covering these topics, but more in like bite-sized chunks. So if you're like, oh, I really want to remember what the business critical architecture was, you could just go to that video because there's one video on that topic as opposed to having to rewatch this entire series. Also, shameless plug for Data Exposed. It's our show on YouTube and Channel 9. We go live on Wednesdays and we release new episodes on Thursdays. And then some books that have happened in the past year. Bob wrote a great book, Azure SQL Revealed, that is kind of along the same themes of this, really translating your SQL Server knowledge to Azure SQL. And then another book that myself and a few folks on the team wrote last year as well was around Azure SQL Database for developers. This dives a little deeper into Azure SQL Database just from a development perspective. So both two really great books to check out if you really want to learn more about these topics. Again, today what we covered was the availability module. So you can go to Learn Available SQL. That's the URL. And if we look at our schedule and you say, hey, I really wanted to know what you guys said about security, well, all of ours recordings are hosted at aka.ms/learnlive. And if you want the calendar invite for our last episode, it's going to be so sad not to spend my Mondays with you all. I don't know what I'm going to do, but is next Monday. So be sure to tune in. You get the calendar invite at this URL. And like Bob mentioned, it's going to be very interactive. We're actually going to take to Twitter, we're going to take to YouTube, and somehow we're going to get you guys engaged because we have some really challenging case studies, and we're going to look to you to help us find the answer. So definitely want you all to turn in to Learn TV next week. Bob, any final closing thoughts?
No, thanks, Anna. Thanks for being a part of this today. Great demonstrations. You did a wonderful job as always. Thanks everybody for tuning in. Listen, we think this is important stuff. You want to go past DP300, just go through this material. And people have told us they've been able to do that. Remember, this is just SQL, but it is the power of SQL. And we believe Azure is the best place to run SQL in the cloud. So I hope today's availability session has helped, kind of convince you that's the case.
Awesome. Yeah. Thank you so much, Bob. Thanks to all our viewers. Thank you. And we'll see you next week.
Bye.
Hi, I'm Anna Hoffman, and welcome to Learn Live. We are super excited to be having you here today for the last episode in our series on Azure SQL Fundamentals. Today, we'll be covering putting it all together with Azure SQL. And today, once again, for the 6th time, I am joined by Bob Ward. Bob, how are you doing? Thanks for joining us again today.
Hi, Anna. Thanks for having me. Thanks for everybody else who's joining. This should be a fun one, kind of different than the other ones we've been doing. But yeah, can you believe it's been 6 weeks of learning Azure SQL together? So this ought to be a very fun one today.
Yeah, I agree. And for people just tuning in, maybe for the first time, can you give folks a bit of a summary of kind of where we've been and where we're going?
It's good you asked that because you're going to talk about this, I believe, throughout today and at the end. You may have missed some of our previous episodes. You probably want to go back and watch those and learn. And we all started this journey 6 weeks ago describing what is Azure SQL. It's a branding, right, of a suite of cloud services for SQL in Azure, including Azure SQL Server, SQL Server and Azure Virtual Machine, Azure SQL Managed Instance, and then Azure SQL Database. And we talked about the various flavors of why would you pick one of those. It's kind of like a what to choose when type session and get you really familiar with the Azure ecosystem and all these type of capabilities of each of these Azure services. And then we went in like, hey, you got to set this thing up somehow. You got to install it first to use it. So deploying configuration. And remember, Anna, the whole idea was to kind of compare and contrast SQL Server experience to Azure SQL's experience. And so we had to cover the meat and potatoes, not in any particular order, but we started with security. Then we talked about performance. And then last week was a great session on availability. And then you got to wrap it all up somehow. How do you wrap up Azure SQL after 6 weeks? And so today is that, putting it all together. And Anna, especially, you might comment a little bit here, really interesting because it was your idea. It's like, how do we go bigger in the cloud? It's got to be something more than just migrating, right?
Yeah, definitely. And this is an exciting one. And this is one that's different from the other ones in the sense that we're really going to look to you all to engage with us. So, if you want to follow along or if you want to go access the module later, this is where you can access that module at the end of the session. But like I said, this session is the most engaging, the most interactive sessions of all our sessions. We have, Bob, you're not going to believe this. Hopefully you're going to like this, but we have 12 knowledge checks. So we have lots of questions which are going to spike discussion and help us understand what you've learned, help you understand what you've learned and feel validated that you really can put it all together. So this is going to be a really fun one. And then at the end, because we think we're going to have a little extra time, we have some awesome, cool demos. Bob, do you want to give a little sneak peek maybe so people stick around as to what we're doing at the end of this?
Well, first of all, once again, you've proven yourself to be the professor that everybody doesn't want to get when they go to college. 12 knowledge measures, super great. I'm sure there won't be any ways you're going to trip anybody up in these knowledge measures, of course. So everybody stay tuned for that because it's always fun to see how Anna tries to trick everyone in the knowledge measures. But seriously, those are great things because you need to kind of verify. And for us, it's really important to see, are you learning what we're teaching you? But yeah, and it's going to be pretty cool. There's some stuff, we've been doing this for a while, and there's some new things that are coming in Azure almost every month. So I've got something to show you about online migrations. That ought to be kind of fun. But I'm not the only one that has something new to show, I believe.
Yeah,
right?
it's true. I've got something that myself and a colleague have been working on that we can share parts of it today. So that'll be exciting as well. And then after all that, if you're still want to stick around with us, we will do kind of an AMA at the end. So we'll answer any questions you might have about SQL or Azure SQL. And I do want to encourage you all to head over to Learn TV. So that's aka.ms/LearnTV. And the reason for that is all these questions we're going to be doing, we have a very nice polling capability in Learn TV. If you're coming in from somewhere else like YouTube or Twitch, totally fine. Just put your answers in the chat. But if you come in through Learn TV, it makes it a little bit better of an experience. Okay, so all that being said, let's get started. So we're going to be talking about putting it all together. And really, when we thought about this, a while back when we were putting this all together, we said, it might be nice to have some scenarios based on real world customer stories or customer situations where we ask people who've been watching, how would you handle this scenario and what are some decisions you might make? And, in an in-person world, we'd have out whiteboards and we'd be walking around the room. And since it's not quite the world we live in, we're going to do it all virtually. So we have, like I mentioned, lots of questions to kind of evaluate what you think of these scenarios and their potential architectures. And on top of that, what we're going to challenge you to do is each scenario will have a hashtag associated with it. So a hashtag that you can use on Twitter or LinkedIn. So if you actually want to go forward and even go further in actually building some architecture diagrams or solutions, you can always tweet at us or use the hashtag on Twitter or LinkedIn, and we'll kind of share some of those good solutions with the rest of the community. So all that being said, we'll give you a ton of additional information. We'll give you lots of resources. We'll talk about some things that didn't quite fit into other modules, but we think is important for you to know. And then we'll give you a call to action, probably a few call to actions. But so busy day today. And so let's get right into this first scenario. So this scenario is about a global content delivery network or global CDN system. And the scenario is as follows. And Bob, try to pay attention because we're going to quiz you on, what you think stands out here. Yeah, you didn't know that.
Another quiz for Bob. I love it.
Yeah, this is a separate quiz specifically for you.
Okay.
Okay. So this scenario says Your customer is a provider for services and content delivery across the globe. They've requested your assistance in architecting a system that can handle thousands of writes per second to what is essentially an operational data mart. They also need to be able to perform real-time analytics on the data to determine trends, identify anomalies, and these things they're currently doing with SQL CLR. Now, they're not looking for a data warehouse, and they utilize large portions of the SQL surface area, but they need to be able to scale where their users live. So that's kind of like the big piece of this scenario. But then from a security perspective, they are trying to determine which authentication methods they should use in their hybrid environment. While the main solution and application is going to live in Azure, there's also 4 things you really need to think about. 1, an application on a non-Azure machine that is domain joined, a legacy application where they can't change the driver or the connection string on a non-Azure machine, multiple users that run reports from SQL admin tools on non-Azure machines that are not domain joined. So there's a few scenarios in there. And wherever possible, they obviously want to eliminate hard coding of passwords or secrets in the connection strings or the applications, and in tools where possible to enhance their authentication. So a lot of things going on. Bob, if you had to take a look at this, what are some things that kind of immediately stand out to you?
Yeah, thanks, Ed. I mean, I do like the way you broke this out because, quite frankly, correct me if I'm wrong here, but you kind of pulled some of these from actual situations where us or our field or somebody at Microsoft has worked with a customer. So I love the way you kind of organize this. The way I look at it in 2 paragraphs here. One is about capabilities I need that feels a little bit about like some scaling performance scenario, capabilities I need, maybe some regional requirements you have here. You have some requirements around, features that are required to use that may exist in one. I'm trying to think in my head in the first paragraph about the what to use when.
Right.
SQL and Azure VM, managed instance, Azure database. And I'm sure, knowing you would probably prefer us to be able to do a platform as a service scenario here. So, for example, one thing that sticks out to me already is that word globe, across the globe, like kind of it's a regional type thing. I always look for things like numbers, so thousands of writes per second kind of stand out to me. It's interesting you said that you don't need a warehouse, but you need some analytics using CLR. So I'm already thinking in terms, and I see the word SQL surface area. So I'm thinking in terms of, the SQL capabilities that I need that may exist in one choice versus the other, one Azure SQL offering, but I don't need a warehouse. So I'm probably going to be able to stick with, one of the ones that we have for Azure SQL. So that's that first paragraph sticks out. And the second one, it's interesting because, you might be given this, for example, you're a consultant or you are an architect and somebody hands this to you. Probably the best thing to do in the second one is to break it like in bullet points and highlight, here are different ways I've got to authenticate. That was the key. I need to be able to authenticate. And these are real world scenarios. So I would take a bullet point for each one of these and, figure out which goes with which, almost a table you could build, right? Of which solution I have and then what authentication is best suited for that. Of course, when you say I want to eliminate using passwords or eliminate hard coding, that's a requirement that I got to consider, when I'm making all those choices. So I have in the first paragraph, I have some capabilities that are really going to lead me towards which of that Azure SQL offering is best for this. And then the second paragraph, it's all about connecting together. What is the right authentication method for a given user, app, or tool that I need?
Definitely. And I forgot to mention this, but I did put together some hints that I kind of bolded some things, but
okay.
You hit most of them. So great job.
Oh, well, okay. Yeah. I had some of them that weren't bolded, but some of these are, right? Yeah. Okay. Yeah.
Exactly. These are just some things that stood out to me as well.
Okay.
So what we're going to do is we're going to do a lot of things at once. And let me see. So here it is. So here, what you're seeing on the screen is the scenario. Again, same scenario, exactly the same. You can see the hashtag. So if you want to submit anything via the hashtag, you can do that as well. We're going to do the first 3 questions, and then we'll go through them. And then we have 3 more questions that are really focused more on the security side of the thing. So what we're going to do is we're going to put up all these questions for you in the polls, but we can only pin 1 poll at a time. So we're basically going to give you some time to take a stab at identifying the answers to each of these questions, and then we'll go through them one by one. How does that sound, Bob?
Yeah, I think that makes sense.
Cool. Awesome. So let's just talk a little bit about what these questions are. And then if we have any questions coming in from any of our streaming platforms, we'll talk about some of those too. So like Bob mentioned, this first question is really going to be kind of your what to use when. So which deployment option of Azure SQL is going to be best for this scenario? The second question, it really gets into some of the things we talked about in Module 5 around availability. So how will they scale over multiple regions with multiple queries happening at the same time while isolating read workloads from write workloads? So really you need to think about your what to use when from the first module as well as availability in the fifth module. And then the third one, this is one that kind of goes back to the security module, module 3. So here I'm giving you guys some hints if you want to go look at Azure SQL Fundamentals to try to figure some of these out. But the third one is, which authentication method would you recommend for the application on an Azure virtual machine? So go ahead and take a stab at trying to understand what the answers to each of these questions are. I'm going to do a quick peek to see if we have any questions that have come in throughout. Let's see. Oh, it looks like we do actually have these 3 polls posted and people have started to answer. So great job. Keep answering those questions. Bob, when, just as a refresher for some people, and this is going to come up in our next set of questions, can you kind of talk to us about some of these different authentication methods? Maybe give a little tips or hints for those folks that might be not remembering, or this wasn't something we went super far deep into.
Well, I think part of the key is that Azure AD authentication is an option for you in many situations, right? The problem is that, like, if you think about that last option here about like a legacy type app that doesn't want to change stuff, that becomes more difficult because you have to change something to be able to connect to that. But a lot of these options, I think that the key thing for people to think of about is that you don't have to be in Azure to use Azure AD, right? That's all possible to use that. And so I like the idea, in my mind personally, as I'm looking at this, I keep seeing the word like live in Azure. To me, that's an, in Azure environment. And then I've got a non-Azure machine, a non-Azure machine, a non-Azure machine. So even in these non-Azure machine areas, I think Azure AD is a possibility. I just got to figure out what is the right way to authenticate, depending, like in some cases you said domain joined or not domain joined. And so that could dictate what option I have. But the key is Azure AD is an option in some of those scenarios. It's just, how do you combine that with our different, integration points with Azure AD? So I think one of these is probably going to need a SQL auth, scenario based on, eliminating hard coding or something of that nature. I think Azure AD can be an option for a lot of these. Just what combination do you pick, right?
Right. Awesome. Looks like we actually have a decent number of answers in for some of these questions.
Oh, okay.
Maybe we can at least take a stab at that first question.
Okay.
So I'm actually gonna leave this up so people can keep looking at the question, but then we'll go to it. We're focusing on the first question right now. So which is the best Azure SQL deployment option? So if you haven't answered that one, go ahead and answer it. If you're streaming in from Twitch or Twitter or YouTube, go ahead and add a comment of what you think the answer to the first question is. Now, Bob, can you kind of take us through the process for thinking about this question?
Sure. So make sure I've got this right here. So in the first one, I don't think it lists D, does it? Is that right? With the one that got pinned?
Oh, yeah, that's correct. Yeah.
Okay. Okay, just want to make sure. So it just shows A, B, and even though you show A, B, and C, and D, there's only A, B, and C choices for them, right?
Right.
Okay. So process elimination. We have to eliminate Azure SQL single database out of this because we need a large portion of the SQL surface area, including CLR. So already I know I need a managed instance here. I could use VM, but I would not say that is the best option for me because it's not platform as a service. It would work. But there'd be a lot of more effort, especially when it comes to this global thing you're talking about. You're talking about, like, I even missed the scale where users live. I didn't highlight that. But doing that would require a lot more work on your part for something like Azure VM. So to me, a managed instance is probably the best. Again, that was your question here. Which offers the best fit? It wasn't just what is a fit, it was the best fit. So it can't be database. To me, it would be B.
Yeah, and let me just go ahead to that one. And That is the correct answer.
Okay.
I think you hit it right on the head there. Really, the customer needs CLR, so Azure SQL Database isn't an option. For those of you coming in through Learn TV, Elastic Pools literally was not an option, but Elastic Pools is just a deployment option within Azure SQL Database. So if single database doesn't support CLR, neither is Elastic Pools.
Right.
And then, deciding between VM and MI, both are going to work. But when we talk about best fit, I think moving towards more of a platform as a service is going to be much handier, especially when we get into the next question, when we talk about scaling over multiple regions. So this next question we're going to answer. So we'll go ahead and pin question 2 to the top of your polls so you can see it handy. Please go ahead and answer that one if you haven't already. Or if you're streaming from somewhere else, just go ahead and put it in the chat. I have been seeing a few answers from other places like YouTube. So thanks for your responses. But this question is, how will they scale over multiple regions with multiple queries happening at the same time while isolating read workloads from write workloads? So this one's a little bit tricky. Bob, do you have any tips for people who haven't quite answered yet?
Well, you did use the word scale, regions, multiple queries, isolating read workloads, use several different things. You got to go back and think in terms of what we talked about. Scale wasn't just about region. It was about like thousands of writes per second. Remember that kind of type conversation? If you remember back to our discussion about what to choose when with different tiers, Business Critical gives you the best IO performance out of any of our options. So already in my head, I'm thinking in terms of eliminating A and B because I think I want that Business Critical capability, especially from IO performance. I suppose it's possible when you really dig into the requirements at a detailed level with a customer that general purpose might serve their needs, but my guess is Business Critical is what you need. So I'm down now to C and D personally because I've eliminated A and B. And then I think in terms of scaling where they live, ensuring that I isolate read workloads, even though geo-replication might be an option, I think auto failover groups is probably the better option because remember, it's auto. That's one of the key aspects to it. I do get that read replica, if I remember correctly, not only with Business Critical, it's another reason why Business Critical could be your best choice, right? I get that Business Critical read replica in my primary region. I also get it in the other region with auto failover groups. So a combination of scaling with the writes per second, a combination of getting those read replicas that I get in both scenarios, I probably would pick C.
Yeah, you are definitely right. And there was a little bit of a trick in here. Of course, I had to bring that in. But remember in the first question, we decided to go with Azure SQL Managed Instance. Now, for Azure SQL Managed Instance, we don't support geo-replication today. So once you pick Business Critical based on, I think if I go back, the scenario actually says they need thousands of write per second, real-time analytics. So I think, just like you, I think Business Critical is going to be a better solution for this. And then to get across to another region, auto failover groups is really the only simple option that they have there.
But there you go again, with your twist. Or your trick? Did you say it was tricky? Yeah, I think you said It was tricky. But you're 100% right. We did talk about that in the last module. That for managed instance auto failover groups, your only option.
Right. So good reminder.
Good reminder.
Not a trick, just a good reminder.
It's a trick. It's always a trick.
All right, and then the third question. So this would round out the first part of our scenario 1. Is which authentication method would you recommend for the application on an Azure VM? So for this one, like Bob mentioned earlier, you will have a few different options available, but you need to think about which is going to be the most viable for this solution. So go ahead and get your answers in for that one. Let's see. And I guess maybe a hint from me is that it is running on an Azure virtual machine. So that might simplify doing something that doesn't require passwords. Okay, so it looks like we have a good number of responses in. I've also seen a few, maybe a B and a D across other streaming platforms. So I think, Bob, you can go ahead and take it away.
Well, if this is a good one, because we did talk a little bit about this in some of our modules. I don't know how deep we really went into this topic, actually, to be honest with you. So I'm so glad we're covering this. And here's the great thing about this is that if you don't get this right, we document this pretty well about what would you pick in certain scenarios. But if you think about the fact that Anna had these different application and machines, this is the one that wasn't Azure, right? And you did say recommended way. So there could be multiple ways. But first of all, SQL auth, even though it could work, I'm trying to get away from passwords, as you just said. Remember, that was one of your requirements as much as possible. So just eliminate E out of the gate. Now I got these other options. And so what you're going to want to do at this point, in my personal opinion, is pick the simplest way to do this. And if you look at what's available in Azure, multi-factor authentication does work. But again, it's multi-factor authentication. So now somebody has that extra step of verifying this with something else. Integrated authentication is going to require a domain, right, to be able to do this. And you may or may not have that set up in Azure. Maybe you have a non-Azure machine, a domain, which was one of your examples. But in Azure VM, it could be very, very possible this is not a domain join Azure VM. So then it comes down. So let's just take away A for a second. So now I'm down to like B and D. As it turns out, this managed identity is a really cool concept in Azure that gives you the simplest way of getting going for a resource that's already in Azure with Azure AD. So for me, I'm probably going to pick D.
Yeah, definitely. And there were some good hints in there, Bob, for the rest of the question. So hopefully people were listening and paying attention. And if we look at the responses we got in, most of you said Azure AD authentication managed identity, although some of you also mentioned integrated authentication. And like Bob mentioned, in general, managed identities is going to be the recommendation for applications specifically that are running in Azure VM. So that's kind of where I rationalize it, which I think is very similar to what you said as well, Bob.
I agree.
Awesome. Okay, so now you got a taste of the what to use when, because you talked about an application on an Azure VM using managed identities. Now we're going to dive into 3 more questions specifically around how to authenticate. And again, like Bob mentioned, this is something we didn't spend a ton of time on in the live session, and so we think it's a good exercise to kind of go through, dive a little bit deeper, apply some of the things you did learn to this scenario. So the next 3 questions, take it just like before, take a few moments, try to come up with an answer to each of these questions. We're going to go ahead and put them all up, but we'll give you a few minutes to kind of answer them. And these questions are all about trying to figure out what the authentication method is. So for example, question 4 is going to be for an application on a non-Azure machine that is domain joined, so non-Azure but is domain joined. And the next is for SQL admin tool, so a user that's using SSMS or PowerShell on a non-Azure machine that is not domain joined. So a little different from the first scenario, because now you have a user using SSMS, SQL tools, and but they're not domain joined and not on Azure. And then the 6th one, and I think actually this one is either going to be really easy or it's going to trick a lot of you. This one is, which authentication method would you recommend for the application on the legacy application where you can't change the driver or connection string on the non-Azure machine? So these are some good questions. Take a few minutes to think about them. A few people have had some comments saying, thanks, Bob, for your explanation. So nice explanation, Bob, as well as great. We have an interesting question on Twitch that's not related to Azure SQL. And nothing on Lauren. It's actually an interesting little question, but not related to what we're talking about. So I'm going to skip that one.
Okay. But if it's about Baylor Bears basketball, I can answer those. I'm here today to answer those.
So certain sports questions are allowed in this in this Azure SQL discussion. We will allow sports conversations.
We will. We will allow that.
Other topics only at the discretion of us.
Right.
Okay. Let me take a look and see if we've gotten some responses in. And you guys, we have some time while we're answering these questions. So if people have other questions that they want us to answer during this time, feel free to just post it from wherever you're streaming from. We are looking at that to see that what you guys are thinking and what you guys are asking about.
And I just want to comment that I'm glad you're doing this, because this is real world. I mean, your customers out there are going to have every way you can think of in today's world where they haven't moved if you have everything to the cloud, which you won't, you said hybrid environment, this is a reality what's going to happen. You're going to be in a discussion with your customer, and they're going to say, well, hey, what about this? I've got this app over here in this domain joined environment that's not in Azure. What are you going to do about that, right? And for you to have preparation of what is the recommended way, what are the different options, what is possible, and you don't have to memorize these, but to have in your mind what is there and what's recommended, I think is a very, very, very valid approach, and it's real world.
Yeah, definitely. Yeah, I definitely think, and thank you. I'm glad you think these are useful and you're not
Absolutely.
upset about having to answer these
Well,
questions.
I mean, I didn't say they weren't tricky. I just think they're useful.
Okay, just for time's sake, I'm going to dive into this first question. So I'm just going to put it up. We're going to pin it on Microsoft Learn. Again, even if you're streaming from not Microsoft Learn, go ahead and put in the chat on Twitch, YouTube, Twitter, Periscope, wherever, what you think the answer to this question is. So specifically, this is an application on a non-Azure machine that is domain joined. And one sidebar here, we actually, we've used this internally as well. And we had an architect come back to us with this super awesome table that was like, if it's domain joined, if it's, I should have actually pulled that in here. But these are
what
things
I would recommend doing after this is all over. If you were doing with a client, I would have a table of this to say, okay, this one makes sense. And remember, it's not just important to say what's possible, what's recommended is the best and why.
Right. Yeah, exactly. Awesome. So let's go ahead. Let's take a look at this first question. We've gotten a decent number of responses.
Okay.
And it looks like on YouTube, we got a C and a D. And it looks like on Learn, we're getting mostly A's, but a few B's and a few D's. So we're kind of all over the place. So maybe we need some help.
Okay.
Why don't you take us through it?
Yeah, I mean, again, like we just talked about, remember the overall requirement you said, you would like to eliminate hard-coded passwords and so forth, right? So SQL Auth, I'm going to take that off the board here because it's even though it would work, this is the recommended way. So let's just take that. I'm eliminating that one, right? Plus, it's a non-Azure machine, and we just said managed identity is an Azure thing. You need to be in Azure. So let's take away D for a second now. Now I'm left with these last three. So multi-factor authentication could be a possibility, I suppose, here. But again, that requires a little more complexity. So even though it's a possibility, it probably wouldn't be recommended. That leaves me with the last two options. And so client ID certificate, I think that would work here actually, Anna, but I want the best option. And so since I'm domain joined, integrated authentication is a great way to do this. So that's what I would pick. I think A would probably be your best, again, the recommended way.
Definitely. Yeah, I would say A is the recommended and probably the easiest way, considering that you are domain joined. But you are correct in that the client ID and certificate is a way forward. You just have to create an application identity for your application in Azure Active Directory, and then go through that process of getting the certificate and the private token, all that good stuff. But yeah, integrated authentication is going to be the recommended approach there. And I think if I go back to the responses we got, all in all, that was the most answered response. But I think a few people, I think, honestly, Bob, I think the way you do that process of elimination is like, oh, well, they can't use this because of this. They could use this. Let's hold that. And then let's see what else they can use and all the options they can use. What's going to be the best one? I think that's a great
That's the best way to take an exam, isn't it?
It is. Yeah. You could go take the SAT and ace it, I
bet. Oh, gosh.
Okay. The last question for this scenario. Oh, wait, no, it's not.
I think you have two more, right?
Two more. Yeah. So, the second to last question, this is, same scenario. We're trying to minimize password usage, but this time we're trying to recommend authentication methods for accessing from SQL admin tools. So like SSMS, Azure PowerShell, Azure Data Studio, SQL CMD, all those SQL tools you know and love. How do we give folks access on non-Azure machines that are not domain joined? So think about those requirements and how they might play into what you're selecting.
Right.
So go ahead.
Are you starting to get some answers there?
Yeah, it looks like we've got a few answers coming in. Would love to see a few more answers from YouTube or Twitch or even Learn. So
Okay.
keep your answers in. But it looks like option C is winning. A few people have said E, which is SQL Auth, and a few people, maybe one or two people each, are saying Azure AD Auth using integrated or client ID or certificate.
Okay.
I think we can go ahead and probably take a stab at this one. We've kind of talked a lot about how to do these eliminations.
Well, let's eliminate D. Again, we did that last time. It's non-Azure machine, so we can't do that. Well, let's just get rid of that. It's a non-domain join, so I can't do A either. Remember what we just said? You have to be domain join machine to do A. So I'll get rid of A and D. I'm left with B, C, and E. That gets a little more interesting. If I'm not mistaken, with like say Management Studio or these tools, I can't do the client ID cert method. I have to be like an app that I can write to do that. I can't just use the tool. So I'm going to eliminate that one. Now I'm left with MFA and SQL Auth. So even though SQL Auth works here, remember we did say we'd like to eliminate the need to do that. So if I have an option to do that, I would prefer that. Would be my recommended ways. It turns out, like I'll just pick on SSMS, there is a way with SSMS to go in and choose in that when you connect. I think I know I've seen you do this before. Where you go in SSMS, you connect. You might have even shown that actually in one of the demos you did during our modules. You can pick MFA. Then you do that because you're Azure AD enabled. And then you would actually go through the MFA process, phone, whatever you have set up to do that. So for me, it's about the recommended way. So again, I'm keeping around C and E, but I think C would be recommended way.
Yep, I think that does it. And yeah, depending on your tool, this is supported. But like you said, SSMS supports this, ADS supports this.
Right.
Most of the SQL tools are going to support using MFA. With Azure AD. So great job to those of you that got that one. I'm just going to do a quick scan. It looks like a lot of people did get it. A lot of people got a little tripped up. I think, this is a new topic, a newer topic. And again, something we kind of didn't spend a ton of time on. So it just makes me feel a little bit more glad that we are talking about it. And hopefully as we've even just gone from questions 4 or 3 where they started talking about this topic, you can kind of see how Bob is using his other knowledge, like, oh, we have to eliminate managed identity because that's only for Azure VM. So you can kind of learn with us if this is a new topic for you. Awesome. So
one more, huh?
One more. So this is the last one in this scenario. There's another scenario, Bob. So don't think it's over. It's not over.
Wait, we're not done?
No, we're not done after this. But remembering that the goal was to eliminate passwords as much as possible.
Yes.
This question says, what do you recommend for an application on a legacy machine where you can't change the driver or connection strings? And obviously this is on a non-Azure machine.
Right.
So
yeah, go ahead.
Go ahead. I was just going to say, it looks like a lot of the answers, a lot of people, there's a few saying A, B, C, D, but a lot of people are saying E, which I find pretty interesting.
Well, I want to eliminate the need for that, but I'm going to use the process elimination again, and if that's okay.
Yeah.
Yeah. So, again, so non-Azure machine, so get rid of D, right? Now it doesn't say non-domain, but it says a legacy application. I'm assuming this is non-domained. Is that true, Anna? Non-domain machine,
Yes.
probably? Okay. So I got to get rid of A. So I can't do that one either. So now I'm left with what? B, C, and E. So here's the problem. I can't change the connection string. To do Azure AD Auth, which again, it's a legacy app. You didn't have that before, Azure AD Auth. You got to change the connection string to Azure AD Auth, unfortunately. So this is going to eliminate actually A, B, C, and D, unfortunately, right? We've already eliminated A and we eliminated D, but I now have eliminated B and C as well. So even though you want to try to eliminate the password scenario, easier only option here, not just a recommended option, it is the only option.
Yeah, and we've had some people, I'm just going to put up this slide that kind of walks through all the different options you could pick. And this is even identifying, whether or not you are domain joined or not. But we have had this question before about the legacy application where you can't change the connection string. If you can't change the connection string, Bob, and this is routed to like some local SQL server, how are you even going to connect to Azure SQL Database?
Well, with SQL, you have the ability to do like an alias. So you could be using an alias that you set up to redirect the app on the client machines to the new Azure SQL Server. So you still wouldn't have to change the server name or something of that nature. You could take that local server name, again, tie that to Azure, and then you'd be covered. So,
Gotcha.
But are you telling me that we just went through all of that?
Yeah.
And you had a visual slide that shows all of this? Is that true?
Yes, I held this back so we could go through the questions.
I know, I love it because we just went through a very, this paragraph description, all these different multiple choice questions, decisions, and some people are very visual. I'm a very visual person. I love this because it shows me a very real world scenario where my SQL deployment's in the cloud, but I could have all these different situations where apps and machines are both in Azure, not in Azure, and what is possible, but also what is recommended. So I like it.
Yeah, awesome. Thanks. Yeah, this is something we actually put together with the security team, something that they call the Azure SQL Security Best Practices Playbook. So that's a section in the Azure SQL documentation where they have a bunch of common security scenarios around Azure SQL Database, where you can go and kind of see what they've done in these scenarios that come up pretty often, like this one. How do I connect and how do I eliminate passwords? So fun fact there, inside look. Okay, so we have another scenario. Bob, do you think you're ready for more?
I don't know. I got to just look, I got to think about this with my head, right? So I don't get stumped here, but yes, go ahead. It's okay.
So, so this is the second scenario. There's only two scenarios. So if you're like, I'm out, I can't do this anymore, there's just one more scenario. This is it. And this one is for a mission critical application. So, let me just tell you about the scenario and then we'll have Bob go through some of the highlights that he sees from this. So let's assume you're hired to architect a mission critical cloud application that requires 99.995% availability because downtime might be life threatening. So you could think of this example, think of it like a 911 dispatch. So it really needs to be high performance and highly available because any delay in response can carry a high risk. Now, given the sensitivity of this, if we consider 911 dispatch, this personal or collected information or medical information, data sovereignty must be guaranteed. Now, your main mission is to ensure that the app is designed and deployed with appropriate data redundancy and fault resilience to meet the availability and data sovereignty goals. So you're going to be thinking a lot about the availability module from last week here. Now, additionally, mission critical cloud applications, especially like 911 dispatch we talked about, also stolen credit card, corporate security, they're concerned about protecting sensitive data, but they also need DBAs to be able to perform their jobs. This is a very common scenario, SQL Server and Azure SQL, but in this scenario, DBAs must not be able to see sensitive data stored in specific columns, and all access to tables containing sensitive data must be monitored. So you might need to classify this sensitive data. And at the same time, DBAs need to be able to troubleshoot performance using the Azure portal. So some of the things in the performance module that Bob showed you can do through the Azure portal, as well as SSMS and Azure Data Studio. And they also need to be able to create new contained database users who must be mapped to Azure AD principles. So there's a lot in here. I'm going to highlight a few things, but Bob, I'd love to get your take on what really stands out to you about this scenario.
Well, just like before, you broke it down into overall capabilities that the application needs, which is going to help dictate your choice, the what to use when choice, and even like a service tier choice potentially, right? Here, there's some performance discussions. I went right to the number, by the way. I'm a number guy, so I went right to that 4.5 nines thing. I'm like, okay, that eliminates a lot of stuff from a choice perspective that we have right now with Azure. Because again, you want probably not just that to work, you want us to back it up with our service level agreement, I'm guessing, because that's what's required. So if you're going to come to platforms of service, you want Microsoft to back that up. So there's a choice you're going to need to make there. The sovereignty thing, I did kind of did resonate with me, probably not as much as you highlighted right here. I did see, though, that you need to ensure the app is designed and deployed with appropriate redundancy and fault tolerance to meet both of these goals. So I'm thinking in terms of availability here and some sort of regional, capability I need to put into this whole thing. So that's kind of what stood out to me in the first one. And the second one's interesting. This wasn't about authentication as much as it was about information protection. But you also put at the very end there some comments about, I need the DBA to be able to do something both out and inside of Azure. So there's probably going to be some authorization that you've got to give them, which isn't necessarily how they're going to authenticate, but how are you going to give them access to Azure? Remember we talked about this before in security. How are you going to get access to things outside of Azure and then Azure SQL? And then what are you going to do inside of Azure SQL? So I see both an information protection comment there and kind of a authentication, or excuse me, an authorization that you've got to do on the second part.
Yeah, definitely. You definitely called out the highlights and things that we're going to be asking questions about. So hopefully that was useful to some users. Just like before, we're going to do the first 3 questions and we'll talk about them. We'll give you some time to answer these first 3 questions. We'll go through them, then we'll do the second 3 questions. And the first 3 questions are really focused on the what to use when, as well as the availability of this application and database. Now, while we are giving you time to answer these, actually, let me go through them real quick. The first question is quite simply, which Azure SQL deployment option makes the most sense here? And then the second question is asking about geo-redundancy and high availability. How are they going to achieve that? And the third question is talking about co-location. So this one you have to think a little bit carefully about. Now, we got a question in Learn TV, which I want to talk about because I know someone will answer, probably one of our wonderful moderators who are helping us answer this, our SMEs from our team. But I wanted to just kind of talk about this one because I think it's interesting. The question is, why, I'm going to paraphrase a little bit because I'm not sure I understand it, but I think what the person is asking is, why does accessing Azure SQL Database through SSMS using Azure Active Directory password or integrated never work? So this is a question that came in, I think is really interesting. Bob, do you have any thoughts on this? I also have some thoughts.
So, so the question is like, why won't integrated work with AD? Is that kind of why where would that not work?
Yes, I think the question specifically is like, I'm trying to access Azure SQL Database. I'm using integrated. I'm trying to use password and it's not working.
Okay, so integrated, the key about integrated, you have to be domain joined, right? So that's a requirement. If you're not domain joined, then that would never work. Then I suppose that if you are domain joined, there is an issue with your account in Azure AD that's been authorized to get access through, it's an Azure AD problem at that point based on your account. I don't know how you feel about it, but that's kind of how I'd look at it.
Yeah, definitely. I mean, like for me personally, like I have a demo virtual machine where I log into Azure SQL Database, sometimes as the Azure AD admin on an Azure SQL Database, and I can't log in with password. And that's because my organization has restricted me from using password only, right? So for that, I have to use MFA, and that's why MFA is the only option really, because this is an Azure virtual machine, but it's not domain joined, so I can't use integrated. So I thought that was an interesting question. So thanks.
Okay, so you were actually, in your case, it was more of a company policy, like in Microsoft, where you could technically put in your Azure AD and password, right? But we restrict that capability because that's not as secure as MFA. In other words, we're kind of forcing you. So you're not domain joined, so you could use integrated connection if you were domain joined, but we're going to force you to MFA because it's more secure, right?
Right. Yeah. And so that's an interesting place where your overall AD organization policies will have an effect here. So interesting. Okay. Cool. Okay. So let's see. Let's see what the questions are. Oh, we did have a comment from one of our regulars. I see John Askew said lots of questions.
Yeah, lots of knowledge measures today. Yes.
Yes, we want to really test your knowledge. Okay, let's go ahead and take a look at this first question, which is, which Azure SQL deployment option potentially offers the best fit for this solution? Bob, can you take us through that?
Sure. It's going to come right down to that 4.5 nines right out of the gate, right? And while in A, you might be able to find a way to do that, Anna. You personally could do this. We don't have an SLA for that. So you can't do A, right? And B, you can't do that either. There is no SLA for that. And we really don't need an elastic pool here. You did not mention any kind of need for that kind of type thing. Plus, I don't even think that is also part of the SLA for getting that 4.5 nines. So I think I'm going to need C. We don't specifically call out how you would do that. We can talk more about that, but I think C is going to have to be your best answer here.
Yeah, definitely. And I think if nothing else, it has to do with that SLA, like you mentioned. You can only get that SLA in Azure SQL Database today. But also, if you look back at the scenario, they didn't really mention anything about using instance scoped capabilities. So it's possible that they didn't really need those anyway. So this helps as well.
Absolutely.
Now, the second question was, so we're using Azure SQL Database, and it says, which option is the best for them to enable geo-redundancy and maintain high availability? Now, this question is kind of an interesting question, maybe subjective, especially given some new information or new releases we can talk about that happened recently. But if we talk about the best option or the easiest option, which option is it going to be?
I mean, for me, Anna, if you're thinking about this, and I just think about in my head about what we covered, it was actually in the last module. Both of these, could work, but you did call out an auto failover groups. The auto piece, that's pretty critical here. The fact that you're connecting through a given server, right, and then literally, if a failover is needed, you would fail over to the other region automatically. I think you called out that for geo-replication, you have to make a manual change to make that work. And so that would not be probably your best option there. There are some things that we've just released that might could help you, even things like DNS alias and so forth that we've talked about. But I think for me that B would be the best option.
Yeah, I would agree with you. And if we just take a look at what other people thought for this question, most people did also think auto failover groups is going to be the best. And again, that's just because when you deploy an auto failover group, we go ahead and give you something to connect to. So you connect to a name that's specific to the failover group, not specific to one of the Azure SQL Database logical servers. So when this failover happens or is required to happen, we can auto fail you over and you don't require any connection changes,
Right.
connection string changes. So that can help in keeping you more available. But maybe with DNS aliasing, like you were saying, like you could set up a similar system for your geo replicas, but I still think there would be a little bit of downtime during.
You still got to manually fail over.
Right. You still have to go decide that you're going to fail over.
Right.
Awesome. Yeah, that's a good question. Okay, so now for the third question, the last one in our first segment, what role does co-location play in this scenario? Looks like we've got a few answers in already. Go ahead and put your answers in. For all the people on Twitch and YouTube and Periscope, would love to see your answers as well in the chat. It looks like on Learn TV, we're getting a good amount of responses. Most people are saying B, so that's something to think about. A few people have said A and a few people have said C. So Bob, why don't you go ahead, take us through it?
Yeah, I'm thinking about the scenario now, right? So, you talked about data sovereignty, I believe, in this scenario a little bit, and availability that's needed. And we already said we're going to use an auto failover group, which, by the way, if I'm not mistaken, applies a different region that I'm going to have. So deploy to one region only can't apply here. Leveraging the auto failover group is great because it does give us what we need from a database perspective. But what if you built an Azure App Service application in, say, US East, and your auto failover group is, say, US West? And if the failover occurs in US East, the app itself could be not available in US East. So it seems to me to be as highly available as I need for this mission critical app, I better deploy the app as well in that region and have it set up so that if I fail over, the app will work in the region where the primary now is. Is that kind of how you see it?
Yeah, exactly. And this goes back to what we talked about near the end of Module 5 last week in availability, is that thinking about where your if your application is ready is almost just as important as thinking about the SLA and availability of your database. We actually have a little diagram that we have from, again, something else that was actually used in the real world. But basically, what the goal here was to achieve the 5 nines SLA. We wanted to create 2 fully redundant application, basically stamps in 2 separate regions. So that's kind of what you're seeing here. So you're seeing we're using zone redundancy in the business critical service tier. So that's going to enable us to have isolation across if there's a failover within an availability zone. So we kind of have that going for us. And then it's also going to give us that high availability in each region with the business critical service tier. You saw in module 5 how business critical fails over faster than, say, a general purpose database. Then we're going to deploy the database application, so the web application, like we talked about, in both regions. That's an important part of it. And for that, we can use Traffic Manager to basically probe and then decide, which app to point you to. And similarly, we can use a failover group, which is a little bit easier than setting up the application side. But for SQL DB, we can use a failover group, which allows you to have a read-write listener, like we talked about and you saw in module 5. And then we can also use some database monitoring logic. So that's what you're seeing in 5, this monitoring logic to basically make sure, like use a synthetic query to make sure that the database is available. And if it isn't, then go ahead and trigger up that failover for the applications. Now, one thing to consider is you do need to use regions that support availability zones for this solution. So something to think about, in the US, you might choose to use something like West US and East US. And now to test this, which is something you should do on occasion, you could actually activate a forced failover as part of the monitoring workflow. And you would also be able to see this RPO of 5 seconds and RTO of 30 seconds in this situation. Traffic managers are going to take care of detecting that outage and rerouting the application. So this is just one example of, something real world that was used with customers and how you can kind of see how they set this up to get the highest availability. So that's kind of the first part of our questions. Now, the second part goes a little bit more into data protection, as well as, like Bob mentioned, the ability to do something. So now we have 3 more questions. This is the last 3 knowledge check questions. Then we're going to do some other really cool stuff that you're not going to want to miss. But these last 3 questions are really about access and data protection and that sort of thing. So if I just go over the questions kind of briefly, the first question is, how can you ensure DBAs cannot see sensitive data stored in specific columns? So think carefully about this one. The next one is, how can you track access to tables containing sensitive data? So we talked about this in the security module a few weeks ago about different ways you can actually achieve this combination of results. And then the final questions is, how are DBAs going to be able to do the stuff they need to be able to do in the Azure portal, in SSMS, and also create new Azure AD principles. So think carefully about that one. And it's a little tricky. I'll just say it up front, Bob.
Of course it's tricky. I mean, right?
Yes.
But they're good questions. They're really good questions that are very real world based and are important for you to understand applying the concepts we've been teaching, right?
Exactly. Yeah. And we do have some questions. So again, just like before, go ahead and think about the answers to these questions. If you're streaming from not Learn TV, you can go ahead and put in the answers in Learn TV. You can also look for those questions. They should be posted now. But we did get a question on YouTube that I just wanted to kind of call out because it is an interesting question. I'm not sure we have the best answer for it, but this user says, this is not applicable. I'm assuming they're talking about the previous scenario. This is not applicable for a country which only has one region available, for example, Southeast Asia. So in that situation, Bob, do you have any guidance or tips on how to think about this?
What do you mean? So what do you mean by one region available?
Right. So, I would have to double check the documentation for this, but for example, I think what they're saying is let's say Southeast Asia only has one region Southeast Asia.
You mean, in other words, I can't do zone redundancy.
Right, or if I wanted to use an auto failover group, I have to pick another region. So
Right.
how do I do that?
Yeah, I mean, so, but that's the whole idea of auto failover group, right? In fact, geo-replication is allowed to be done inside your region, and people we've seen do that isn't just for redundancy; they get extra replicas from that, right? But auto failover group requires a different region, if I'm not mistaken, and so, but that's the whole idea. You're going to need to pick a different region so that you have that redundancy in a different region. Now, I don't know if zone redundancy is available in that specific region. I have to look it up in the documentation. So you don't get that specific capabilities, but you do get the ability to still do auto failover to a different region.
Correct. Yeah.
Is that how you're thinking about it, or?
Yeah, I think so. I think they still might potentially, like, if Southeast, and again, I'd have to look this up, but if Southeast Asia is the only region available, then where would their other region for auto failover groups go to maintain data redundancy or data residency?
You mean for sovereignty purposes?
Data sovereignty, yeah.
Yeah. So I did have one scenario come up that's really interesting to think about, where somebody could not use an auto failover group or even geo-replication because the data itself could not be in that other region for sovereignty reasons, right?
Right.
So, but in that particular case, it's more of a situation where the applications are controlling different sets of data. They don't need that replication of data to go across. What they need is a replication of schema to go across to keep that in sync. So you have to use something else. You have to use another technique from some application-based scenario to keep schemas in sync, but the data's separate anyways. It can't even be redundant. What's important there is just to make sure that you have other things set up so that your data is available, right? Whether it's, we have automatic backup set up and so forth, and those kind of type things, so that you have at least a HADR story. And remember, if you do something like business critical, we have separate replicas of your data, even in the same region. And remember that the data itself, even like in general purpose, is redundant in storage. So we have redundancies of data even within a region, even if you don't use availability zones, and even if you can't do a failover group.
Yeah, exactly. Yeah, I think that's a really great call out. So thank you. And thank you for the user who asked that question. I hope that answer kind of helps you. Okay, let's talk about these questions. So this first question is, how can you ensure DBAs cannot see sensitive data stored in specific columns? And it looks like most people, from what I'm seeing across platforms, have said A, but we did get a decent number of people saying C. Can you take us through that one, Bob?
Yeah, remember the concept here is that I want to ensure that a specific person can't access or see data in a column. So audit is not the answer, because that doesn't control access. That just allows you to audit access, right? Data classification is an interesting story. It allows you to tag things in columns, but it doesn't prevent anything. So there's no feature in classification say, oh, I'm tagging this as a GDPR column, and I won't let somebody see it just through that feature, right? Now, dynamic data masking is interesting. That's going to leave me C and D left right now. So dynamic data masking is interesting, because the whole idea is to mask looking at data from a SQL perspective, even if you run a SQL query or an app or so forth. But typically DBAs are the ones controlling the masks and the permissions to the masks. So they typically can see that. The only way to do this is C, because remember about always encrypted. Always encrypted is specifically designed for this separation, where the business owners or the app owners are the one controlling encryption, not the DBA. So I would say C.
Awesome. Yep, that is true. And yeah, some people might get tripped up by dynamic data masking, but I think you covered why that won't work, right? Good job. Okay, so this next question is, how can you track access to tables containing sensitive data? And for this one, we have more people saying A than C, but pretty split between that one. And then we also, I was just looking on other streaming platforms, looks like we also have a few A's there as well. Bob, you want to take us through this one? I think it's a little bit easier than the other one.
Yeah, I mean, so it's not going to be B, because B has nothing to do with tracking. This is just setting up, classifying your data or masking data. So let's eliminate that. It can't be D either, even though audit allows you to audit stuff. It is not a way to track specifically access to tables containing sensitive data. So I'm left with A and C. And dynamic data masking, even though you may consider that sensitive data, there's no classification system for masking. It's just you doing a mask. So that leaves A to be the answer. You classify your data, and then because you classify it using our classification techniques, you for free, auditing will tell you somebody touched one of those things you classified.
Yeah, exactly. And there's a really interesting exercise. If you haven't gone through all the exercises for Azure SQL Fundamentals, recommend doing so. But in the third security module, there's an interesting exercise where you actually use SQL audit, data classification, and dynamic data masking all together to kind of provide this solution around tracking access, masking, and auditing, and tracking the sensitive data access as well.
Right.
Now the final question, so drum roll, like the only question left in the series before we get on to some other topics is how can you allow DBAs to be able to troubleshoot performance via the Azure portal and SSMS and create new contained database users with Azure AD principles? Now this one is a tricky one. So most people said C. A few people actually said D. So Bob, why don't you take us through what you think?
Sure. So if I read this right, you need access to the portal to do something and to SSMS, and you need to be able to have access to go in and create actual users, right? You need all of those capabilities. So just by looking at this, Azure AD groups are interesting because I can use Azure AD groups to give me some other thing. RBAC is going to give me access. I can take RBAC, for example, and assign that to an Azure user to get access in the portal to do something. And then I can use a combination of those. But none of these gave any hint in here about giving access to the SQL auth required to do this, to log into SSMS, and especially that admin right to go in and create these users. So once again, Anna, here you are tricking the world. Unfortunately, the answer to me has got to be D.
Yeah, that's exactly right. Because basically what you would need to do is create an Azure AD group, maybe called SQL DBA, for the DBAs on the respective instance. And then you could assign the group to the Azure RBAC role SQL Server contributor. That's going to help them see stuff in the Azure portal. And then finally, you need to set the whole Azure AD group to be the Azure AD admin. And that's the only way any of them are going to be able to do things like create new Azure AD principles. So kind of a lot going on in that situation. Have a little diagram here that talks about preventing DBA access to sensitive data. So we're seeing some of those things like we saw in the other questions, like we're tagging sensitive data with data classification. This is kind of a good review. We're also encrypting data with always encrypted. We're auditing to log analytics so we can see kind of what's going on using Kusto query language or KQL. And then you're seeing some of that scenario about the SQL DBA group that's then able to not only have the Azure RBAC role, but also the Active Directory admin to create new users. So a lot of scenarios, but hopefully this was useful to viewers to actually putting their knowledge that they've learned throughout Azure SQL Fundamentals to the test. What do you think, Bob?
No, I think it's important. I mean, there was a lot of knowledge checks. But think about what we're doing. We are trying to put the entire thing together for you. And some of it may have felt to those of you paying attention here or watching us a little detailed, hyper-focused, right? But it's important because we want you, and again, Anna, you said this at the very beginning, people have gone through all of our modules, including this one, and passed certification, like the DP300 certification exam. And some of this stuff that's in this module is actually needed to be able to do that.
Yeah, exactly. And, we're going to switch gears a little bit. We've talked about the scenarios. I also mentioned there were some things that I met with Bob about, and he was like, hey, we got to talk about this. It doesn't exactly fit in the meat and potatoes. So Bob, can you talk about, what else should people know when they look at Azure SQL?
This is the classic hyper-focusedness of our project together. Anna, the funny backstory, if you remember, was we had a OneNote that we used to design this course. And boy, by the end of this thing was huge with all sorts of notes and comments. And then towards the end of our discussion, I showed you a OneNote tab and I said, Anna, what about this stuff? And you go, what stuff? You've already covered so much stuff. And I'm like, no, just a little more that I want to talk about because hyper-focusedness, right? So it starts with job management. We have folks today that use SQL Server Agent to do job management for many different things. backing up databases, maintaining indexes, all sorts of really cool stuff, right? And for managed instance, SQL Server Agent in its full glory exists there, right? So that's there. SQL Server Agents in managed instance, and it's a great migration store for you. Take your agent jobs, be able to pull those into managed instance. Unfortunately for SQL Database, since it's really not an instance, agent doesn't exist there, but there's a really cool thing called Elastic Jobs. And it's meant for helping you with Elastic databases and, Elastic pools and so forth, but it can be used outside of that. And in fact, in the book, Anna, Azure SQL Revealed, I showed an example of going through and rebuilding indexes across 10 databases at the same time. Using Elastic Jobs as a service, you get to build like these jobs that are T-SQL based. So you get to connect to your Azure SQL database, and Elastic Jobs comes with a database that you point it to. Think of that as like your MSDB to schedule a job. So that's pretty cool. Also, there's something pretty powerful called Azure Automation with something called runbooks. So with PowerShell and various things like that, you could build a schedule of tasks to do things in the cloud. And this is really nice, Anna, because this is kind of like serverless, right? You are going through with either agent, Elastic Jobs, or automation, and you're not actually building another VM to do all this work. We will provide all the compute for you. You just declare what you want to do. So there's different ways you can do job management, and a lot of times those are combined with things to do with SQL type activities. But there's other SQL Server capabilities that are interesting for you to note. So SQL 19 has this really cool thing called Polybase, and we don't have that full capability in PAS yet. But people, you may not realize this, but you could do an external table, something like you could do in Polybase, and you can do that across Azure SQL databases, or even into a serverless SQL pool in Synapse, which is a really interesting scenario where you can effectively, you're building like a cross database type query to another Azure SQL database or to serverless. Now we have the full, not the full, but the link server capabilities for SQL based providers exist in managed instance. And then look at the different options here. So you can do link servers to Azure SQL VM database instance, a SQL server, or even to Azure Synapse SQL pools themselves. And so other things exist on here that are surface level things you should know about. We've kind of mentioned some of these, but if you didn't know Database Mail, and now Service Broker, I think there's a new announcement on that, Service Broker across managed instances for Service Broker applications. We've had some customers come to us and say, look, I need Service Broker. I'm relying on this. And managed instance is going to give you those capabilities. And then full text search is interesting. It's been in the product for a very long period of time. But if you haven't looked at the Azure Search integration, specifically, especially with Azure SQL Database, that's a really cool concept. So don't just say, hey, I just need to keep full text search going. You might go further with the cloud and use this Azure Search integration. It's pretty powerful. There are other cognitive services capabilities with Azure Search that you wouldn't get from SQL full text search. Now, we just announced general availability for Azure for machine learning services with R and Python in managed instance. And I think you even had a data exposed episode not long ago where we showed off those capabilities and why that's a great story for you in the cloud. Distributed transactions are an interesting one. And for a while, we did not have this capability except for Azure VM. In fact, that was a reason why you had to use VM. But now you can do that in preview and managed instance across Azure managed instances. I mentioned the XP command shell is not supported only because some people are relying on that capability in SQL Server today. But, Anna, every time I've talked to a customer about this, I said to them, hey, I know so many people that just turn this off because it is kind of a surface level attack vector for your SQL Server. So we don't support that, and I don't envision us supporting that in a platform as service environment anytime soon. And then this is really interesting. Database migration service is out there today as an Azure service. We have this new capability called log replay service to do an online migration. And I'd like to show you that to you here in a second. But first, let me just also mention that we talked about this a little bit throughout our other modules here, but there are some new errors unique to Azure that are not in SQL Server, and we've got a hyperlink. You can go find it. You can just do a search. You can just look at error handling in Azure SQL, and we will show you some of those examples. And we've talked about some of those. So remember we said that if your gateway's up but your database is unavailable, you might get a different error than you would like in SQL Server when you can't connect. Or you might have run into the maximum number of sessions in Azure SQL Database, which isn't a thread pool wait now, it's an actual error. So there's new errors that you need to handle in your application, and we talk about those. The good news, Anna, is that it's not an exhaustive list, but there's some specifically you need to think about in a platform as a service environment. And then this is really interesting because I've had this question before. Customers are like, look, I used to get like this thing called a stack dump. And Anna, I've been across the world actually sometimes showing stack dumps on stage with debuggers and so forth. And often you take the stack dump and you contact Microsoft support and they will help you with this. But guess what? In Azure SQL, you don't have access to those, but that's a good thing. In fact, we monitor for these things behind the scenes and decide whether it should cause a failover. But then we look for these all the time, and we're always diagnosing, should we fix this proactively, which is that great benefit of versionless.
Yeah, definitely. This is a great list, and Bob, we have a little bit of time left, so I would love to see this demo of migrating to MI with LRS, and this is something I haven't actually seen before. So.
Oh, okay. Well, let's show it off. It's pretty cool. So let me share my screen, and you tell me if you can see this okay here.
Yes, I can see it.
So here's my goal. I've got a SQL 16 Azure VM going. So one of the cool things about log replay service is, let's say you're already in the cloud with Azure VM, but you would like to migrate online to managed instance. So your backups are already at Azure storage. Why not just take advantage of that and just access those things and migrate for you with a few PowerShell commands to your managed instance online? So to quickly kind of demonstrate this, what I'm going to do is I'm going to go ahead and back up a full version of my database. I don't know how that name got in there, the name of the database. I don't know who created that. Oh, I know. It's because that school just won the national championship in basketball. So in case you haven't heard about that before, that's why that's there. So I'm going to back up the database, notice, to an Azure Blob Storage container. So I'm going to do that. And then let me flip over to the Cloud Shell and show you what I've got here. I've got a PowerShell command like this. And let's kind of look at this a little bit here. I'm going to use this is in preview now, a new PowerShell command called log replay here. And what I'm going to do is I'm going to say, hey, here's where the database backup is. Here's where I'm putting that database. And I've got a SAS token for security reasons, so I can get access to it. But notice I say autocomplete, restore. And then I say, here's the name of the backup to look for so you can complete the online migration. So I'm going to start this. Let me just kick this in. And let's just make sure we understand what's going on here. It's like running as a job now. So what's happening is the log replay service behind the scenes, because you told it to, is going to go to your Azure Blob Storage. And we gave it credentials here with this shared access signature. So it's going to go to this Azure container. It's going to grab that full backup that you've done. It's going to restore it for you in Azure SQL Managed Instance. Okay, it's going to start that process. Now your database is going to be in the restoring state. So you're asking yourself, well, how do I do an online migration? Well, you could be making changes to this 2016 database, and then you want to do that final log backup, like your tail of the log backup. In this particular case, though, I'm telling log replay, when you see this backup show up in that container, that means I'm done. So you automatically pick that up, restore it, and put me online. So let's go see in the portal if we can see what that looks like. Well, first of all, here's where my backups exist. So this is that Azure storage where the backups are. And so then I'm going to go over here. Let's go. Yeah, sorry. I had it right there. So you see here, it says that the database is in the restoring state. So what I'll just do is let me go over here back to the 16 VM. And let's just do a log backup. I'm not going to make any changes, but I'm just testing this out to see this work. So I'm going to do a log backup to the same container, but I'm going to use that name that I said was the one to monitor for. So when I do this, the whole idea of being in the portal is that when the log replay service is monitoring this, is that when it detects that this log backup is here, it's going to restore it and then bring the database online with recovery, because right now it's in what's called no recovery mode, where you can't access it because it's restoring. But again, I don't need it until I'm ready to cut over. So this is kind of like this auto cutover capability. So let's go back over here and let's see here. So this is where, in this particular case, when the log replay service is able to restore the log, it can do this and just bring this database online, and think of this as being like the online cutover. But I'm just testing this. This isn't really about production. So let me flip back over and show you more of that experience. So what I've got now is I've got like 10 databases over here. You see this, like 10 databases. My goal is to go restore those in parallel and then do an online cutover in parallel for all these databases. So I will back these up with one script. I mean, you might have different ways of doing this, But notice here I'm using different folders. They're called like virtual folders within the container. So I'm going to run all of these, and they're going to back up all these databases, to this container in these different folders. So in PowerShell, I'll do something just a little bit different here than I did before. Let me get over to that. So in PowerShell, I've got a different script here called start ls_prod or ls_prod.powershell. Now what I'm going to do here is I'm going to use the power of as PowerShell, but this log replay gives me the ability to run this as a job. Now this is not autocomplete. This just says go restore this. In fact, let me just kick it off actually. Start ls_prod. And you might see this state of not started, but that's actually not 100% true. It's all running asynchronously in parallel. All 10 of these databases are being restored at the same time because they all exist out there in Azure Storage in these different folders. That's part of the requirement, is that you must be in different folders. So you told, with 10 different PowerShell commands, you told it, hey, go get this started. And then once this is started, this is where you're going to control the cutover a little differently. You're going to back up your logs, and then you're going to tell log replay, hey, I'm done. You complete it yourself. In fact, let's just kind of go back into the portal a little bit here and see. Let me get here. So now can you see this, Anna? You can see that this has come online.
Okay.
Yeah, this one's already come online that I did, and these other ones are in this restoring state now automatically. So now you make changes, but you say, I would like to bring all of them online in parallel. So I'm going to go back over to my 16, and I'm going to go back up a tail of the log for all the databases. So let this run. And then when this is done, I'm going to go back over into the Cloud Shell. Let's do that. The Azure Cloud Shell. Let's go back over here. And I've got a different script to complete this. So let's go ahead and run this, and we'll take a look at it. Complete lrs_prod.ps1. Let's run it. Now this is a little bit different. The completion doesn't have this as job parameter, so I'm doing something interesting. I'll show you an example of one of these. I'm using the power of PowerShell jobs. So this complete LRS just calls a bunch of different scripts, and one of them looks like this. I'm going to actually run this right here, this complete, but I'm running it as separately as an Azure job. Well, how does that? What do you mean by that, Bob? Well, if you look at this over, notice I'm using the start job commandlet for PowerShell. And so this is each script. And again, back to the script, notice here, there's a separate command here called complete Azure log replay. And then here's the name of the log backup. So it's not been listening for this log backup. I'm telling it when I'm ready to cut over, that is the last log back I'm going to do. When you see that, you restore it and you bring it online automatically for me. So if I go back over here, let's just kind of see if we can see the behavior. And you see they're they're all effectively in the restoring state. But now they're all there they go. The magic of the cloud. So everybody's online now. So think about what I did. I took 10 databases. By the way, we can do up to 100. This is during preview right now. We can do up to 100 of these. I can say, hey, I'm going to put all these in a container with folders. I'm going to tell you where they are. You put them in the restoring state. I'm going to go over and continue to use my Azure VM, make all the changes. When I'm ready for a cutover, it's pretty fast. I just say, hey, here are my last log backups. You do the cutover. And within, you can saw here with less than a minute, I'm up and all online with an online migration. So it's a perfect example of doing an online migration, especially from that Azure VM to managed instance situation.
Awesome. Thanks, Bob. That was really cool. I actually had not seen that before. Really cool. I'm going to have to go play with it. And I can do that because it's available in preview. So I'll definitely be checking that out. We have about 10 minutes left. We wanted to talk a little bit about, okay, now I've learned how to translate my skills from SQL Server to Azure SQL. You even got a bonus tip from Bob on how to migrate potentially to managed instance with LRS. But we want to let you know that, once you move to the cloud, it's not just SQL Server in the cloud, but everything else that Azure has to offer. So there's all sorts of different services that you can integrate in, regardless of your industry or your scenario. There's going to be various solutions and pieces that, if you were to go build these in-house, you would take a very, very long time. So we have some examples, but, translating from SQL Server to Azure SQL is really just the kickoff point, really, to me. We're really just scratching the surface on what Azure itself has to offer as a whole. And we have some scenarios, for example, Bob, I think you found this scenario online.
Think about, Anna, in your environment today, if you're in your data center or your company, you had to go build that right there. Somebody said, go build an IoT application. And by the way, make sure you include Azure ID authentication, stream analytics processing. Oh, can you do some machine learning with it? And can you put a logic app into it and do some reporting on it, right? All that kind of stuff.
Right.
This would be hard. So you might have the SQL Server part figured out, but other parts are going to require a lot of different software you have to install, purchase, et cetera. All this is possible in Azure. So you see SQL Database being the warm path store for this in this scenario right here. But doing all this is possible in the cloud. And Anna, some of this is serverless things, right? Like the function app or the logic app. You don't provision a VM. Azure Database, you don't provision a VM. In fact, actually, now that I think about it, this is all server. When I say the word serverless, I mean, you're not provisioning a VM here. You're just saying and declaring, I'd like an IoT hub. I'd like a function app. I'd like a database. Give me some storage. I'd like to build a machine learning app and a logic app. Oh, by the way, I'd like to process stream analytics on it. And then I'd like to go do reporting with Power BI. Incredibly cool, Anna. But I tell you what, though, and we have a GitHub example that you can go look at. If you just go search up IoT example Azure, we have a GitHub that you can see the code example. But I think you've been working on something that kind of shows the story of Azure SQL Database. That's real?
Yeah, I would love to give a sneak peek of this new thing that I've been working on with Davide Mauri around catching the bus. So let me just switch over to that quickly. So what you're seeing here is the sample. So this is live today. I put the link in the slide, which I'll go back to. But basically the idea of this application was to build a serverless full stack application where we just happen to leverage Azure SQL. So what you're seeing here is we're going to be collecting real-time data from an IoT device in the buses. Specifically, we looked at the Seattle metro area. So we're getting real-time data in the form of JSON, and we're using Azure Functions, which are also a serverless. We're using those with a combination of Azure Logic Apps to send notifications to users when their bus is near their geofence, or say, near their office building or where they want to catch the bus from. And they send that via Outlook. And this was all very easy to develop using Azure. And I'll also add that supporting this whole backbone is really Azure SQL Database, because Azure SQL Database supports JSON, supports geospatial queries. So all this was easy to do because of the power of the SQL engine that all of our viewers already know. It's just a matter of piecing these things together. We brought the route reference data in so we could associate these two things together. And then we use an Azure Static Web App, all powered by GitHub Actions, to deploy a website. So I'll give you guys a sneak peek at what this looks like. But then I'd love for you guys to check it out. So this is my Azure Static Web App, which basically combines the power of Azure Web App Services with Azure Functions. So you'll also see my Azure Web App has Azure Functions associated with it as well. And then this is my actual application. So if I come in here, I'm just gonna go ahead and refresh it. And what you're gonna see, here we go. So what you're going to see, all these circles, I can zoom in a little further, all these circles are buses on the route I'm monitoring. And this geofence represents where I want to catch the bus. So where I want to be notified that the bus is coming so I can catch it. So now I have a web page so I can track when my bus is getting close by. And then I also have this Azure function, which is doing all of that stuff for me. So for example, it's seeing, okay, we have 466 buses, but only 5 of them is in the route that you actually care about. So that's great. And if one, let's see, this has been running for a while. If one, here's a good example. If one is activating or entering or exiting a geofence, what we're going to do is we're going to call a logic app giving that information about the vehicle and the route and whether or not it's entering or exiting that geofence. So now that we have that, let me see. Let me refresh my inbox. What we will hopefully see is that we have some emails here, since we have been, oh, sure enough, yep, we got some here. And you'll be able to see when your bus is entering or exiting the geofence. And if this would load, there would also be some email text. We're just gonna keep on going. Now, what I wanted to also stress is that all of this, here, All of this is being powered by GitHub Actions, which means, for example, if we look at my Azure SQL Database GitHub Actions, whenever I update my database, that schema is actually being updated by Azure SQL Actions. So it's going to look at my database. It's going to analyze my existing database. It's going to update the database as needed and then publish that updated database. So this is the way I can deploy updated schema to my databases in my environment. And of course, we also have these available for Azure Static Web Apps and Azure Functions. And even when things go wrong, you can troubleshoot them. So all of this is surfaced in this serverless sample here. So if I go back here, that's where you can find that aka.ms/catch-the-bus. But just one of the ways you can really take advantage of all that Azure has to offer. Now, we have just a few minutes left. I'm going to kind of go through some resources pretty briefly. You've seen these resources week after week, but we definitely recommend you check them all out and stay connected with us. And Bob, I think you have a final call to action for our viewers.
Yeah, if you've seen what we've talked about in all these 6 weeks, I don't think there's an excuse not to try this. You have a free sandbox to go try out Azure, right? We talked about our learning path. But you know what? Pick a workload, pick something small, go to the what to use when scenarios that we even talked about, authentication methods and all those different things. You can kind of get a feel for how do you deploy and use Azure SQL. And then do a proof of concept, right? A lot of people forget that they have like toolboxes of scripts and things in nature that help them maintain and use their SQL server. Make sure you try and test all those out in your Azure SQL deployment. But I know it sounds like it's just a test thing, but it's not. It is ready for you. We have great case studies of customers in very large production scenarios with large databases, large number of users, mission critical applications, gaming platforms, you name it, that are using Azure SQL today, which is why we call it the world's database. So I'm pretty excited that somebody could go through this 6-week series, could get going, but here's our call to action for you to get started once you've picked up and gained your knowledge.
Yeah, I think it's a great call to action that Azure is ready for you. If you happen to miss any of these sessions or you want to study and go past DP300, which we encourage all of you to do, you can go to aka.ms.learnlive/learn live to see our previous episodes all throughout the series. And Learn Live doesn't end with us. I mean, I know you wish it was just us that came on every Monday, but the next series is really interesting. You saw a sneak peek of GitHub Actions, and we have a whole series dedicated to learning more about Git. So I definitely recommend this. It's definitely a way towards CI/CD and managing code in the future. I also wanted to call out this event that we're doing called Innovate today with Azure SQL. Bob, do you want to tell people just a tiny bit about what this is? Because I know you're involved.
I'm kind of involved with this. You might see me show up in this as your host for this event. Hey, want to hear from Rohan Kumar, our corporate vice president, about Azure SQL, how important it is? A surprise guest may show up. I think some other people that you may know may show up and doing some demonstrations as well. And then we have people like myself and others from the engineering team. We have the MVPs from the SQL community, video testimonies from Microsoft mechanics with customers. We have it all. A lot more details about stuff we've talked about in our fundamentals and learning path and more. So stay tuned. I think it's going to be one of the largest digital events we've ever done on this topic.
I'm looking forward to it. You know, just to wrap this up, we want to thank you all so much for spending your time with us. We know you have a choice of where you spend your time. We appreciate you spend it with us. We hope it was useful. Please let us know. Please like, subscribe, add a comment, whatever. We're just so happy and thank you. And we'll see you next week. Well, not us, but someone else will see you next week on Learn Live.
Thanks again, everybody.